need is the max. So this, just get your A, your B, and your C values, substitute the quadratic formula, or get the factors and then get the answers for X. Then for the second part, create the standard form first. So it's 3x squared. Okay, what's happening? I say 3x squared minus 17x, okay, plus 8 is equal to 0. And then you can go on to solve. And then with the inequalities, you need to pay attention to the A value, okay, whereby if the A is positive, and then the symbol of the inequality is greater or equal to, then your solutions must be X is less than the smaller value, X is greater than the big value, okay? And then if the A is positive, and then the inequality is less or equal to, then the small value is less or equal to X, less or equal to the big value. So just pay attention to the sign and the direction. Okay, 1.2, these are exponents. So with exponents, just make sure that the bases are the same. Since these are exponential equations, make sure the bases are the same. Express a 4 in a base of 2. In this case, they just want you to show that. Then simultaneous equations, remember, we always have a linear equation, okay? Which you call maybe equation 1, and then you call this equation 2, and then you just do the substitution. That is to do with the simultaneous equations. They carry quite a lot of marks. So and so on and so forth. So that would be question number 1. Then let's look at this other one. Probably let's just snip into it and see how a question 1 would look like. Okay, here we go. So in this case where you have brackets and then they're asking you to solve for X, we don't necessarily have to open up the brackets, just use the dot product where X minus 7 is equal to 0 or X plus 4 is equal to 0 and then solve the values. Or alternatively, just get these numbers and then switch the signs. So X is 7 and X is negative 4, something like that. Then in this case, where the question comes with a condition of 2 decimal places, that is the quadratic formula. Then 1.1.3, where we say the sides. You know, you square both sides, get the values, get a quadratic, and get your answers. Then those answers, we need to test them on the left-hand side of the original expression, and then on the right-hand side. So if we get a scenario whereby we get the same answers on the left and on the right, then that value will be a solution. And then if we get an answer that does not give us the same value on the left and the right, we just cancel it out. Or you can just say not applicable or no solution, something of the sort. 1.1.4, create a standard solution or the standard equation. You move the 4 that side and then you solve that. For 1.2, it's a simultaneous equation, a 3x, a y, a 5, and all of that. So we have the linear and then we have the quadratic equation. So start with the linear, manipulate it around. Make one of the variables the subject. So you can leave y on one side, move the x that side, and then get that y, substitute into there. Then 1.3, calculate. So the square root with these exponents. So in such a case, break down the bases to just the smallest base, and then do the factorization since we have a plus. So when you have a plus or a minus with exponents, factorization is always a must. So that is how the question 1 would look like. Okay, then I'm moving on to the second part, which is normally the sequences and series, number patterns. So number patterns, sequences, and series. So what they tell us that the sequence of the first difference of a quadratic is always a linear pattern. Therefore, knowledge of linear patterns can be tested in the context of what we call the quadratic patterns. Then recursive patterns, we're not going to ask you about that. Then we must link between the patterns that were done in earlier grades. And so remember, guys, that when we talk about number patterns, we have what we call the arithmetic, okay? We have the geometric, and then we have the quadratic. What is important with all the 3 is that we need to know what their Tn's are, the nth terms, okay? The a plus n minus 1 into d, the AR n minus 1, and then the AN squares, the BN, and then the C. So all these need to be known, whereby A represents the first term for the first two, and then N is the position, and then D, in this case, is the common difference. In this case, R becomes the common ratio. Okay. Then when you're dealing with, let's say, the quadratic, we need to remember the 2A, the 3A plus B, the A plus B plus C. We need to use those expressions. Then okay, so the other thing that we need to remember is also the sum. Okay, we need to know our formulas. Sum of an arithmetic is n over 2 into 2a plus n minus 1 into d. For the geometric, we need to know that it is a into 1 minus r to the exponent of n over 1 minus r. And then lastly, we need to know the sum to infinity, a over 1 minus r. So this we need to know, and how to apply them is also important. Then the other thing about the sums is, let's say you're given the sum of maybe n squared plus n. The sum of any pattern or sequence or series is given as n squared plus n. Then they ask you to use this to determine, let's say, the pattern itself. And so we know that S1, that will be the sum of the first term, is always equal to T1. Replace n with a 1. You're going to have something like 1 squared is 1 plus 1, that's a 2. Then for us to get S2, the sum of the first two terms, that will be 2 squared, 4 plus 2, that's a 6. So what I need us to know is the link between the sum of the terms and then the term themselves. What this means that for us to get, let's say, the second term, you must get the sum of the first two terms minus the sum of the first term. For us to get T3, we shall get the sum of the first three terms minus the sum of the first two. But what we know is that T1 is equal to S1. Okay, so what this means is that T of n is equal to S of n minus S of n minus 1. For us to get term 3, you must get the sum of the first 3 minus the sum of the first 2. So this is also possible. Okay, so we have the sums to infinity, arithmetic, geometric, and all of that. So R is the common ratio, A is the first term, and then we're good to go. Okay, so that is how these geometric patterns and series can be asked. But then we also have what we call the converging series. Okay, converging series. We need to know this as well. So for series to converge, there is a condition that -1 must be less than R, must be less than 1. In other words, the ratio must be between the intervals. But in most cases, the ratio that is given is in terms of other variables, maybe P, X, and so on. And then we need to work that out. So if, let's say, we have 2x minus 1 as our common ratio, if we put it within this interval, and then we solve for the x, you move the -1 to either sides, it's going to be a plus 2 that side. And then this side is going to be a 0, is less than 2x. Divide through by 2, 0 is less than x, and then is less than, let's say, 1. So this is the interval within which that sequence, that imaginary sequence of ours will converge when R, or when the common ratio is between those values. So that we need to remember. So that is to converge. That means the series will just become smaller, smaller, and narrower. Okay. But then for series to become bigger or to diverge, which means your R has to be greater than this one. All right. So that is what we need to know with the sequences and with the series. let's just snip into the papers and we see, okay. We have this, which I didn't mention. Thank you very much. It's here, sigma notation. So sigma notation means just the sum or the summation. For you to work around with the sigma notation, you need to first of all determine the type of sequence it is. Is it arithmetic, geometric, or quadratic, depending. Okay, we can do that by just substituting these 3 into this, the 4 into that, and then the 5, because the sigma notation is telling us that n must start at 3 and must end at 20. So after getting those terms and determining whether it's arithmetic or geometric, so let me assume this is arithmetic. Okay, I'll have to get my A, and then I'll have to get my D, and then bring in the sum of the arithmetic, which is n over 2 into 2A plus n minus 1 into D, and then do the substitution. How do I get the number of terms? I will get my last term where I'm ending, which is a 20, minus the starting point, which is a 3, and then I'll have to plus a 1. So in this case, our n will be something like 18, and then I'll use n as 18, and then apply all of that. Remember, it's a T2 over T1, or T3 over T2. That's how we get the common ratio, not the other way around. Same applies with the differences. When you're getting the differences, the T2 minus T1, which is the same as a T3 minus T2, just between consecutive terms. Okay, so in this case, our ratio would be 3x minus 1. Okay, then they're asking for which values of x. They're not asking for r. Of x is the series going to converge. Then bring in that condition. -1 is less r and less 1. And then get this r, replace it, and then make x the subject in that case. Then sum to infinity, we know the formula a over 1 minus r. So after doing your substitution of x as a half, you'll get your first term. You replace x as a half, you get your T2. And then get this a, and then between the two, get the common ratio. You can just get x, substitute it here, and then you have your common ratio. And then work the question out. So that is one question. Okay, there's another one here. We have 2x, 12, and y. They're telling us their first 4 terms of a quadratic. Sometimes they'll tell you what sort of sequence it is. So if it's a quadratic, just know that we have 2 differences that are involved. Okay, so 2, we have x, we have 12, and then we have y. So this and this is going to give us our first difference. But then they're telling us that the second difference that we're going to have here must be equated to a 6, according to the information given. So whatever we get here is a 6, and then whatever we have here must also be a 6. So in that way, we shall be able to solve just in the format of sequences and series. Okay, that was just one paper. Let's look at the other one. Okay, so with this one, they're telling us we have a quadratic. Okay, there we go. So we can get the first difference, which is maybe 18 minus 5, which is a 13, 37 minus that. I don't know. Is it a 9? 29? 19? Okay, someone is saying 19. And then you subtract that and you have your first difference. And then within the first difference, you get your second difference, and then you determine the Tn. So here, whatever we get for the second difference is the 2a. This 13 is going to represent the 3a plus the b. Okay, and then the a plus b plus c must be a 5. So 2a is equal to what's 19 minus that? It's a 6, something like that. And then you solve that. Whatever we get for a, we substitute it there. The a and the b we have, put it there. Then we got our terms, a, b, and c. Then determine the number of terms. Now, for you to get the number of terms, you should have been given the last term, the Tn. So where there is Tn, we're going to put 557. We have our a, we have our b, we have our c. Then we solve for n. Remember, when you're looking for n under sequences and series, your n should never be negative. And then your n should never be a fraction, because we're talking of a position. Positions are countable, okay? So in that case, not a negative, not a fraction. If ever we get a negative fraction, we discard those values and just focus on the others. And 2.2, we have 10x, y, and so on, the first 4 terms of an arithmetic. So follow the rules of arithmetic. There's just one difference. You just subtract x minus 10. That will be the first difference. And then we have y minus x. That will be another. And then negative 14 minus y will be another. Then these differences have to be the same since it is arithmetic. It's constant. Then equate this. And then also equate that. So it will be more like a mini simultaneous. You get x, then you get y. 2.3, just the same thing, determine the sum. So it's arithmetic, use the sum for arithmetic. And then the mth term of a sequence of arithmetic is k, the kth term is m, determine the common difference. So in this case, use the TNs, since they say the mth term, the kth term of what? Of an arithmetic. Use the TN of an arithmetic, and then we're good to go. All right, so we move on. So that is sequences and series or number patterns. Ne? The next we have what we call the functions. I'll just go up a bit. Functions. We need to know and use and interpret the functional notation, okay? When teaching the process, people must know how f of x will be transformed. Remember we said f of x will be the same as the g of x, will be the same as the h of x, the same as y itself. Ne? So when you have f of x, but then it has turned out to be f of negative x, this is a reflection about the y-axis. Okay? Then if it is in this format where it's negative f of x, it's a reflection about the x-axis. Then if we have f of x plus a, this is a shift. In other words, the graph has been moved some units. So it's a units. If it's positive, it's going to be to the left. And then if it's a negative a, it's units to the right. A units to the right. And then if we have f of x and then plus a, which a represents any number, this a is going to represent a shift, which is vertical. Okay, the graph is being moved up or down, and so on and so forth. So trig functions, these can only be found within paper 2. Now, with the functions, we need to remember we have different types of functions and we need to pay attention to all of them because most of them are examinable. Okay, an example, I'll start with the first one, which is maybe the exponential. This one is common, it's always there. With exponential, the exponent is x, probably plus a q. This q represents the asymptote. We need to remember that. Okay, we need to know at least how to determine the domain. The domain, you don't need to stress. X is a set of real numbers or an element of real numbers. Problem is the range. Range, these are y values. So y values are always affected by the asymptote. Okay, always y is greater than the asymptote. Then we need to know when is the exponential increasing or decreasing. We need to go over that because sometimes they can ask you to do the sketch. Then we also need to understand how to determine the inverses, okay? Most cases, it can be of an exponential function. So the shape is usually in that sort of format. So remember that. That is to do with exponential. Then 2, we have the parabolas. Parabolas always have to be with another graph in most cases, either parabola and a straight line, parabola with exponential, or parabola with a hyperbola. Okay, so that is x squared plus bx plus c. It's a cubic function. We also have ax plus p squared and then plus q, where p and q represent the turning point. And then we also have a into x minus x1 into x minus x2, where x1 and x2, these are intercepts. Okay, the points where the graph is cutting axis. And then we also have so parabolas, we have the smiling one if a is greater than 0. And then the frown face if a is less than 0. Then we have the hyperbolas. Hyperbolas, the denominator is having x involved. Ne? So a over x plus maybe p plus q. So with the hyperbola, we need to know how to get the asymptotes. So with asymptotes, we can say x is a p or y is equal to a q, depending. If this is a negative, then x is going to be a positive. Say it's a positive, then x is going to be a negative. These are asymptotes, guys. Okay, so having obtained the asymptotes, we also need to know Okay, then remember with the format of a hyperbola, okay, there has to be two arms, whereby if a is greater than 0, we expect the arms to be in that format. And then if the a is less than 0, okay, we expect the arms to be in the second and then the fourth quadrant. Then what we need to also remember is how would we determine the axis of symmetry with the hyperbolas. So we have two, one with a positive gradient and then one with a negative gradient, okay? Now they will tell you, they can ask you, determine the equation or axis of the parabola, the hyperbola, then you look for the one with a positive gradient. And then we use that. And then in the case where they tell you, they determine the axis of symmetry with a negative gradient, then you use the one with the negative x plus c. Now, how do you get the c? Use the points of intersection of the asymptotes. Okay, so that is all we need to know. And then remember with the transformations that happen. Let's look at a snip into these questions. There's question number 3, which question number 3 is a hyperbola. So 12 over x minus 4 plus 6. So you can see that this is an asymptote, and then that is also an asymptote. Then when they ask you to sketch, in most cases, you will need what we call the intercepts. So for you to get the intercepts, remember for x-intercept, okay, y has to be a 0. And then for y-intercept, x has to be a 0. And then you just have to get these points and then know the shape of the hyperbola. Because now our a is a 12, so we expect the hyperbola to be in quadrant number 1 and quadrant number 3. So even if a quadrant does not have any coordinates that you need to plot with, just draw the arm there so that it is two arms of a hyperbola. Okay, then write down the equation of k if k is a reflection. Now they are reflecting about the x-axis. Then you'll have to sort that out. And then question number 4. We have now a parabola and then a straight line. Okay, so use them to determine what you need to get. Then one other thing I need to really emphasize, okay, let's say the turning point of D. So turning point, you know what to do. Axis of symmetry, x is equal to negative b over 2a. We need to remember that as well. And then for us to get the coordinates of a and b, those are intercepts. We mentioned that upwards. And then the value of k, we're seeing that k is the y-intercept. Okay, so for you to get the y-intercept, you need the coordinates of A, at least a set of coordinates that is passing through the graph of G, which is A. And then that is going to give us the missing part. And so on. Now we can see this, what 4.1.4. They're asking the values of P for which it has no real roots. Now this is nature of roots being questioned. And then we need also to remember how to answer questions when you have f of x times g of x is greater or less than 0 and so on. And then with tangents, we need to also apply some bit of calculus sometimes, okay? Calculus could be needed, especially with such questions of tangents, because there's going to be need for the gradient and all of that, okay? They're telling us this is a tangent of f, but with this tangent, we can see that the gradient is clearly a -2. So what you need, get the value of x, where the gradient is a -2. So find the first derivative of f, equate it to -2. So for x, get the value substituted back into the original. And then we have this also to do with the shifting and the transformation. We need to pay attention to that. Look at question number 5. We have the graphs g of x and f of x, but then the drawing is showing the inverse. Please pay attention to that. And then you just need to know that with the inverse and the original, we just switch everything around. What is x becomes y, what is y becomes x. One point for which both graphs will pass, remember this is f, ne? It's not the g. So just switch these points, 1 and 4, or 2 and 16. Then equation of f, for you to get f, you need a set of points. Whenever you're looking for unknowns of any function, you need a set of points. Okay, if there are two unknowns, then you're gonna need two coordinate pairs to get those two unknowns. Then calculate x if g of x, now x plus 2. This is a shift. The graph is being shifted 2 units to the left. And then we answer that as well. Okay, that is one paper. Let's see this paper. What does it have under functions? Could be more or less the same thing. So we have this. The exponent is x. So that's an exponential equation. They want the asymptote. Remember asymptote? You said anything that is extra there. Then the range is affected by asymptote. Coordinates of the intercepts, we discussed that. And then drawing, for as long as you know the shape. Because now our b is a fraction. So which means this is a decreasing function. And then we have this sketch below, not drawn to scale, represents a parabola. They never told us that, but it is x squared. So it's a parabola. And then we have a straight line. It cuts that and that, blah, blah, blah. And then here we go. They ask us to determine the length. Now, whenever we're looking for length of lines that are parallel to the x-axis, parallel to the y-axis, in other words, just horizontal and perfectly vertical, you don't need to use the distance formula. What you need to do, you need to get the coordinates of B and then the coordinates of C. These are intercepts. And then get the number of units up to the 0, get the number of units up to the C, and then plus these 2 units. That will be the distance. They want the coordinates of D. They told us that D is the turning point. Remember, with the turning point is negative B over 2A. Then there's a straight line that is parallel. These things parallel to G, touches F at M, coordinates of M, calculus involved. There's some bit of calculus because we need the gradient. We know that with parallel lines, the gradients are the same. With perpendicular lines, the products of the gradients will give us a -1. Then when they ask for the values of x for which f prime, remember f prime is the first derivative, which first derivative focuses on the gradient. Okay, gradient. Then when they ask for maximum, you look at the turning points. Then question 6 is a restricted function with a condition or restrictions. So we have a point A with an unknown, so which is P. Then they want you to get P. So for you to get P, you need a set of coordinates. No, we don't need a set of coordinates. Just substitute this into the function itself because this is the set of coordinates. So where there is Y, put a 4. Where there is X, put the P. And then we're good to go. Then determine the equation of the inverse, just switch. Where there is X, you put a Y. Where there is a Y, you put the X. And then the condition must stay the same. And then for which values of X, for which values of X is the f of X greater than the inverse. So for a graph to be greater, it must be just above. So let's say I had plotted my point. I don't know what this is, but let me just sketch something. And then I have something like that. Let's say this is my inverse, and then that is my f at this point of intersection. When they say the f inverse is greater, we focus on this point because the f is above. But then when they ask for f being greater than the inverse, where do we find f to be above? We remember that as well. Then we have this hyperbola. They gave us the conditions. So domain, those are x values. X cannot be this. This is an asymptote, the vertical. Then range is this. Y cannot be that. This is a horizontal asymptote. Then G of 2 is 0. So remember the original must be G of X is equal to something. But now they're telling us G of 2. So where there is X, we've replaced it with a 2. So that's the coordinate point 2 and 0 because this is a Y. Okay, so they want you to determine the equation. So use those facts. Where there is X, you're going to put the 5. Where there is Y, you're going to put the 1 somewhere there. But then the signs are going to change for the P. All right, that is to do with the functions, okay? Then from there, we can look at the finance questions, okay? So under finance, growth and decay, they are telling us we need to understand the difference between the nominal and the effective interest rates and how to convert nicely. because this formula is usually not on the formula page. 1 plus I nominal over n to the exponent of n. Some people would use m. Let's just confirm and see if that formula exists, because we don't have to stress about things that are already there. Nominal interest, nothing. It's not there. Nothing. So that formula, we just need to know it by our heads, by ourselves, okay? And then you work out that. So the ends are either going to be compounding periods of monthly, where it's a 12, quarterly, which is a 4, half yearly, which is a 2. Sometimes half yearly is known as semi-annual. I saw a question that talked about weekly. Okay? How many weeks are there in a year? It's 52, no? Not 54. 52 weeks. That okay. Then with the exception of calculating I, okay, they're not going to ask you for I under annuities. But all the other variables, the X, the N, all of them, they can be examined. Okay, so F represents the future value. Okay, and then P represents the present value. To calculate the value of any other variables, pyramid schemes, they're not going to look at them. So when they talk of finance, we need to know, number one, when you talk of, let's say, growth, then you use the compound formula, 1 plus I to the exponent of n. When we talk about decay, we have different types of decay. Number one, we have what we call the reducing balance. Okay, it's A into P1 minus I to the exponent of n. And then straight line depreciation is P into 1 minus I n. All these formulas are on the formula page. Okay, then all these apply if you're dealing with just a lump sum, or either it's a loan or it's an investment or whichever amount it could be, but just a lump sum. Then apply the correct compounding periods, where you divide by n and then multiply by, if it's a 12 monthly, divide by 12 and then multiply by 12 to get the number of periods. Then if, let's say we're dealing with payments that are regular, okay, regular payments, either you're going to pay them monthly, quarterly, half yearly, and so on. It's continuous. These are what we call the annuities. Okay, so we have two. We have what we call the present annuity. This present deals with the loans. If you borrow money and you have to pay it back, that's present. Then we also have the future. We need to know about the future, which is F. This is the P. Okay, so this deals with investments. And then what we call the sinking funds. Okay, sinking funds. Now, there's a question that is usually asked, especially under the present value. That is to do with the outstanding balance. So for you to get the outstanding balance, use the present value formula. Okay, and then where there is N, let it be the remaining period to clear the loan up. And then you get your outstanding balance straight away. Okay, that is that. Then we need to remember at least the grade 11 concepts of finance, that is to do with the timelines. Okay, so that's all we need for finance. The rest are just a walkover. Let's see. Let's snip into the questions. My question 6 or 7. Here we go. Convert 14% compounded monthly into an interest rate that is compounded quarterly. So use that 1 plus, that's going to be 14% compounded monthly over 12 to the exponent of 12. Is equal to 1 plus, this is a percentage which we don't know, I, but it's compounded quarterly over 4 to the exponent of 4. And then simplify this. If you are getting rid of an exponent, use the roots. In this case, we use what we call the 4th root, the 6th root, the 8th root, and so on and so forth. And then look for the I. 6.2, this person deposits this into an account. 3 years later, he adds. Okay. So which means there is inconsistency. Okay. 3 years later. Then the interest for the first 2 years changes. The last 3 years. So in this case, we're going to use what we call the timelines, grade 11 aspects, to work this out. And then 6 point next, or there's no 6 point next. Question 7, Mr. Daniel wants to take out a loan. Okay, we said loans form what we call the present value. They gave us the period, which is 20 years, and they want the total cost of option 1. So for you to get the total cost, what is missing is the monthly payment, which is X. So get the monthly payment, multiply it by the number of months, which is 240, and then you plus the commissions. That will give you the total payment. Which option is the best? If you get this and that, the total that you have in 7.1, can also multiply this 10,000 times 240, multiply the 200 by 240, get the total, and then compare the loan amounts. And then you draw your conclusion. Okay, let's look at this other one. What kind of finance questions were there? Okay, Tandy invests this much for a certain number of years. She earns interest rate at this compounded quarterly. The final value is this much. For how many years? Now they're asking for the N. And they gave you the P. They've given you the A, because this is our A. That's our P. That's our N. And then just substitute. We have our I here. Substitute into the formula of compound interest, because this is just a lump sum. 7.2, this person takes out a loan of 500,000. So this 500,000 becomes the present value. That's the interest rate. It's compounded monthly. Then the bank requires him to pay off the loan in 8 years with equal installments starting 1 month after. Okay. So the normal standard period that we give is just 1 month after, then you can start paying off your amounts. But if it so happens that you take some time before you start paying off, let's say you take 6 months, this amount is going to grow for the first 5 months. Okay. And then whatever you get there, that will be your new loan amount. If you start immediately, then you'll be cutting short the number of years or the periods. It will be less than exactly 8 years. So you need to bear that in mind. Outstanding balance after 5 years, remember the period was 8 years. So if you get 8 minus 5, you're going to have 3 years left. 3 times, this is monthly, no? You're going to get 36 months. So use the present formula, okay, with the same installment that you got in 7.2.1, where there is N, put a 36. Whatever you get becomes your outstanding balance. And then this person decides instead to pay off the loan with just 95 monthly installments. Okay, of just 7.3 everywhere. And then calculate the 96th installment. So we need to know how much would be accumulated with 95 installments. You can use the formula still of the present and see how much would be outstanding. So in case it could be maybe even a fraction that is left, just a fraction of a year or a month that will be left, which amount would be less than the 7.3. Okay, so that is finance, and that's what we should expect. Plus minus 15 marks. If we can get 3/4 of them, well and good. Next, we have what we call the calculus, differential calculus. Okay, so differential calculus, we have notations that we use for differentiation. Number 1 is what we call the f prime, okay, of x. Sometimes we just call it the dx, and then dy dx, or sometimes it's just the y prime. It's the same thing. We need to know how to work out the first principles. Okay, how do we factorize from first principles? And then how do we apply the rules, the differentiation rules, and then the applications. Okay, here they are telling us that in respect of cubic functions, candidates are expected to determine the equation of the function. Remember that is ax cubed plus maybe bx squared plus cx plus a d, where d represents the y-intercept. And then we can use either the long division or the synthetic approach in doing this. Then you need to discuss the nature of the stationary points. So these stationary points are basically the turning points, either the local minimum and the local maximum, and then the points of inflection. So for you to get the stationary points, remember, you need the first derivative. For you to get the points of inflection, you must get the second derivative, or you must get the midpoint of these points of the stationary whatevers. Then apply the knowledge of transformation on a given function to obtain the image. Okay, candidates are expected to be able to draw. Okay, so when you're drawing, the A has an effect. If A is positive, then you're gonna have this kind of shape of a cubic. If A is negative, then you're gonna have something like that. Bear that in mind. Then that is the graph of the derivative of a function. Okay, so if this is derived, if the cubic function is derived, you're gonna end up with a quadratic, no? Which quadratic? If let's say our x here was a 2, then our x here is a 4. 2 and a 4 will instead become the roots of that quadratic. So that is a 2, and that is a 4. Okay, so candidates are expected to be able to draw and interpret the graphs, okay? Then surface area and volume will be examined in the context of optimization. In other words, when they're asking for minimum and maximum surface area, maximum volume, these you need to know. And the formulas, you need to have them ready because they're not going to give you these formulas. Okay, candidates must know the formula of the surface area and the volume of right prisms. Okay, rectangular prism, the cube, and so on and so forth. This will not be provided if optimization question is based on the surface area volume of the cone sphere, and so on. The relevant formula will be provided in that question, not on the page, just within that questions. So you have to select the correct formula from the list because sometimes they can give you more than one. All right, so let's see. In this case, they are telling us f of x is 3 minus x squared. Determine f prime. Remember, f prime is different from the f negative 1. F negative 1, key inverse. This f prime is just the first derivative. So the formula for first principles, we have the limit as h tends to 0, f of x plus h minus f of x divided by h. And then you apply the correct measures. Ne? So where you have your f of x as this, what you need is the x plus h. So where there is x, put x plus h. And then they tell you to determine dy dx. So in this case, you need to know that whenever you have root signs, you can change them to exponent a half. Okay, and then if the root sign is down or the cube root, you can always move it up and then the exponent sign changes. When you look at 8.2.2, they want dy dx. Step number 1, you're going to have to factorize the y. Make y the subject before you find dy dx. Okay, so y is out, you have x minus 1. On the right-hand side, I can factorize that also, x minus 1 and x plus 1. Divide both sides by x minus 1, x minus 1. That cancels. So our y is just x plus 1. And then we need to differentiate this. So the answer here is just a 1. Okay, so where do the marks come from, or where do we allocate the marks? Just this thing of factorizing and simplifying, because this derivative is so quick. 8.3 times the value of x, where the gradient of the tangent to this graph is equal to -8. They want the value of x, where the gradient is -8. So open this thing up. Okay, so it's x minus 5. Open the square brackets using the FOIL, then find the first derivative, then your first derivative, I'll say f prime of x equated to the gradient, which is -8. So we equate the first derivative to 0. Okay, first derivative is equated to 0 if you're looking for turning points. Oops, why am I rushing it? Maybe it's even the next question. Okay, they gave us a function. Here we go, represented by the sketch. We have -1 and 36, and then b is a turning point, while g is a tangent of f, and boom. Show that p is that, and q is that. We have 2 points, guys. Ne? We have the 30, so that is a 0 and a 30. Then we have -1 and a 36. So this is going to involve some sort of simultaneous. Looking at the mark allocation, and we have how many unknowns? We have 2 unknowns that we need to solve for. So first get this 0 and 30, substitute it. Where there is f of x or y, put a 30. And then that is going to give us the same thing. So this is not going to help. Let's use this. -1 and 36, substitute it. We're going to get the first equation. Then get the first derivative of x. Then where there is x, so that's going to be 3x squared plus 2px plus a q. And then we know that this first derivative is going to be equal to a 0 because it's a turning point, and the gradient at the turning points will always be a 0. Then x is a -1. Then you substitute a -1 here. So it's going to be a 3 minus 2p plus q is equal to 0. So you can create another equation from here. And then you solve the two equations simultaneously. Your p's and the q's must come out. Then they ask for the value of c. Okay. So with c, we know that this line is parallel to the x-axis. Is that true? YG is that which cuts f as c. It looks like yes, it's parallel to the x-axis. Okay, if that is the case, which means the equation of this line is just going to be y is equal to a 36, and then equate this to this equation or to this f. So where there is f or where there is f of x or y, put a 36 and then solve that equation. You'll get 2 points. One is going to be a with a -1, and then that is the c coordinate that they need. And so on. So the rest will be just application questions, and then they ask you to draw the graph of a derivative. Draw the graph of a derivative, clearly showing the intersection. Remember, we said the derivative is going to be a quadratic. So that is that. Then you have question 10. PQRS is a rectangle with P, the curve H of X is x squared, and all of that. X is 6 with boundaries. Can we show that the area of PQRS can be expressed like that? So in this case, they'll give us a formula, which formula we shall move towards 2. So this is what they are looking at. Now, what did they give us? They gave us the equation of H as x squared. So do your magic. This line is a 6. They told us this is a rectangle. So do what you have to do with the area of the rectangle, length times breadth, and so on and so forth, and determine the largest possible area. So for largest possible area, you use the derivatives. First derivative, and then equate that to 0. Then solve for x. The answer for x, put it back into the area. Okay, you bring it back into the area, and that will be the maximum possible area. When I look at this question 8, same thing, first principles, we just need to know how to work that out from the rules. Then in this case, you have to move the x to the top. Please, when you're moving the x, the 2 will still stay down. So that will be like x to the -5/2 minus 7x plus 4b cubed. The question is telling us to find the derivative with respect to x. So we shall derive the first term and the second term, but this is going to be looked at as a constant because it doesn't have x. So we cannot say 3 times 4 is 12, and then no, this is not x. So that is going to fall away. And then when you have something like this, split up. So 5x to the 4 over x squared plus 3, we said x to the half over x squared. Simplify that using the laws of exponents and then find the derivatives. Then we have another cubic function, more or less the same. Then they want us to find a and b. So do the same thing. You have this point, which is a turning point. First substitute it there. You get your first equation. Then you find the first derivative. Okay, equate it to 0, and then replace x with a 1. Just link to what we saw there. That is done. Determine the coordinates of b. What is b? B is a turning point. So get your first derivatives and then equate to 0. So we said for turning points, the first derivative must be equated to 0. You solve for x. And then a tangent touches f at x is equal to 4 times the x value. where the point is that. So get this 4, put it into the equation of f, determine the y value. Okay. What do they need? They want the x value of the point where the tangent intersects with this. So you get that point, and we know that a tangent is just a line that touches the graph just at one point. And then apply your knowledge there. Then determine the values of k for which are exactly 3 distinct roots. So this is also nature of roots in a way. Okay, then question number 10, rectangle ABC is inscribed in an ellipse, blah, blah, circumference. There's a rectangle, and then the equation of the ellipse is given as this. Okay, then what do they need? They're telling us to get the maximum area, calculate the maximum. So you need to get the formula for the maximum area and all of that. So we have the coordinates. No? From here up to here is x. From there up to there is also negative x, which means your length is the same as 2x. And then this side, this is a y. And then this must also be a negative y. So which means the breadth is going to be that much. So for you to get the area of the rectangle, what we need to do, you can just substitute x and y, because we need just one variable, y to be on one side and the x to be on the other. Substitute since these points are intersecting, make y the subjects and so on. Okay, so that is how the calculus would be like. All right, then I'm moving on to the last aspect, which is probability or counting principles. So with this, we need to know what we call the dependent variables. Okay, but we're not going to use conditional probability. I don't even want to discuss that, where they tell you probability of A given that B has already occurred. This is out. Just dependent. Dependent events in which an object is not replaced. This normally comes under the tree diagrams. Let's say you're picking marbles or you're picking sweets from a bag and then you don't replace the sweets. Okay, then questions that require a learner to count the different number of ways that objects may be arranged in a circle or use of combinations are not in the spirit of the curriculum. So you don't count in circles, but rather the way that we've taught our learners. In respect of word arrangements, letters are repeated in the word can be treated as the same, indistinguishable, or different, which is distinguishable. The questions will be specific with this regard. They'll tell you whether the arrangements must be kept the same or different. Okay, so with this probability, we need to remember our concepts of grade 11, okay, where you talked about how do you prove that events are independent or dependent using the contingent tables, okay, two-way tables. You need to at least go over the old tree diagrams, how to draw the tree diagrams and obtain the outcomes. There is this question that always brings memories, which is the Venn diagram. So with Venn diagrams, remember, we always prefer the 3-set one, as much as the 2-set one can also be examined since it's a previous grade. So this we need to know independent and all of that. Then the probability rule or the addition rule, which is probability of A plus probability of B. This is on the formula page, A plus B, or A and B. And then we need to know something to do with mutually exclusive. How does it work? So mutually exclusive, we know that the probability of A and B is equal to 0. And then for as long as the events are independent, this is what they love, or probability of A and B, that's going to be probability of A times the probability of B. This we also need to remember. Then with the grade 12 probability, those are the counting principles where you talk about the factorial symbol. What is 7 factorial? That's when you're looking for different ways in which 7 can happen. An example, if you have 7 letters, is it 7 letters? No, let me just use the word 7. Not 7 letters, but 5 letters. And then we want to rearrange this word. In how many ways can we rearrange? Or in how many words can we obtain? Now they're telling us if we have 2 letters, they'll tell you The question will tell you whether you should treat these as two different or just one same whatever. Okay. So 5 factorial will represent the number of options that we have, number of ways. Then how you get the probabilities, we need to go over that as well. So when I quickly have a look at, let me start with this one. Okay, in a survey, so they're using a table where you have 2 options, okay, male and female, and failed and passed. So totals must add up, and then they're asking you to determine whether the test is independent. Okay, so they did not specify the gender, so you have the right to choose your own gender. So in this case, failing, okay, and the gender. So probability of failing and maybe your male. That will be probability of failing times the probability of being male. So on the left, failing and male, oh Lord, I'll just call it fail and male, okay? So you failed and you're male, it's 170 over 3,000. Then for probability of failing is 200 over 3,000 times probability of being male is 1970 over 3,000. So you check the answers. Please do not transpose anything. You kind of proving what is on the left and what is on the right. Get the answer here. We normally prefer decimals, at least to 4 or 5 decimal places. Same place, same option with the right-hand side. If you see that the answers are the same to at least 4 decimals, then they are independent. If they are not, then the events are dependent. Then here, events S and T are independent. You see that? Probability of S is the same as probability of T, which is Y. Then probability of S or T is this. So you have to apply that addition rule. They want the value of that. So S or T, we said is going to be S plus T minus probability of S and T. Now, what is S? It's a Y. What is T? It's a Y. Minus S and T, events are independent, so you multiply them. Is that what is happening? Is that going to make sense? Yes, 0.84. So that's a 2y minus y squared is equal to 0.84. It's a quadratic, you solve it. That's why it's 5 marks. Then 11.3, we have 7 bananas, 4 apples, 3 oranges, and 5 guavas in a fruit basket. How many arrangements are possible if the fruits were to be placed next to each other in a single row? Okay, we have 7, we have 4, we have 3, we have 5. We can just multiply those numbers. Answer we get, those are the different ways of how we can group them. Then we have the word stapled. If the letters are randomly selected and all the letters are used, what is the probability that a new word will start and end with a vowel? Okay, so how many vowels are there? It's just 2 vowels. How many letters are they? 1, 2, 3, 4, 5, 6, 7 letters altogether. So start by looking at what if there was no condition of the vowel. We would have 7 factorial. Those are the options, or those are the arrangements we would have. Then bring in the condition, whereby one letter is, let's say A, and then this is maybe E. I'll just say this position is taken, and then that position is also taken. How many positions are we left with? So wait, 2, 4, 6, 7. I'm only writing 5. Okay, this position is also taken. So I have 1, 2, 3, 4, and 5 places to play with. So I'll say 5 factorial. And then I multiply the ones by the end, and then 2 factorial, since the A and the E can switch positions. So that's how I would have gone about that. When I look at this other one, they're talking about probability of getting the first answer in a quiz is 60%. If the test answer is correct, probability of getting the second correct rises to 70. So this is more like a tree diagram, if you want to. So 60%, which is 0.6, that's if it's correct. And then if it's correct again, is 0.7. So remember, every branch must add up to 1. So for wrong answer, this is going to be a 0.4. And then for wrong answer here is going to be a 0.3. But then they're telling you that if the first answer is wrong, the probability of getting the second answer correct is 0.4 or 40%. So that's a 0.4, and then this is a 0.6. This is correct. This is wrong. So the outcomes will be correct, 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 wrong, wrong and correct, and then wrong, both of them. Then they want the probability of getting the second answer correct. Now, they are not being specific whether the first answer is correct or wrong, but the second answer has to be correct. So it's possible for you to get the first answer wrong and then the second answer correct. So that's 0.4 times 0.4 plus first answer correct and correct. So 0.6 times 0.7. Multiply that, give your answer either the decimal or a percentage. Remember, probability can be expressed in 3 ways. Percentages, fractions, and then decimals. Then here again we go. A and B are independent. They want the values of X and Y. Please and please and please. When you look at these Venn diagrams, B is going to be 0.4 because we are adding the 0.1 and the 0.3. A alone is going to be 0.1 plus X. And then this 0.1 is the probability of A times the probability of B, which is 0.1. And then apply your addition rule, A or B. So probability of A plus probability of B minus that, and then you apply what we have. So in that case, you're going to be looking for X. Then for you to get Y, you add up everything here. It must give you a 1, since we're dealing with decimals. Maximum probability would be 1. Then question 11.3, ping pong balls numbered 1 to 12 are placed in a hat. Every time ball is thrown, it is placed on a rack, one next to the other. How many different arrangements can the 12 balls be obtained? So that is 12 factorial. Okay. They are telling us assume that the numbers 8 and 11 must be placed next to each other. So these ones are going to move together as a single block. In how many ways can the numbers be arranged? So treat this like one block, and then you recalculate that. Then the numbers 2, 5, 6, and 9 are taken from the group of balls. Then 2-digit numbers must be formed out of these 4 numbers. How many 2-digit numbers can be formed? So you have 4 options, and we only need 2 options. So permutations and combinations, or we need to know. So guys, that's all that you can expect. I wish you all the best, and do prepare wisely. Thank you very much. Let's meet in the scope for paper 2. Hello and welcome to this episode where we shall be looking at the preparatory examination for Gauteng Province 2022 Mathematics Paper 1. All right, so the paper was a full paper, which was 150 marks. And the instructions, we have 11 questions. All must be answered. And then question number 1, which is the usual algebra. They want us to solve for X. Okay, so when you look at 1.1.1, it's a dot product where we have 2x times this bracket must give us a 0. So from our dot product, we clearly know that if we have A times C is equal to 0, it's either the A is a 0 or the C will be a 0. So we don't need to open this up. Just apply the dot product. So what I'm going to say, I'll put the 2x and equate it to 0, or I'll have the x squared minus 1 must give me a 0. So from the first approach, we can divide both sides by 2. Clearly, x is going to be 0. And from this second bracket, I can see it's a difference of 2 squares. So I can say x minus 1, and then x plus 1 should give me 0. So which means either x is a 1 or x is also negative 1. In other words, we have 3 solutions for this question. Because if you were to open this up, we're going to get 2x cubed. And degree 3 must always give us 3 solutions. Then 1.1.2, we have x minus 6 plus 2 over x is equal to 0, but x can never be 0. We want it to correct 2 decimal places. So remember we said whenever a question comes with this condition, we're going to apply the quadratic formula. But before we apply the quadratic formula, we have to make sure that this whole thing is in the standard form of the x squared plus bx plus c. All right. So I'll say if I have my x minus 6 plus 2 over x is equal to 0. So step number 1, I'll get rid of this denominator or try to eliminate it. And the only way for me to do that is if I multiply through by x on both sides of the equal signs. So if that is times x, times x, times x, and then times x. So this x and that will cancel. I'll be left with x squared minus 6x plus 2 is equal to 0. So this is the standard form that we must use. So from this, we know that our a is a 1, our b is a negative 6, and then our c is a positive 2. Then from the quadratic formula where we have negative b plus minus square root of b squared minus 4ac, we're dividing this by 2a. We just do the substitution. So our b shall have a negative and negative 6 plus minus b squared. We're going to say negative 6 squared minus 4. Our a, we said, is a 1. Our c is a 2. Dividing all this by 2 times 1. Okay. So remember, when you're punching this into the calculator, when it comes to the signs, you use one sign at a time. Okay. So if I put this into the calculator, my first x value I'm getting is 5.65 if I'm to round it off to just 2 decimals. Then the second, if I use the subtraction, I'm getting 0.35. That is if I'm to round it off to 2 decimals. All right, so that is what we do, what we get. Normally we want 2 decimals. So if you give more than 2 or less than 2, you might be penalized for the rounding because the instruction is clear. It must be 2 decimal places. Okay, so we said it's 5.65 or 0.35 to 2 decimal places. All right, then 1.1.3, this is an inequality. So they're telling us if we have x minus 1 times x plus 4 is greater or equal to 6. So we cannot apply the rule that we used in the first one, since we do not have a 0 by the right-hand side. So we just need to open this up and create a standard form. So I'll do it on this side. Okay, so I will have, just create space there. Okay, so we're calling that 1.1.3. So we're saying x minus 1 into x plus 4 is greater or equal to 6. Okay, let's open this by using the FOIL. Okay, so x and x is going to give us x squared. That's going to give us a 4x. This and that is a minus x. This and that is minus 4. Then we need to pull this 6 that side. Minus 6 is greater or equal to 0. When I simplify this to create my standard form, I'm going to have x squared plus 3x. This and that is going to give me a minus 10 is greater or equal to 0. Then I can use my dots here, or I can use the quadratic formula just to solve for this. So if I use my product, my factors, numbers I multiply to give me -10, I add them to give me a 3. I'll have is greater or equal to 2. Okay. Then I need to get what we call the critical values, or what would be solutions. So we're going to have x as a -5, or x is going to be a +2. Now, how do we represent this? Because I've seen a number of learners just saying x is equal to -5 and x is equal to +2. That is kind of wrong, because we are dealing with inequality symbols, so you must give the solutions with this. So if the inequality is greater or equal to, then in most cases, our solution is going to be x is less than the smaller number, and then x must be greater or equal to the bigger value. That is how we represent the solution, for as long as the inequality is greater or equal to. If the inequality was less or equal to, then it could be the small value is less or equal to the x, less or equal to the big value, something of the sort. So in this case, we're going to say x must be less or equal to -2, or x must be greater or equal to +2. So this is how you would represent it. Alternatively, someone would draw a graph or a line, number line, and draw the parabola. Okay, so that is 1.1.3. Then I'll move on to the next page. That is question 1.1.4. So we said x is greater or equal to 2, then x is less or equal to -5. All right, so 1.1.4, we have the square root. We have the roots, okay? So square root of x minus 2 plus a 3 is equal to 10 over square root of x minus 2. Okay. How do we go about this? Okay, so there are two ways that I can see. It's either we can multiply through by the root sign throughout, so that we have, let's say, square root of x minus 2, we're gonna multiply it by root x minus 2 plus 3 times root x minus 2 is equal to 10. Someone can let this be a letter. Maybe if we call it a t, so that it is t plus 3 is equal to 10 over t. And then we just solve for t, and then later on we just replace t with this kind of expression. Okay, so I'll try with the first one. Okay, I'll try with the first one and we'll see what it gives us. So we're saying that this is 1.1.4 square root of x minus 2 plus 3 is equal to 10 over square root of x minus 2. So we said multiply through by square root. So we're going to have x minus 2 times the root of x minus 2 plus 3 the root of x minus 2. We say this is just going to give us a 10. From our sides in the previous grade, we know that root a times the root of a must just give us a, since that's going to be square root of a squared, which is the same as n. Now, when I look at these two brackets, so it means I'm just going to have x minus 2 as my final result here. And then plus 3 with the root of x minus 2 is equal to 10. Then I'm going to move everything to the right-hand side and leave the root sign alone. So I'll take the 2 and the x that side. So when this 2 moves that side, it's going to make it a 12. So I'm going to have 3 square root of x minus 2 is equal to, we said 10 plus 2, that's going to be a 12. And then we subtract x. Okay. Then from here, we can square root both sides. We can square both sides. So this squared, and then that squared, so that we can get rid of the root sign. Now, for as long as we have a number in front of the root sign, that number is also going to be affected by this square. So 3 squared is going to give us a 9. Into the root sign is going to fall away. So this only applies if we are multiplying by the root or we are dividing by the root. We cannot square if we have addition there. It will complicate life. So that's going to be x minus 2 is equal to, when we open this up, it's going to be 12 minus x and then 12 minus x. Okay. So when I FOIL that, I'm going to have 144 minus 24x plus x squared. Open the left-hand side, it's going to be 9x minus 18 is equal to 144 minus 24x plus x squared. And then I'll just create a standard form. So I'll move the 9x to that side, the 18 to that side. So I'll have x squared minus 24 minus 9. Okay. Negative 24 minus 9, I'm going to have negative 33x. And then 144 plus 18, I'm getting 162 positive is equal to 0. Okay. Then from here, I can choose to use my either quadratic formula or what's that thing? Or just the factors. So if I look at the factors, which numbers do I multiply to give me 162 positive, but then when I add them, I end up with a negative 5. So this would be, which numbers are those? 33. We have some 162 divided by 33 is going to give me, no, that's something else. So if I try 7 and 6, you can use the quadratic formula just to save time. Okay. So that's going to be x minus 27. Does it make sense? Yes. And then x minus 6 is equal to 0. So either x is going to be a positive 27 or x is going to be a positive 6. Then we have to test the values. Okay, we need to test. Whenever a question of a square root comes, you need to test your answers before you get to the conclusion. So if I'm to write down the original statement, which was square root of x minus 2 plus a 3 plus 10 over square root of x minus 2. Okay, so how do we test? We just have to replace these numbers, the x values, on the left-hand side and see if we're going to get the same thing on the right-hand side or the same result. So an example, if I use 27, it's going to be 27 minus 2. If I'm looking at the left-hand side, 27 minus 2, that's 25. Square root of 25 is 5. And then 5 plus 3 is going to give me 8. That's in the left. On the right-hand side, I have 27 minus 2, which is 25. Square root of 25 is 5. I have 10 over 5, which gives me a 2. So on my left, I'm having 8. On my right, I'm having 2. So that solution it's not working out. In other words, what I'm getting on the left is not the same as what I'm getting on the right. So we cancel that solution out, or we simply say not applicable. Okay. Then let's try 6. If we have 6 minus 2 on the left-hand side, it's going to give us 4. Square root of 4 is 2. And then 2 plus 3 is a 5. We're saying square root of 6 minus 2 plus 3, which is a 5. Let's look at the right-hand side. With the right-hand side, we know that 10 divided by square root of 6 minus 2 is a 4. Square root of 4 is 2. 10 over 2 gives us a 5. So since we have a 5 on the left and 5 on the right, this solution stands and will still remain as the correct solution for this question. Okay, so that was alternative number 1. Remember, alternative number 2, we said you can just replace the square root into the letter format and then solve. It could be a little bit quicker. Okay, then 1.2, they want us to solve for x and y. We have x minus 2y is equal to 1, and then we have this. So what we say always is look for the linear equation. If you call this equation number 1, you call this equation number 2. From the linear equation, we can manipulate the x if we move the y that side. So we're going to have x is equal to, I'm going to say 2y plus 1, or 1 plus 2y. Then I'm going to call this equation star, or I'll call it equation number 3. And then I need to substitute this equation star into equation number 2. Where I see x, I'll replace it with all of that. All right, let's do that. So that is 1.2. So we said x is 2y plus 1. And then our equation number 2 is x squared. It's 2x squared. So 2x squared minus xy, okay, minus 5y minus 3y squared is equal to 0. Okay, so we said where there is x, we're putting the all of that. So it's saying substitute, say this is star, equation star into equation number 2. Okay, so that's going to be 2 into 2y plus 1. I square that minus my y. I'll put the y first, and then I'll have 2y plus 1, this x. I need to replace it with this whole thing. And then I'm subtracting 5y, I'm subtracting 3y squared, and equating it to 0. So then I'm going to open the square bracket, the first one. You can still use the foil. So I'll keep the 2 for now. I open that, I'll have 4y squared plus 4y plus 1 minus, that's going to be 2y squared. This with negative y and the 1 will give us negative y. Minus 5y minus 3y squared is equal to 0. Let's open this bracket. 8y squared plus 8y plus 1 minus 2y squared. You can simplify this if you want. 6y minus 3y squared is equal to 0. Then I'll do my final simplification by collecting the like terms. This is 8 minus 2. That's a 6 minus 3. I'll be left with 3y squared. Then I have 8y minus 2 minus 6y. That's going to give me a 2y. And then I'm just going to be left with a 1 as a constant. Does it make sense though? Or did I do something wrong? Okay, I'll go revisit and see what I did wrong. Let me just confirm the equation. Oh, there's something I left out. This minus 2. I left the minus 2 out here. So we said minus 2. That's minus 2. And even my opening here is wrong. So we're gonna set this a plus 2. But this is wrong. So if I have a minus 2 here, and this, that's gonna die out of it. Then that is a 0. But it's not making sense. Okay. Then we just open up, take out the y. We're gonna have, let's say, 3y plus 2 is equal to 0. Then either y will be 0, or I'll equate this to 0, which means my y is gonna be negative 2 over 3. Okay, if I say 3y plus 2 is 0, move the to that side, divide both sides by 3. Then I'll get this and then substitute into my equation star for me to get my x. So if the y is 0, then my x is just going to be 1, because 2 times 0 plus 1 would be 1. And then if my y is negative 2 over 3, then now x is going to be 2 times negative 2 over 3, and then plus a 1. So which means our x will end up being, that's negative 4 over 3. It's going to be a negative 1 over 3. Okay, guys, so those are the solutions for the simultaneous. All right. Then we'll move on to the next question. Move on to the next question, and that is 1.3. 1.3 is to do with exponents. 2 to the x plus 1 plus 2 to the x is equal to 3 to the y plus 2 minus 3 to the y. Okay. So what I'm going to do here, on my left, I have just 2's, and then on my right, I have 3's. Is it possible for me to expand? Yes. And if I have plus signs and minus signs, which means I can factorize out at some point. Okay. So I'm going to start by expanding this. We know that 2 to the x plus 1 is the same as 2 to the x times 2. Then I'm saying plus 2 to the x. On my right-hand side, 3 to the y plus 2 is the same as 3 squared, and then 3 to the y. Because from the laws of exponents, when you multiply numbers with the same basis, we add up the exponents. So I'm going to say minus 3 to the y. Then I can factorize out. Let's say 2 to the x comes out. I'll be just left with 2 plus a 1. Okay. And then on my right-hand side, 3 to the y is common. I'll be left with 3 squared minus 1. It's fine. I'll just do that. Then if I look at, it's fine. I'll just use this space here. So when I simplify my left-hand side, I'll have 2 to the x times 3. And then that's going to be 3 to the y into 3 squared is a 9 minus 1. That is 8. Okay. So in this case, I can decide to use the same bases or something like that. Alternatively, if I keep the x's and the y's on the same side, then I'll keep the numbers on the other side, which will still give me more or less the same thing. Okay, where I'm heading to is, if I look on my left-hand side, this is 2 to the x. When I look at the right-hand side, I can match this with the 8, since I can also express 8 with a base of 2, which is 2 cubed. When I look at my left, 3 to the y, I can link it to this 3, since it's also having a base of 3 with an exponent of invisible 1. So I can use this root and just conclude that 2 to the x is the same as 2 to the 3, or the 8. And then which means x is going to be a 3. So we know that if the bases are the same, then even the exponents will be the same. Same story, 3 to the y is going to be equal to 3, and then I will equate the exponents. So y is a 1. Getting x as a 3, and then I'm having my y as a 1. This would be my approach. I don't know. Someone could also just divide so that you leave the variables on one side. In other words, that would be 2 to the x over 3 to the y. That's going to be 8 probably over 3. And then you treat the top numbers separately, and then the bottom numbers also separately. That's what I just did. Okay. Then 1.4. 1.4, they're telling us that the equations x squared plus rx plus m is equal to 0, and x squared plus mx plus r is equal to 0 have real and equal roots. They have real, but also equal. So what is in capital letters? Can we solve for the value of r and m if r is greater than 0 and the m is also greater than 0? Okay, so from the nature of roots, we know that for roots to be equal, the b squared minus 4ac must be equal to 0. Okay, for the real part, I'm not going to go into details because it's kind of obvious. The discriminant must be greater than 0. So from the first equation, that's what I'm going to focus on. My a is a 1. Our b will be r, which is the coefficient of x, and then this is going to be m. So I'm going to substitute that into this. Okay. So we're going to say b squared, which is r squared, minus 4, the a is 1, and then the c is m, is equal to 0. And then I can make, I don't know, I can isolate. Will it make sense though? Okay, I'll have r squared is equal to 4m, positive 4m. Okay, what is so special about this? Should we make m the subject or r the subject? I don't want square roots. Let me just make m the subject, which is r squared over 4. Then I'll go to the second equation and do the same thing. So from the second equation, x squared plus mx plus r. So our a is a 1, our b will be m, and then the c will be r. So when you apply the same thing, because equal roots must be equal to 0, that's going to be m squared minus 4 times 1 times r must be equal to 0, which means my m squared is going to be equal to 4r. Okay. And then I can make m the subject, but it's no good use. I can just get this and then replace it somewhere there. Where there is m, I'll put r squared over 4, so that it is r squared over 4 is equal to 4r. Now we're squaring this. Okay. And then when we square that, it's going to be r to the 4. But why can't I move this to the left? Just to make life easy for me. So that I have r squared over 4 squared minus 4r is equal to 0. You can open that up. Have r to the 4 over 16 minus 4r is equal to 0. Get rid of the 16, multiply through by 16. Okay. Oops, sorry. So that's going to be r to the 4 minus, we know that same times 16 times 16 times 16. So this cancels that. 16 times 4 is going to give us 64r is equal to 0. R is common. You take it out. I'll have r cubed minus 64 is equal to 0. So either r is a 0, or you can find r cubed is equal to 64, and then we can find the cube root of 64. So cube root of 64, I'm getting just a 4. So either r is a 0 or r is a 4. Then I can just use this and substitute into that equation of m, where we said m is going to be r squared over 4. So if we use a 0, it's going to be 0 squared over 4, which is a 0. And then if we use the 4, it's going to be 4 squared over 4. That is 16 over 4. And then the answer becomes a 4. I don't know, but that would be my approach. That would be my approach. But remember, the question told us that R is greater than 4. Sorry, R is greater than 0. And then M is also greater than 0, which means, in essence, these zeros are not going to count in our solutions. They have no use since R is greater than 0. And even the M is greater than 0. So shall go with 4 and then 4. All right, then we move on. Question number next. Question 2. Okay, so they're telling us that we're given a quadratic sequence, 20, 12, 10, 14. They want us to determine the nth term. So we need to find the first difference and then the second difference as well. So if that is a 20, come on, what's happening? Hello. The pen is leaving me there. Okay. What did I do wrong, guys? $10, $20. Okay. I think it's behaving now. Okay. So that is a 20. We have 12, we have 10, we have 14. So when you subtract this, remember it's T2 minus T1, not the other way around. So 12 minus 20 is going to give me negative 8. 10 minus 12 is a negative 2. What's happening? Did I copy the correct thing? Yes, I did. This is 20, 12, 10, 14. And then 14 minus that, which is a 2. That's correct. Then when we subtract this, negative 2 minus 8, that's going to give us a 6. Okay. But something's not right. What's wrong with my subtraction? This is a 4. Then 4 minus 2. We get a 6. Yeah, makes sense now. Okay, so then we know that our 2a is going to be equal to the 6. Divide both sides by 2, which means a is a 3. Then we have 3a plus b. It must be equated to that first difference, negative 8. But since our a is a 3, so 3 by 3, that's going to be 9, plus b is negative 8. Move the 9 that side, which means b is negative 17. Then we know that a plus b plus c must be equated to the first term, which is 20. So 3 minus 17 plus c is a 20. That's a negative 14. When you put it in the quadratic sequence, the first difference would be 148. Okay, so we need to start by determining the nth term of the first difference. Okay, and then if the Tn is 148, what position will it be? So from the arithmetic, we have a plus n minus 1 into d. Our a is going to be negative 8 plus n minus 1. The common difference is a 6 for this case. Now, if I replace the Tn with 148, and then I solve for n, so I can move this 8 that side, I'll end up with 156 is equal to n minus 1 into 6 if I divide both sides by 6, is it gonna make sense? Yes. So over 6 and over 6, I'm getting a 26 is equal to n minus 1. I'll move the one that side, which means n is a 27. So in other words, position number 27 of the first difference, that's where we're gonna have our difference of 148. Okay, so what this translates into is that in relation to the general format of the pattern or the sequence, we're gonna be looking at terms T27 and then T28. That's how it works. An example, we can see that this first term number 1 of the first difference is between T1 of the quadratic and T2 of the quadratic. Term number 2 is between T2 and T3, which means term number 27 must be between T27 and T28. All right, then determine the smallest value of n for which the Sn is greater than 10140 within the arithmetic sequence. Okay, so they specified arithmetic. So with arithmetic, which is the first difference, we said our a is -8, n is what we need. The Sn is greater than 10140. The d is a 6. Get that, and then substitute it into the Sn. It will be n over 2 into 2a plus n minus 1 into d. This formula can be obtained from the formula page. Okay. Now, I'm gonna replace this. Okay, I'm gonna put it on my right hand side and put the inequalities. Okay, so that's gonna be n over 2 into 2 times, we said our a was what? -8. Okay, that's -8 plus the n minus 1 into a +6 must be greater or equal to, we said 10140. Okay, greater or equal to 1 101 101, said what? 240 10140. Okay, then we open up the brackets. Your choice. You can start by getting rid of these two or opening it straight. I don't know, it's just your choice. That's -16. You can open this up. Plus 6n minus 6 is greater or equal to 10140. Then when I open this through, I'm gonna have -8n plus 3n squared minus 3n is greater or equal to 10140. Then I can form a standard solution. That's gonna be 3n squared. I link this up. I get -11n. I move this aside. Minus 10140 is greater or equal to 0. Then I can use my quadratic formula if I want. So -b plus minus square root of b squared minus 4ac over 2a. So -11 plus minus square root of -11 squared minus 4 times 3 times -10140. Okay, I'll divide this by 2 times 3. So if I punch this into the calculator, this is what I'm getting. Okay, minus, okay, that's gonna be plus 40. over that. So my first n is going to be a 60 if I use a plus. And then if I switch the middle sign to a negative, okay, I'm getting negative 56,3333 and so on. But remember, our positions can never be negative. In other words, we're only focusing on whole numbers, and plus positions can never be in decimals. Now, since they told us that the sum is greater than 10140, but this n is just going to give us the exact value of 10140. So I can draw the conclusion and say, therefore, n must be equal to 61 because our n is greater than 60. Okay, so n is 61. Yeah, makes sense. Okay. Then 2.2 is a sigma. Okay, you're telling us that if r is 1 up to r is 5, those are the limits of r plus b must give us 10a. They want us to determine b in terms of a. All right, let's try to substitute. So if r is 1, that's for the first time, I'm going to have 1 plus a. Okay, remember sigma represents summation or addition. Okay, so I'm adding. If r is 2, that's going to be 2 plus b. If r is 3, that's going to be 3 plus b. If r is 4, that's going to be 4 plus. Okay, I'm saying that's going to be 4 plus b. And then if r is 5, that's going to be 5 plus b. All this must be equated to 10a. So if we collect the like terms, I'm having 1 plus 2 is 3. That's a 6. That's a 10. That's a 15. Okay, that's 15 plus 1, 2, 3, 4, 5. Must give me 10a. They want us to make b the subject to solve for b. So I'm going to move the 15 that side, or I can divide through by 5 so that I have a b is equal to 2a, and then make b the subject. That's going to be 2a minus 3. I don't know. I feel like that is it. Okay, so that is 2.2. Then question number 3. Question number 3. We have the following geometric. Okay. We have 24 over x, then 12, then 6x, and then 3x squared, and the story continues. They want us to calculate the sum to infinity. So from the formula of sum to infinity, which is a over 1 minus r, what we need is a common ratio. I can use T2 and T3 for me to get that common, or I can even use T21, no problem. So if I get my T3 divided by my T2, that's going to be 6x over 12, which is a half x, or x over 2. That is my r. And then I just need to replace or substitute. So that is my first term is 24 over x. I'm dividing it by 1 minus x over 2. Okay. Then what do we do next? What do we do next? We simplify. No? Yeah. So let's apply our normal fraction kind of things. We're dividing by, okay, so when I simplify this denominator, it's going to be 2 minus x. Let me just say that over 2. Okay. Then let me just put it slightly down here. It's a lot of space. then I'm going to have 24 over x times the 2 is gonna go on top. This is 2 minus x. Okay, then I'll multiply the top part, that is 48. This and this is 2x minus x squared. So that becomes the sum to infinity. What did we do down here? So remember, these are fractions with different denominators. So look for the LCD, which is a 2. Then 2 divided by 1 is a 2. 2 times 1 is a 2. 2 divided by 2 is a 1. 1 times that is that. Then you end up with that. Remember, you need to change the sign to multiplication, and then this goes on top, that comes down. That's how you end up with that. Then 3.2, determine the values of x for which the sequence converges. Now, the condition for convergence is that -1 must be less than r, must be less than +1. These are the limits for any sequence to converge. But we found our r to be x over 2. Okay, so where there is r, we're just going to put x over 2. So that's going to be -1 is less than x over 2 is less than 1. Then we multiply through by 2. Just to get rid of this the part. So it means it's going to be -2 is less x, and then less +2. So those are the limits or the values of x for which condition must converge. And then they're asking us for which values of x would the series increase. Now, since we know that converge is just to get narrower and narrower, smaller and smaller, up to infinity, and they're telling us r has to be less than 1. So for the series to increase, r has to be greater than 1. Okay, but our r is x over 2. We can say it's greater than 1. Then solve for x, which means x must be greater than 2. And then lastly, 3.4, they're telling us that if x is a 4, can we determine the sum of the sequence to 15 terms? So we know that this sequence is geometric. That is true. That is very, very, very true. And we know that the sum of a geometric is given as a into, I'm going to say r of n, r to the n minus 1. Because if x is 4, if the x is 4, which means the r is going to be x over 2, which is 4 over 2, which is a 2. That's why I'm using this. Then over r minus 1. Okay, so our first term was 24 over x. Now that is 24 over 4, which is a 6. So 6 into our r, we said we translate it into 2 to the 15 minus 1 over 2 minus 1. So when I punch that into my calculator, it's 6 into 2 to the 15. We're subtracting the 1 over 2 minus 1. Okay, I'm getting 196,602. That's what I'm ending up with. I don't know if that's what people are getting there as well. Okay, so that's how I would have gone about that. Start by replacing the x to r to get a 2, and then find the value of a, which is the first term, and then substitute into the formula. So that is question number 3. Then question number 4, which is functions. Come on, what's happening? Okay, thank you. The graphs f of x is x plus b squared plus q. This is a parabola. F. G is a over x plus b plus c. This is a hyperbola. Okay, parabola, because we're having a square somewhere. Hyperbola, because the denominator is having x. They have the following properties. They're telling us a, which is 5 over 2 to 0, is a point on f. Where is a? Okay, where is it? P is the turning point. Okay, thank you. Vertical asymptote passes through 1. Okay, horizontal passes through 2. Thank you. G passes through the origin. All right. Then they're asking us to show that the equation of G can be written in this format. So remember, G, we said, is the hyperbola. So what usually happens is we're saying it is C A over x plus b plus c. Okay, so what normally happens that B represents the vertical asymptote, and then C represents the horizontal asymptote. So I'll start by substituting those. So A over, since this vertical is a 1, I'm going to switch the sign there and make it -1. The horizontal is a 2, it maintains its sign. Then we need to get one more point that is not part of this. And that point can only be found by O, which is the origin. So we need a point that G is passing through. The only point is the origin. We know that with the origin, X is a 0, and then Y is also a 0. So we just replace, substitute into this formula and solve for A. So 0 is equal to A over -1 plus 2. Move the 2 that side, you're going to have a -2 is equal to A over -1. Multiply both sides by -1, which means A is a 2. What was the question asking for? Show that the equation of G can be written as this. Now, I know there are learners that will just put the equation just like that. This question is, in other words, telling you to prove that the equation of G is this. So when you substitute those values of yours, we're saying G of X or Y is equal to A, which is a 2, over X minus 1 plus a 2. Please and please remember, G of X, F of X, they all represent just a single value Y, single letter Y. And then they want us to get the coordinates of P. So what we know about P, is there anything we know about P? No. We know nothing about P. Only thing we know is that P is a turning point where X is what? Where X is a 1. Why, we don't know. But when you look at the format that was given of the parabola, remember we have 3 formats. This format is the turning point format, where P represents the X value of the turning point and Q represents the Y value of the turning point. So I'm just gonna try to do the substitution, and f of X, we said it's a Y, is equal to X. P is the X coordinate of the turning point. And this we say it's a 1. Okay, we can see it's a 1. So we're gonna switch that sign from a positive to a negative. Okay, we're saying X minus 1. We square that. Plus the Q that I don't know. Okay. Then I'm going to need another point that this graph is cutting. The graph of F. And that point is A. So at A, we're saying that X is 5 over 2. And then Y is a 0. So I'll say 0
is equal to 5 over 2 minus 1. I square that plus a q. Okay. Then I just use my calculator, saying 5 over 2 minus 1 squared. I'm getting 2,25. We can always give it as a fraction, no problem. So 9 over 4 plus q is a 0, which means q is negative 9 over 4. Okay, so what was the question asking for? The coordinates of P. So we're saying P is going to be 1 and negative 9 over 4. So we need to just go through all of this. We need to show all the workings and obtain the marks. Then 4.3, they want us to determine the vertical asymptote of P. If P of x is the same as G of x minus 1. So they're getting the graph of G, okay, and then they are shifting it 1 unit to the right because it's a minus 1. So when there's a minus, you're shifting to the right when it is next to the x. If it's a plus, you're shifting to the left. So in this case, what I'm going to do is since our graph or our asymptote is here and they're telling us it's shifted 1 unit to the right, so which means this is going to be at 2. So which means we're just going to say x is equal to 2. That's why it's 1 mark. Then determine the equation of the axis of symmetry in the form of this. If m is less than 0. Remember, for axis of symmetry of a hyperbola, it's always given as y is equal to x plus c if the m is positive, or negative x plus c if the m is less than 0, or if the gradient is negative. Okay, so now we have the general format. What we need is just the values of x and y that we're going to substitute. Now the values that we substitute will be the asymptote values, which is 1 and 2. Okay, so where the asymptotes intersect. So we said at 1 and 2. So where there is y, I'm going to replace or substitute with a 2. Okay, and then where there is x, I'll replace it with a negative 1. Then I solve for c. So I put that negative on that side. So c becomes a 3. So my equation is going to be negative x plus a 3. Then 4.5, they want the equation of k if k is the reflection of g above the x-axis. Remember, it's a hyperbola where we said it's x minus 1 plus a 2. So when you reflect above the x-axis, let's go back to the graph. So if we have this point here, okay, I'll call it negative 2, okay, this point, negative 2 and 2. When you reflect it about the x-axis, this point must move in this direction, downwards, but it will be just the mirror image of each other. So the x is maintained, but then the sign on the y is the one that changes, okay? But since we see the whole of this represents the y, I can just introduce a negative sign in front of that thing, and then I'll be good to go. Okay. So what happens, or what I was doing, is introduce a negative sign then. When I introduce the negative, it's going to be negative 2 over x minus 1. Then this negative affects that positive, and then it ends up being a negative 2. So that becomes the equation of k. So k of x is equal to that. All right, so this is the equation that they want. The bottom sign will not be affected since it can only affect it once. Then for which values is f prime of x times g prime of x greater or equal to 0? What does this mean? So we know that f prime will represent the gradient that we know. And then they're talking about the g of x to be greater than 0. So we're looking at a scenario where this is positive. In other words, it's above the x-axis. And then the gradient of f is also positive. Does that make sense? No. Does it? Yes. Where is f? F is the parabola. Gradient is positive just from this point, moving in that direction. It's increasing. And then the g, we said it's just above 0. The g is above 0 between positive 1 and the positive infinity. But g can also be above 0 between no, the g is equal to 0 at this point, and it's below 0 within this point. Okay, so scenario number 1, either I focus on this upper part where the g is on top, and then the x, this f is also above. Okay, but we know that g cannot be equal to the 1. So what I'm going to say is that x should be greater than 1. That is condition number 1. Then the other condition is if the gradient is negative of f, and then this graph is below. So we're looking at the positive and the positive to be greater than 0, or negative and negative to be greater than 0. So both graphs to be below. Okay, so where do I find both graphs to be below? So between 0 and 1. That's why I'm saying both graphs to be below. This one is below, then this one is decreasing. So we're going to say 0 less x less 1. That's also another condition. So 0 less x less 1. So these are the two options we had. Then for which values of x, sorry, k, or the equation g of x, which is x plus k, have two real roots, but of opposite signs. Okay. So which one is g? G is this 2 over x minus 1 plus 2. So what do they mean by two real roots? So roots are basically the x-intercepts. Okay. So we shall say that k must be greater than 0. Then the graph will have those two roots. Okay, so k has to be greater than 0. That is question number 4. Question number 5, they're telling us the graph of h is given as that, where a is greater than 0. They sketch it for us. Okay, then they want the coordinates of q. Is q the y-intercept? Looks like. Okay, so if it's a to the x, we know that at q, x is a 0. Okay, which means a to the 0, which is a 1. So the coordinates will be 0 and 1. Then for us to get the value of a, we just need one point, which is p. So we're going to say y is equal to a to the x. Our y is a half, that is a to the negative 1. Okay, you can change that, or you can multiply by the reciprocal. Okay, so that is a half is equal to the same as 1 over a. Do your cross multiplication, which means a is a 2. Okay, so you're getting a as a 2. Then they want us to write the inverse. So if a is 2, which means y is 2 to the x. 2 to the x. So how do we write the inverse? Okay. So remember, for as long as it is exponential, then the inverse is just going to be a log graph. So that is log, the base is at 2. Then we just put the x there. Then we're done. All right, then sketch the H inverse in your answer book, clearly show the intercepts. So if I sketch it just here, they don't necessarily have to be together, but let me just put it in. So remember what we said, if this is 0 and 1, you switch the points, call this the 1 and 0. Okay, if this is negative 1.5, then we're going to look at a half and negative 1, probably somewhere there. So this graph is going to move just in that sort of direction. It will move towards the y-axis. So this is going to be the inverse. So say h negative 1. Or you can call it the log something something. Okay, so that is that for the sketching part. Then they want us to write the domain of the inverse. So domain of the inverse is the same as the range of the original. Okay, let's see if that's going to make sense. The range here would have been y to be above 0, since the x-axis is the asymptote. So y must be greater than 0. So when they talk about the domain, you can see that this graph does not cut this y-axis where x is a 0, but rather it just tends towards it and then moves to the right. So we can say that x, since domain represents x values, x is greater than 0. Okay, then we move on. They're telling us hence or otherwise. Okay, hence or otherwise, can we determine the values of x for which the log x base 2 is greater than 1. The values of x for which the log x base 2 is greater than 1. In other words, it's above 1 on the y. Good people, what do you think? What do you think? The log x base 2 is greater than 1. So from our graph, remember we said this was a half, and then this was negative 1. They want it above 1. We can go back to the original, which is 2 to the x as our y. If we replace x with a 1, okay, 2 to the 1, our y is just going to be a 2. So which means the coordinate of the original would be 1 and a 2. Okay, let me just put it there. So if x is a 1, the y here is going to be a 2. So that's 1 and a 2. So if I'm to draw my point, this one, on the inverse, it's going to be somewhere here, which is 2 and a 1. Now, the question is asking us, for which values of x. Okay, for which values of x is this greater than a 1? So we can see that at this point, that's where the 1 is. For it to be greater than 1, this is the section of interest. And in that case, the x has to be increasing. So I'm going to say x has to be greater than a 2. Okay. I'm saying x has to be greater than a 2. That's my opinion. Okay. Then 5.7. 5.7. Okay. So with 5.7, if g of x is given as 100 times 3 to the x, they want us to calculate the value of x for which h and g are the same. Where is h? We said h is 2 to the x. No? Yep, 2 to the x. Let's see. So for x to be the same as g of x, so 2 to the x is the same as 100 times 3 to the x. Okay. Then, yeah, perfect. Then we need to apply the right mechanisms. And this question might require the logs. Fine, I'll divide both sides by 3 to the x, 3 to the x. So this and this cancels. Then I'm going to have 2 over 3 to the x is equal to 100. And then you have to introduce logs. This is not usually taught since we no longer teach the laws of logs in details. Okay, we just focus on the power rule. But if we introduce logs, you can say log on both sides. So this x will come that side since we have now 2 powers. So x log 2 over 3 is equal to the log of 100. So the log that we are introducing is more like a base 10 log. So that's 2 over 3. Then divide both sides by log 2 over 3. By log 2 over 3 by the log 2 over 3. Okay. So in this case, we have we can say log of 100. Okay. Over the log, I said log, guys. Okay. 2 over 3. And that gives us negative 11,358. Something like that. Something like that. That's what I get. Okay, then that's what would have happened anyway if this question was to be asked. Then the next question, which is question number 6. Question number 6. They're telling us that the graph f of x is negative 27 negative root 27x, where x is greater than 0. P is that point, lies on the graph of f. Okay, so we have restricted functions. Then use the graph to determine the values of x. Use the function to determine the values of x, where f of x is greater or equal to negative 9. So when you look at this point, that's where we find our negative 9 for the y. And then the value for -9 or for f of x to be greater than -9. We're talking of this region where okay, it's between 0 and this 3. Those are the values of x that we're focusing on. So we're going to say 0 is less or equal to x, less or equal to 3. Since they said equal or greater. Okay, then 6.2. 6.2. Write down the equation of the inverse in the form of y, and we need to indicate all the restrictions. So if our original is negative, we said square root of 27x. Let's just confirm it. Don't want us to do our own things. Okay, and it gave us the restriction of x being greater or equal to 0. When we are finding the inverse, remember the rules still stay the same. We switch these variables. So you're going to have x is equal to negative square root of 27 with y. So we're also going to keep the condition and we say y must be greater or equal to 0. Then for us to get rid of everything and make y the subject, we need to square both sides. So if I square this, then I square that, I'm going to have x squared is equal to just the 27y. Then I'll divide both sides by 27. So y becomes x squared over 27. And then what's going to happen here is that x must be less or equal to 0. Since we're no longer dealing with the roots. So x must switch the condition. Okay, so that is 6.2. Then they want us to sketch the inverse. In the answer, indicate all the intercepts with the axis and one other point on your sketch. Okay, so what I can see is that since this is 3 and -9, we can play around with it and switch it around. So that's going to be -9 and 3. So -9 could be somewhere there. Oh, anyway. And probably 3 could be somewhere there. Then we have the 0 point, that is fine. So we can already see with these 2 points where the graph is heading to. So we can have something like that. So since they asked for an extra point, just use that one. Yeah, call it -9 and then 3. That's the quick one to use. Or if you have time, yes, you can replace it with the 1 and what and so what you end up with. But remember, we're saying x must be less or equal to 0. So if you put a -1 there, you're going to have a decimal somewhere there. So any other point just on the left would make sense. Then now, done, we need to describe the transformation from f to g. Okay, remember, f was -√27x, and now g is square root of 27x. Still the condition is the same. So the only difference is the negative sign. And we said if there's a negative sign or there's a positive, it's just a reflection above the x-axis. A reflection using the x-axis as a mirror line. So we're going to say that is a reflection in the x-axis or the horizontal axis. All right, so that is question number 6. Then 7, this is a finance question. They're asking us at what annual percentage interest rate compounded quarterly should a lump sum be invested in order for it to double in 6 years. So the question wants us to get the I. Do we know the P? No, we can call it X. Do we know the A? We can just call it 2X. Then what's the N? It's a 6. But we're compounding it quarterly. So it means it's going to be 6 times 4. which is a 24. Okay, so from our compound interest, we have p into 1 plus I to the exponent of n. So it's saying 2x is equal to x into 1 plus I over 4 to the exponent of 24. This cancels that. So then I'm having 2 is equal 1 plus I over 4 to the exponent of 24. Then I can find the 24th root on both sides. Or what people normally do is they get the reciprocal of 24, which is 1 over 24. Like 1 over 24, and then to the exponent of 1 over 24. No problem. If I find the 24th root, you can just use the cube root, and then you remove the 3, and then replace it with the 24. We enter our 2. We're getting 1,02930. I'll just give quite a number of decimals before my final answer. Then I'll move the one that side. I'll have 0,02930 is equal to I over 4. Then I'll multiply both sides by 4 and then multiply by 100. Okay, so I'm getting my I as 11,2%. So that is 7.1. Okay. And remember, this person is investing just a lump sum. So we cannot confuse it with annuities. 7.2, they're telling us that Simon buys furniture to the value of 10,000, but he decides to borrow the money on 1st of February 2020 from a financial institution that charges this much, compounded monthly. This guy agrees to pay $450 per month. Okay, the agreement of the loan allows him to pay equal monthly installments from the 1st of August. When did he borrow the money? 1st of February. Oops, okay. So calculate the amount owing to the financial institution as of the 1st of July. So between 1st July and then 1st February, how many months are there? Those are basically this like 7 minus 2, which is like 5 months that we're talking about. So which means this money is going to grow for 5 months using compound interest. So A is equal to P into 1 plus I to the exponent of n. Our P is the 10,000 into 1 plus, remember the I we said is 9.5%, compounding it monthly to the exponent of 5, since it's already in months. Then we punch that into our calculators. That's 1 plus, so it's 9.5% over 12 to the exponent of 5. Okay, I'm getting 10402 from 15 friends. Okay, so that is what this guy must pay back. Okay, then how many months will it take Simon to repay the loan? So they want us to get the n. Okay, but since this is a loan and this guy is going to be paying monthly installments, then it forms what we call an annuity. Okay, but which type of annuity is it? It's the present annuity, the P value. Okay, the P. So we use the P formula where we say that the PV must be equal to X into, that is 1 minus 1 plus I to the exponent of negative n. We're dividing it by I. So the value, the answer we just got now will become our P. So we're saying our P is 10402,15. Interest rate is 9.5 compounded monthly. And then the X is going to be the 450 that we know. Okay, so I'm just gonna say 10402,15 is equal to 450 into 1 minus 1 plus, say, 9.5% over 12 to the negative n over 9.5% over 12. Okay, so we can start by simplifying these two before we take them that side. Or you can take this aside and then you divide, whichever one is simpler. So I'll say 450, I'm dividing it by 9.5% over 12. Okay, getting a big answer. So 10402,15 is equal to 56842,105 into 1 minus. If I simplify this bracket, percent 1 plus 9.5% over 12, 0.007917 to the negative n. Then divide both sides by 56842,105. So 1040 said 56842,105. So those two will cancel. Then 56842.10. Okay, that's giving us a small answer. Small answer is 0.183 is equal to 1 minus, said 1,001. It's a 7. Yellow. 7917 to the negative n. Okay, then I'll move the one that side. 0.183 subtract 1. That will give me negative 0.817. I'm getting a negative 1,007917 to the negative n. So this negative and negative will give us a positive. Okay. But remember, with this n of ours, there's something we didn't do. And I think we need to do it just to be on a safe side. We did not include the 12. I don't know, we can, it's fine, let's include it then. So that we are safe at the end, okay? So that's a 12, and that's also 12, okay? Then from there, you have to introduce your logs on either sides. It's going to be, this is the base. So I'll have negative 12n is equal to the log. That's the base, which is 1,007917. Then that's 0.817. And I punch that into my calculator. 1,007917. And that is 0.817. That's giving me negative 25.63. Then I'll have to divide both sides by negative 12. Okay, I divide that by negative 12, end up with 2,135 something. It's 2, but why did I multiply by 12? If I may ask myself, what is the question asking for? How many months? Yeah, we're on the right track now. We have to multiply by 12. Okay, we can just see this representing the number of months. Okay, so this is 25. It's going to be positive. Okay. Because the number of years is just going to be 2,1359 years. Again, multiplying it by 12 again, going to be moving back and forth. Okay, nevertheless, if we round this off, it's just 26 months. Cos 25,3. Remember, the 12n is representing how many months in total. All right, then, oops, that is that. That's what you had to do. Then, what is the balance of the loan immediately after the 25th payment? So, we need to find the outstanding balance. So, since this is a present value, and we say that with the present value, we have 450 as the payment into 1 minus 1 plus, say 9.5% over 12. I will say 9.5 over 12. Now, the period that we're talking about is the period that is left. Now, since we agreed that we're going to take 26 months, yeah? Since we got 25, something, and we rounded it off, because we need another month for it to work out. Now, since this guy has now made 25 payments, how many months are going to be left? We can go back to the original answer, and then we subtract the 25 or 26. We subtract the 25, no, it's not making sense. Can't say that. That is wrong. If we get, let's say, 25,63, and then we subtract the 25 months, we left with 0.63. In other words, it's just a fraction of a month. Okay. So if we punch this into our calculator, guys, it's going to depend on your rounding also. Okay. If you use a lot of decimals, your answer might be slightly lower than ours. If you use few decimals, your answer could be slightly higher, but just it's within the same range of decimals. Okay, then we have 9.5% over 12. So I'm getting 281.68. 281.68. So this is how much it's going to be left. You round it off, roughly 282 rands. Okay, so that is question 7. Question number 8, which is calculus. Okay, determine the f prime of x. If f of x is 3x squared plus a 2x. Okay, so from what is it? From the formula page, there is that limit as h tends to 0, f of x plus h minus f of x over h. This is the formula we use for first principles. Then, since we were given the f of x as the 3x squared plus 2x, we need to find the f of x plus h. In other words, where there is x, we're just going to replace it with x plus h. Okay, so that's going to be 3 into x plus h, we square that, plus 3 into x plus h, minus brackets 3x squared plus 2x over h. We're saying the limit as h tends to 0. Okay. Then we're going to open up using the FOIL. So limit as h tends to 0, we have 3 into x squared plus 2xh plus h squared plus, that's going to be 3x plus 3h. I can open this up, which is 3x squared minus 2x. Everything is over h. Then the limit as h tends to 0, simplify that. I have 3x squared plus 6xh plus 3h squared plus 3x plus 3h minus 3x squared minus 2x. Now, whenever we deal with first principles, certain things have to cancel. So this is cancelling with that. Okay. What else is cancelling? Nothing. So we just need to work around this and work around that. Okay, yeah. So what we see is the limit as h tends to 0, just left with this. Something doesn't add up, guys. What did I do wrong? Why did I put a 3 up there? Yo, Modimo. It looks like I'm tired. This is a 2, not a 3. So this is a 2x and a 2h. I'm wondering why the 2 is not cancelling out. Okay, so this is a 2x. So this cancels that. Yeah, then factorize out the h. So you have 6x plus 3h plus a 3. Everything is over h. And that one is over h. Then cancel the h. This h cancels that. And then the limit as h tends to 0, that thing is going to fall off. Okay. Then we have 6x plus a 3. So that is going to be the first principles. Okay. Then 8.2. 8.2. They want us to find dy dx. Interesting. So whenever we have root signs, change them into exponents. Okay, so that's going to be y is equal to 4x to the exponent over half minus 8 over x to the exponent over half plus pi x cubed. Then 4x to the exponent over half minus 8. Let's take the x to be numerator. It's going to be negative a half plus pi x cubed. So since we are deriving with respect to x, we can now say our dy dx is going to be a half times 4, which is 2x to the negative a half. And this a half negative times negative 8, that's going to give me a positive 4x. When I subtract a half, just get a negative 1. Then from there, the 3 comes that side, it's going to be 3 pi x squared. I could leave it like that. 2x to negative 2 plus, oops, what's wrong with me? You say it's not minus 1. So it's subtract 1 there. That's negative a half minus 1, which is negative 3 over 2. Instead. Okay, guys, 8.3. So that is 8.2. Then 8.3, the graph of g of x is x squared plus b over x equal 96. It has a minimum at this point, right, with the values of a and b. So when we talk of minimum, maximum, talking about the first derivatives. Okay. So what we're going to do, we're going to differentiate this. Okay. And after differentiating it, we equate it to 0 when x is a 4. Because when they talk of a minimum, this is like a turning point. And we know that the gradient at the turning point is always 0. Okay, gradient is always 0 at the turning point. And the first derivative represents the equation of the gradient of the graph at any point. Okay. So what we do, we have ax squared. Let's see if it's gonna make sense. If it doesn't, we leave it now. 8.3. Okay, so we have ax plus b over x. Okay, 96. Then x is a 4. So we said, let's get the first derivative. So that's gonna be ax squared plus bx negative 1 is equal to 96. Okay. Then divide x. Okay. Divide x, it's gonna give me 2ax minus bx negative 2. This is gonna die out. Is equal to 0. Okay, so we have 16a plus 32. That's gonna give us 48a is equal to 96. Then 96 divided by, oh, that's it. I'm not mistaken. Yeah. So that's it. Then I'll get this 2, replace it there. So which means 128 times 2, we get the 256. Okay, so that is how that question would have been done. Okay, then question number 9. Okay. You're telling us that the graph of h, which is negative x cubed plus x squared plus bx plus c sketched below, give us the values of a and b to be 6 and 0, which are the turning points. Then t is 3 and y is a point on h. Then the graph of h passes through the origin. Okay. So having read that, they're telling us to show that a will be a 12 and b will be a negative 36. Okay, so we have number 1, b is a turning point, and also a is a turning point. Okay, then we know that since the graph is passing through the origin, the c is going to fall out since c is going to be 0. So we only going to be having negative x cubed plus ax squared plus bx. Okay. If I use this point first, and then I substitute. So 0 is equal to, what is 6 cubed? Which is 216. Plus 6 squared, it's going to be a 36a plus 6b. And I just make this an equation. I'll have 36a plus 6b must give me 216 positive. I can divide through by 6. 6a plus a b must give us, we can get 36, which is true. Then make b the subject, which is 36 minus 60. Cover the first equation. And the marks are there. So if that is the first, there are 3 marks. Oh, why are we doing that? Okay, it's fine. Let's see if we can get them. Then let's find the first derivative. First derivative, which is dy dx. That's going to be negative 3x squared plus 2ax plus a b must give us a 0. Okay. Having done that, I feel like this is a long route. Yeah, it's a long route, but it's fine. Let's see. When I replace x with a 6, That's going to be negative 3 times 36, which is 108. It's negative 108 plus 2 times 6, which is 12a, plus b must give us a 0. But we said our b is this. So negative 108 plus 12a plus 36 minus 6a must give us a 0. So this and this is going to give us a 6a. Negative 108 plus 36, getting a 72. Then I'll divide both sides by, wait a minute. This is positive 6, that's a negative. Okay. So 72 divided by 6, we're getting 12 for A. Then I can replace this 12 here. And then my B is going to be negative 36. Okay, so that is one way of getting that, in as much as the marks look too small for all that I've done. Alternative number 2 could be using the factor method. Since we have this as a turning point and an intercept as well, which means I'm going to have x minus 6 squared. And then this point also is an intercept with the root, which means I can also have x minus 0. Must give me a 0. If I try to open this, I'll have x squared minus 36. Oh, 36, man. It's 12x plus a 36. And then I'm multiplying by x, which is x cubed. Something's off here. Because with this opening, it's meant to be negative. It's fine. Let me keep an a there, just in case. Okay, x cubed minus 12x squared plus 36x. That is my y. Then if I try to substitute 6 and 0, is it going to make sense? Because now this is meant, with this opening, the a is meant to be a negative. That's what I'm saying. With the way the, oh, it's already here. What's wrong with me? So that's a negative. Okay, so if that's a negative, then it's negative x cubed plus 12x squared minus 36. I think we can use that and then get those answers directly. Whichever way, all we need are the answers. Then they want the coordinates of A. We found the first derivative, didn't we? It's fine, let me just find it again. So coordinates of A, we need the first derivative, which is going to be dx, which is negative 3x squared plus a 24x minus a 36 is equal to 0. And then we solve using either the quadratic or the factor method. You can even start by dividing 2 by 3 if you want. So if I use my quadratic, that is negative 3, we have x squared plus 24 minus 36. Getting x as a 2 or x as a 6. So since we're focusing on A, A is going to be a 2. And get this 2, you replace it into the original. So when that happens, our y that we end up with is going to be negative 2 cubed. That's correct. Plus 12 times 2 squared minus 36 times 2. I'm getting negative 32. Okay, so negative 32 becomes the answer. Then they want us to get the value of y around about here. So if x is 3, what is y? So just replace that. Negative, we have 3 squared, no, 3 cubed, plus 12 times 3 squared, minus 36 times 3. Okay, so that is giving me negative 27. And they're asking us, is this graph concave up or down at point T? Okay. What do you think, guys? So we need to find the second derivative. And then at the second derivative, where there's x, we're going to replace it with a 3. So this is going to be, let me just say f double prime x. That's going to be negative 6x plus a 24. When I replace x with a 3, it's going to be 6 times 3 negative plus a 24, which is a 6, because that's negative 18 plus 24, which is a 6. We can see that 6 is greater than 0. Okay, so which means the graph is concave up. So we can say graph is concave up, since the second derivative of x, let's put 3, is 6, which is greater than 0. Okay, just at point B. Then determine the coordinates of the point of inflection. So the point of inflection is okay, so we're saying for the point of inflection, we need to find the second derivative. We need to find the second derivative and equate it to 0, which we got. Okay, so we said negative 6x plus 24 must be equal to 0. Move the 24 that side, negative 6x is equal to negative 24, which means x is a 4. Then we need to get this 4 and then substitute it into the original. So we're going to have negative 4 cubed plus 12 times 4 squared minus 36 times 4. And then that is going to give us negative 16. So which means the point of inflection is 4 and negative 16. Number 10, which is also calculus. They're telling us that a hotel has 72 rooms that it can let to clients. The daily rent per room is 500. Then if the rent is now increased by 100 rand per day, 2 rooms are going to be left vacant. And then the rent is around x per room per day. X must be greater than 500. Can we show that the total daily income is given by that? So what we need to know is we need to set up equations or expressions just for what might be happening here. As an example, if you look at the rooms and the income that is coming through. An example, if I talk about rent being 500, And then there was another scenario where they said if the rent is increased, so if we increase it, it's going to be 600. So what's going to happen? How many rooms are there that are rented? We're saying there are 72 rooms. Okay. And then if the rent was increased to 600, then it will only be 70 rooms available. Not so. Yeah. Then what would be the income? What total will be collected? So if it's 600, that's going to be, does it make sense though? Because it is 600 by 500. The rent is 500. Now the rent is 6. With this much. Let's see what we have. So what we're saying is that originally, if we have 500 and all rooms are rented out, it would give us the 36,000. And then if it is 600 and only 2 rooms are left empty, we could have the 42,000. Okay, so how do we now work this out? Where x is greater than 500. So we need to look for the total increase or the rate at which the increase is taking place. So we can say if we have x minus 500 over 100. Okay. X minus 500 over 500, and then this is going to be multiplied by okay, so I'm going to say 72 minus the rate that is causing everything to decrease, because now if 2 rooms are left vacant, then the rate kind of decreases. If we try to open this up, it's going to be 72 minus what's 2 times x? That's going to be 2x minus 1,000. We're dividing it by, no, this must be plus. We're dividing it by 100. Is that true? Yes, it's true. Then if we divide that, it's going to be so 72 minus, I'll say 2x over 100, I'll say x over 50 in this case, plus now 1,000 divided by 100, that's going to be a 10. And then 72 plus 10, that's going to be 82. What happened to the x? I don't know. We shall see. 82 minus x over 50. Okay, but now all this again must be multiplied by the number or by the income that is increasing. So we get the 82x minus x squared over 50. Then 10.2, they want us to get the maximum daily income. So with maximum daily income, we have to differentiate. We need to differentiate that. So if we differentiate that, that's going to give us 82 minus x over 25 equals to 0. Move that aside, so x over 25 is equal to 82. Then multiply both sides by 25. So 82 times 25, getting 2050. So that is the daily income. Question 11. telling us events A and B are mutually exclusive. So mutually exclusive simply means they cannot happen at the same time together. Probability of B is twice probability of A, and probability of A or B is that calculate B. So from the addition rule, you know that probability of A plus probability of B minus probability of A and B. But for mutually exclusive, this whole part is a 0, so it doesn't count. Let's substitute A or B is 0.57 is equal to our A. Let's leave it as A. And then our B is twice A. And then 1A plus 2A's, those are 3 PA's, is equal to 0.57. So if we can find the A, which is 0.57 divided by 3, that gives me 0.19. Then we need to just substitute this to get the B, which is 2 times 0.19. And then that must give us 0.38. Okay, then 11.2, they're telling us a box of 40 calculators is sent to a store by a supplier. The owner of the store is not aware that 5 of the calculators are defective. 2 calculators are selected at random from the box, the first one not being replaced before the second one. What is the probability that the first calculator chosen is not defective? So 5 of the calculators are defective. So for the remaining ones that are not defective will be 40 minus 5, which is 35. Okay, we'll divide by 40. 35 divided by 40, we simplify that, can give it as a 0.875, or you simplify and give it as a common fraction. Okay, then what is the probability that if 2 calculators are selected, one calculator is defective and the other is not? So if we were to draw just a simple tree diagram, defective, not defective, then defective and not defective, defective and not defective. Okay, so for the first part of it being defective, it will be 5 over 40. We're saying 35 over 40. And then if it was defective and then another one is defective, then it's going to be 4 over 39. And then okay, so we have 4 plus 3, which gives us a total of 7. So 7 factorial. Just use your calculator and find that. So that's going to be 5040. That's the answer. Then they're asking us that if 2 particular books must be placed next to each other, in how many different ways can you arrange the books? So if we have 1, 2, 3, 4, 5, 6, 7, they're telling us if 2 books can be placed together, in how many positions can we place them? So it's going to be position number 1, position number 2, position number 3, position number 4, position number 5, position number 6. So in other words, we shall have 6 different positions to place these 2 books. Okay. Times the arrangement of the 2 books, they can switch. Maybe book 1 and book 2 can come first and then 1 can come next. So that's going to be 2 factorial. In how many different ways can you arrange the books and show? So 6 factorial times 2 factorial. So from my calculator, we have 1440. Okay. Then if all the economics books must be placed next to one another, and all the life science books must be placed next to one another. In how many different ways will you be able to arrange the shelves? Now, step number 1. We have, let's see, 2, 3, 4, 5, 6, 7. We have 4 books that are going to move as a block. And I see it's just one position that we can, no, it's not one. But that's 1. We can have the second one. Okay, 4. And have this as a 4. And have this as a 4. But will it accommodate the other ones? Because now that's one other thing that we need to bear into mind or into consideration. So I'm just going to say the 4 books and switch within themselves, because it's not only the economics books that we're focusing on. So I'm going to have 4 factorial, and then with the life sciences, which are 3, I'll also set 3 factorial. And then the 2 books can sit together, because this clearly is not going to work of the shifting. So it's only one kind of arrangement for 4, one arrangement for 3, and then the books can switch within themselves. Okay, so we're saying this is not working. It's just 4 factorial within the economics books times 3 factorial within the life science books times 2. And then when I multiply that together, I'm getting 288. Thank you very much, guys. Let's meet in paper 2. So there are 2 ways to this. We can use the vectors, where we look at the product being 12 and then the sum being negative 7. So which 2 numbers do we multiply to give us 12? But when we add those numbers, we must get negative 7. So if I use the vector method, whereby I have my 2 brackets equal to 0, it's going to be x minus 4 and then x minus 3. Because negative 3 and negative 4 will give me positive 12. When I add negative 3 and negative 4, I get a negative 7. So with this first bracket, I will equate it to 0 and say either x minus 4 is 0 or x minus 3 is equal to 0. So which means if I solve for x, my x is going to be 4 or x is going to be a positive 3 that side. And then I'll be done with that. Alternatively, someone can also use the quadratic formula, whereby your a is 1, your b is negative 7, and then your c is 12. And then all you have to do is substitute. Plus minus, you said it's a b squared minus 4ac. Everything is divided by 2a. And then when you substitute these values into the formula, you should be able to get the same answers. Alright, then 1.1.2, they're telling us that if we have x into 3x plus 5 is equal to 1. Now, whenever they tell you that you must give your answer correct to decimal places, in most cases, they need us to use the quadratic formula. Okay, so what I'm going to do, I'll start by opening up this and create a standard form of this equation. So that's going to be 3x squared, and then x and 5 is going to give me 5x is equal to 1. Then I can transpose this one to the left. So that is 3x squared plus 5x minus 1 is equal to 0. Okay. Then from there, I can tell that my a is a 3, my b is a 5, and our c is negative 1. And then I'll just substitute this into the quadratic formula. We said negative b plus minus square root of b squared minus 4ac. Everything is divided by 2a. So my b is a 5, so that's going to be negative 5 plus minus the square root of 5 squared minus 4, my A is a 3, and my C is a negative 1. All this is divided by 2 times 5. Okay, I may choose to do just a substitution and get my answers straight away, or I may try to simplify it further so that I have a negative 5 space plus minus. I know that my 5 squared is 25. This is 4 times 3 is 12 times that, which is going to be like 25 plus 12 over 10. Okay, when I put that into my calculator, that's negative 5. I'll start with a plus sign. Square root of 25 plus 12, dividing it by 10. Come on. I'm getting 0, 1 something. That is just a moment. So say negative 5 plus square root of, that is 5 squared. Sorry. Our A is a 3, not 5. Sorry about that. Our A is a 3. So which means the first x is going to be 0,18. And then I'll just replace the plus with a minus sign, this minus sign here. And then my x is going to give me a negative 1,85 from round it off to decimal places. So those will be our two answers. The 0,18 and then the negative 1,85. Then 1.3, being told that if we have x squared is less than negative 2x plus 15. So since the highest degree is a 2, or the degree of the equation is a 2, we can create a standard form so that everything is on one side of the equal signs and then the 0 is left on the other. So I'm going to move this 2x that side and then the 15 that side also. So that's x squared plus 2x minus 15 is less than 0. Okay, so we're seeing a quadratic again. We can use the quadratic formula or we can use the vectors. So if I use the vectors, the two numbers I multiply to give me negative 15, and then when I plus them, I will get a positive 2, only see negative 3 and positive 5. Multiply this, I get negative 15. I add those two, I get a 2. Then that's going to be x minus 3, and then it's going to be x plus 5 is less than 0. So from this, if there were no inequality symbol, and I assume there was just equal signs, I'll get solutions which I'm going to call my critical values as positive 3 and negative 5. Okay, but since it's an inequality and we're having a less than symbol, then this is going to be represented as the smaller number being less than the x and then being less than the bigger number or bigger value. So which means my final solution is going to be negative 5 is less x and then is less positive 3. I would prefer presenting it this way, though there are other ways of doing it. Some people can draw the graphs and so on. And then 1.1.4, we have the root of 2 into 1 minus x is equal to x minus 1. So in normal cases for such questions, we advise learners to leave the root sign on one side and everything must be on the other. So this has already been done for us. So the only thing I'm going to do I'm going to introduce a bracket by the right hand side. Okay. Now for me to get rid of this root sign, you know that we have to square both sides. Square that, then I can get square that and remove put another bracket. Okay, so this 2 is gonna kill the root sign so that I'm just left with 2 into 1 minus x. When I open this up, I'm gonna have 2 minus 2x is equal to, when I open this, we can FOIL it, x minus 1 and then x minus 1. That's going to give me x squared minus 2x plus a 1. Then I'll create a standard solution. I can move everything to that side. There's no harm in that. Yeah. So that's going to be x squared minus 2x. That's going to be plus 2x. We have a plus 1. When the 2 goes that side, minus 2 is equal to 0. Then this is going to cancel that. And then plus 1 minus 2 is going to give me minus 1 is equal to 0. So this is a difference of 2 squares, whereby x minus 1 and then that's x minus plus 1 is equal to 0. That is if I factorize using the difference of 2 squares. And then when I solve this bracket, either x minus 1 is a 0 or x plus 1 becomes a 0. So I can see that this one is going to give me x to be positive 1, or my x is going to be negative 1. Alright, now whenever we have a square root kind of question, we always advise to go back to the question, to the original expression, and test which of the values will satisfy the expression, and then we choose. So in this case, if I use 1, that's going to be like the square root, let's say on the left hand side, it's 2 into 1 minus 1. What am I getting here? I'm getting the 0. On the right hand side, I'm having x as a 1, so that's going to be 1 minus 1, which is also 0. So this one works, or that one satisfies the equation. Let's try the negative 1. On the left hand side, we have the square root of 2 into 1 minus minus 1. Okay, I know that 1 minus minus 1, that would be a 2. 2 times 2 is a 4. Square root of 4 is 2. And then on the right hand side, I'm going to have negative 1 minus 1, which gives me negative 2. So this second one does not give me the solution. So I can say this one is not applicable. So I'll choose to go with x is equal to 1. So therefore, x must be 1. Guys, that's 1.1.4. Move on. Then 1.2. We need to solve for x and y simultaneously. So in this case, we always have a linear equation and then a quadratic one. Okay, so we have 3 to the x plus 27. So 3 to the x plus y is equal to 27, and then x squared plus y squared. So I'm going to say 3x plus y is equal to 27. I'm going to call this equation number 1. And then I'll call this my equation number 2. Okay. So I need to create a linear equation between these two. And the easiest one is going to be this first one. So since it's in the form of an exponential, it means I can even create a 27 as an exponential. So 27 will be the same as 3 cubed. The bases are the same, which means the exponents will also be the same. So I'm going to say x plus y should be 3. Then I can make y the subject and say y is going to be 3 minus x. I can call this my equation 3 or equation star. So I need to substitute equation 3 into equation number 2. Where there is y, I'm going to replace all of that. So with my substitution, it's going to be x squared plus, so we are replacing y with 3 minus x, I square that is equal to 17. So that is going to be x squared plus, when I FOIL that, remember it's 3 minus x times 3 minus x. So that's going to be a 9 minus 6x plus x squared. I can move the 17, that's okay, is equal to 0. Then when I group and collect my like terms, I'm going to have 2x squared. I know that plus 9 minus 17 is negative 8. Okay, so I have minus 6x. Then I say this is negative 8 is equal to 0. Can choose to divide through by 2. Okay, so that I have my x squared minus 3x minus 4 is equal to 0. And then I can use my factors, or I can use the quadratic formula either way. So I'll say this is x and x, numbers that I'm looking at to give me negative 4. When I add them, I get negative 3. It will be negative 4 and a positive 1. Okay. So which means my x is going to be negative 1 or x is going to be positive 4 when I equate these brackets to 0. Remember the dot product. X plus 1 is a 0 or x minus 4 is a 0 for us to get the solutions. So these are my x values. Then I need to substitute or replace those x values into my equation number 3 to get the y. So which means my first y is going to be 3 minus 1, which gives me a 4. And then if I use x as a 4, that's going to be 3 minus 4, which is negative 1. So at this point, y is a 4, or at this point, y is also negative 1. So I've solved that, and that's how I'll get all the 6 marks. Alright, then question 1.3. They're telling us without the use of a calculator, they want us to get the value of this. Yup, this is something else. Okay, we're having 1 over the root of 1 plus root of 2. And then 1 over the root of 2 plus root of 3, and so on and so forth. So my approach to this, it's a bit tricky, but you don't want us to calculator, which means there's a quicker opening. If I try to rationalize this, what am I going to end up with? Let me rationalize just the first one. And we know that when you're rationalizing, we multiply the numerator and denominator. Okay, so I have root 1 plus root 2. So when I'm rationalizing, I'll say root 1 minus root of 2, and then root 1 minus root of 2. I open the top part. I'm going to end up with just the root 1 minus root 2, but I know that root 1 is the same as the 1, okay? Okay, over this is a difference of 2 squares, which means I'm going to have root 1 and root 1, which is a 1, minus root 2 and root 2 is going to give me a 2. So it's a root 1 minus a root 2 over negative 1. When I simplify that, I'm going to have a negative 1 plus a root 2. Okay, so this is my first term. If this is progression, say negative 1 plus root 2. If I try the second one, I'm going to have root 2 plus root 3. And that is root 2 minus root 3 over root 2 minus root 3. I'll open that up. So root 2 minus root 3 over, this is still a difference of 2 squares. So root 1 root 2 is a 2 minus root 10 root 3 is a 3. I'm still getting negative root 2 plus root 3. So there is something I'm seeing. Something that I'm seeing. That if I am to replace this and that according to the progression, I'm always gonna get, let's say my third term is gonna be negative root 3 plus a root 4. And then I'll have negative root 4 plus a root 5, which means my last term, if I'm to do the same, is going to be negative root 99 plus the root of 100. I don't know whether you guys where I'm heading to. So if I'm to replace everything, it's going to be negative 1 plus root 2. But then I'm adding my second term, which is negative root 2 plus root 3, plus the negative root 3 plus root 4, and so on and so forth, up until I get to negative root 99 plus root 100. Okay? What I notice is that this is going to cancel that. The 3's are going to cancel. The 4's are going to cancel. Up to this point of negative 99, everything is just going to cancel. So I'll only be left with negative 1 and then the last expression, which is square root of 100, which I know is a 10. So negative 1 plus 10 gives me 9. So that is how I approached this question. Okay? If you have a better way, a quicker way, please leave it in the comments. Then that is question 1. Let's move on to question number 2. Question number 2, they are telling us given the geometric series. Okay, we have 1 over 15. Sorry, 1 over 5 plus 1 over 15 plus 1 over 45 and so on. The question is this a convergent geometric series? You must justify the answer with the necessary calculation. And so one thing we know is that the condition for a progression or a series to be convergent, there is negative 1 and positive 1. So this is the condition that our common ratio must be between these two values, between negative 1 and positive 1. So let's try to get the common ratio where we know we get T2 divided by T1, or someone can still use T3 divided by T2. There's no problem. So that's going to be 1 over 15. I'm dividing it by 1 over 5. Can just put this in the calculator just to be sure. But I'm getting 1 over 3 as my common ratio. So when I look at 1 over 3, 1 over 3 lies between these intervals. It's bigger than negative 1, but 1 over 3 is smaller than 1. So the answer is going to be yes. It's a convergent geometric series because negative 1 is less 1 over 3 and is less 1. There we go. Then 2.1.2. They want us to get the sum to infinity. We know that sum to infinity is given as a over 1 minus r. Our first term was 1 over 5, if I'm not mistaken. Yes, 1 over 5. Okay, just substitute. So 1 over 5 over 1 minus our common ratio, we got it as 1 over 3. So that's going to be 1 over 5 over 1 minus 1 over 3. That's going to be 2 over 3. You simplify this. You can use your calculator again. I'm going to just switch that up. So that is 3 over 10. Remember from your earlier grades, said when you're dividing fractions, you must use the reciprocal and the multiplicative inverse and switch the sign to multiplication. That's what I did. So it's 3 over 10, or someone can give it as 0.3. Then 2.2, they're telling us we have an arithmetic and a geometric are combined. And this and it's given as x 1 over 3, 2x 1 over 9, 3x and so on. And they want us to write the next two terms. So when you look at the x's, it's like you're adding an x. So 1x plus 1x to x, and then 2x plus x is 3x. So which means we must add x to give us 4x. When you look at the geometric progression for the sequence, it's 1 over 3. That's our first term. Our second term is 1 over 9. Then that is 1 over 27. So the next one must be 1 over 81. Okay. Seems like I'm multiplying by 1 over 3. Alright. Then 2.2.2. You want the general term for the odd terms. So we know that odd numbers are 1, 3, 5, and so on. Yeah, those are the odd numbers, which means we want the general term of the arithmetic. We know that Tn is given as a plus n minus 1 into d. So our first term is x. This is n minus 1. Our common difference is also x. Then when you open that and simplify, it's going to be x plus, that is xn minus x. So this cancels that, which means my Tn is going to be the same as xn or nx, whichever way. Then 2.2.3, calculate P26, the term in the 26th position. The term in the 26th position. Okay, so if I'm to look at P26, now let me just write it out. 2, 3, 4, 5, 10, 11, 12, 13, 14, 15, 18, 19, 20, 21, 22, 23, 24, 25, and then 26. So if the odd numbers are being represented by the arithmetic, which means P26 is going to be represented by the even, okay? Which even is the geometric. So what I need to do is I need to find the general term of the arithmetic, and then I'll find not P26, but it's going to be my 13th term. Someone is wondering how. So this is 23, 24, 25, and then 26. 14, 15, 16, 17, 18. Okay, so what I'm saying is that now with the geometric, which position am I going to focus on? Because I cannot focus on 26 since 26 is the general. So I'll be looking at number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So I'll be looking at T13 of the geometric. Okay. So we know that with the geometric, it's a r minus 1. Our a was 1 over 3. We said our common ratio is also 1 over 3 to the exponent of n minus 1. Now, since I'm looking for T13, it's going to be 1 over 3 times 1 over 3 to the exponent of 13 minus 1. You can just put this into the machine. So the calculator. This is 1 over 3. Oops, okay. Say to the exponent of 13 minus 1. I'm getting a very small number. Okay. That's 1 over 1594 3 to 3. Okay, so you can leave it as a decimal, which is 0, 0. Yes, it's a lot here. So that is how I would have done that. Or alternatively, by looking at the way the progression is moving, someone can quickly sense and know that no, it's just 1/3 to the exponent of, and then you can put the 13 there, you still get to the same answer. Alright, then 2.2.4, they are telling us that we have the sigma. Remember what we said, sigma represents summation from n1 to 21 of the same progression that is having both will be equal to 33.5 from the first one to the 21st, the one the value is. Now, if the total number of terms are 21, I'll just slightly group. Okay. So if we have 21 terms, this is where we're ending. These ones are out. Question is, how many arithmetic? So for 18, now call it arithmetic progression. How many terms do I have? 1, 2, 3, 4, 7, 8, 9, and 10. So I'm going to have 10 for arithmetic, which means the geometric progression or series is going to have 11 terms. Is that even true? Let me just recount, guys. I don't want to make a mess. Okay. So arithmetic, we said, is the first one. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So arithmetic is 11. And then geometric will be 10. And counted the other way around. Alright, so we know that the sum of an arithmetic is given as, I'm not going to look at the generals, like the formula for the sum. I can look at that summarized one that talks about n over 2 into a plus n. I don't know if I find this big because I have my first term and I also have my last term. Okay. Then I'm going to add the geometric one. You know that the geometric one is given as a into 1 minus r to the exponent of a over 1 minus r. So this is the combined. So for my arithmetic, we said we have 11 terms, so that's 11 over 2 into my first term was x. Okay. And then since 21 is going to be my last term for the arithmetic, this is going to be term number what? We say 11. Okay, which is 11x. Then plus, when I look at the first term of the geometric, we have the 3, so 1 over 3 into 1 minus 1 over 3 to the exponent of 10 over 1 minus 1 over 3. But this must be equated to 33.5. Okay, I'll open my brackets, that is 12x. So 11 over 2 times 12x plus, when I simplify this, okay, when I simplify that, I'm getting, I'm not going to assume, let me just use my machine. Say 1 over 3 to the exponent of 10, close that bracket, then 1 minus 1 over 3. I'm getting 0.4999999. So if I round it off, I'll get a half. We got the 3.5. So when I simplify this 2 and that, so by 2 is 1, by 2 is 6. So 11 times 6, I'm going to get 66x plus a half is equal to 33.5. Then I can, let me just use this space here. I can move this half that side, so which means 66x is equal to 33.5 minus a half. You know that a half is 0.5. So 66x is the same as 33. I'll divide by 66 on either sides so that my x becomes, is it a half also? Just confirm, yes. So x becomes a half. So that is question number 2. That's question number 2. Alright, then question number 3. Question number 3. Okay, they're telling us that in a quadratic sequence, these are the following properties. The second difference is a 10. Okay, the first two terms are equal. T1 is the same as T2. And then T1, T2, and T3 will give us 28. Show that the general term is that. So with such questions, guys, just come up with something. Okay. So I'm gonna let my first term and second term be maybe letter. I can't use A. That's fine. Let me use X. It's fine. It will make much more sense. So if my first term is X, my second term is also X, and then maybe this is T3, which I can call, I don't know, call it a C. It's fine. So I'm letting T1 equal to T2 be equal to X. And I'm letting my T3 be X. It's fine. What I know is that this is going to represent the first difference, because x minus x will give us a 0, and then this is going to be like c minus x. Okay. And then they told us that the second difference is a 10. What does this mean? This means that if I get my c minus x minus a 0, I must get a 10. So c is the same as 10 plus 1 plus x. I've made c the subject to the formula. I can call this equation number 1. But we know that T1 plus T2 plus T3. So which means if I have my x plus x plus the T3, which is my c now, it's gonna be 10 plus x must give us 8. I'm trying to get the value of x first, then shall get the general term. So 1, 2, those are 3 x's is equal to, I can move the 10 that side, that's gonna give me 18. Divide both sides by 3, which means x is a 6. Okay. If x is a 6, which means my third term is gonna be 10 plus 6, which gives me 16. Alright. So I'll start. I will start and look at my second difference. So I know that 2a is the same as 10. Divide both sides by 2, which means my a is a 5. Okay, that's fine. And then I know that 3a plus a b must give us 0. But our a is 5, so that's going to be 3 times 5 plus b is 0. Move the 3 and 5 that side, that's a negative 15. Okay, which is that. And then a plus b plus c must give us this x, which x we found as a 6. Okay, so my a is a 5, my b is a negative 15, plus c is equal to 6. Okay, so 5 and 15, that's negative 10, plus c is equal to 6. Move the 10 that side, so it becomes negative 16. Okay, just for the sake of this last part, please remember the c I'm using here is not the same c in this part. This can even be a d, just for the confusion being rectified so that we don't have the same kind of thing. We can use a D. Okay. So which means our Tn is going to be 5n squared. We have the minus 15n. Oops, why did I get a negative 16? Something is amiss here. Guys, if I move the 10 that side, it's a plus. So which means it's a positive 16. A positive 16. Okay, so that is that. With that, let's change 3.1. Then 3.2 is 216 a term of this sequence. So for us to justify this, we need to equate this whole expression 5n squared minus 15n plus 16. We equate it to 216 and find what position it represents. So I'm gonna move the 216 that side. So 5n squared minus 5n, that's going to be negative 200 is equal to 0. Then I can divide through by 5. Divide through by 5, that's going to be n squared minus 3n minus 40 is equal to 0. Then I can use my factors. I can use the quadratic formula. This is n, it's going to be 8, n and 5. So I make this a negative and a positive to give me this expression is equal to 0. So which means either n is 8 or n is negative 5. But remember, we're looking for the position and we can never have a negative position. Therefore, 216 is the 8th term of that sequence. Alright. Because they say, is this a term or not? The answer is yes. Yes, 216 is the 8th term of the sequence. Then question number 4. They're telling us that we've been given this function p into x is equal to 1 over 3 to the exponent of x. Okay. Is this an increasing or decreasing? So we need to know what type of graph, what type of function is this. This is an exponential function or graph. Condition is if this is a b, one thing we know, if it is in the form of y is equal to b to the x. If b is greater than 1, then the function will be increasing. Okay. But if b is in between 0 and 1, then the function is decreasing. So in this case, since 1 over 3 is between 0 and 1, the function is decreasing. Do they want a reason? No. So that is enough. So the function is decreasing. Then 4.1.2, they want us to get the inverse. So it was p of x is equal to 1 over 3 to the exponent of x. So in most cases, whenever we ask for the inverse, this is going to be in the log form. So it can be log, the same base, 1 over 3, put the x there, and make that a y. So y is equal to the log 1 over 3 to the x. Okay, so that is that. Alternatively, what people usually do is 1 over 3 to that, switch that x is the same as 1 over 3 to the exponent of y. Then introduce logs. So log x is equal to the log 1 over 3. This y is the second power. It will come that side. So that log x is equal to y log 1 over 3. Then when you divide both sides by log 1 over 3 and log 1 over 3, that cancels that. And then this will be the same as that. Okay. Then they want us to write down the domain of the inverse. So one thing we need to know is that the domain of the inverse will be the range of the original, since we are switching them around. So originally, our range was y must be greater than 0. Okay, that was the original range for the p of x. So when you are writing domain, since domain represents the x values, the input values, we're going to just say x must be greater than 0. Okay, so that is that. Then 4.1.4, write down the equation of the asymptote. So if I have my p of x, which is 1 over 3 to the x, and then we are subtracting 5, so we are shifting it 5 units down. This extra portion, remember y is equal to b of x plus q. This q represents the asymptote. So I'm just going to say y is equal to negative 5. That is my asymptote. Then we move on. Given the function 4 over x minus 1 plus 2, find the equations of the asymptotes. So this is a hyperbola, just from the nature of this, because we have a number and then the x is at the bottom. So with asymptotes, we have the horizontal, we brush with the horizontal, get the x minus 1, equate it to 0, which means x is a 1. And then for the y, or for the horizontal asymptote, because it's the vertical, y is going to be equal to 2. So x is equal to 1, and y is equal to 2. Then they want us to get the x-intercept. One thing we know is that for x-intercept, y must always be 0, which y is also the same as the f of x. Where there is f of x, we're going to put a 0 there. So 0 is equal to 4 over x minus 1 plus 2. I can move this to that side, so that I have negative 2 and cross multiply same time. Okay, because I'm saying negative 2 is equal to 4 over x minus 1. And then I multiply both sides by this denominator, or cross multiply. Open this up, negative 2x plus 2 is equal to 4. Move the 2 that side, negative 2x is equal to a 2. Is that true? Yes. Divide both sides by negative 2, which means x is going to be negative 1. It's the x-intercept and not the coordinates. Okay, then they want us to sketch 3 marks, so it's 4 marks, guys. You cannot just throw this away. Now there are people who be like, when I see sketching, skip. Guys, these marks are for grabs. Then I can put my x somewhere there. So step number 1 when you are sketching a hyperbola is the asymptotes. Just draw the asymptotes. We said x is 1 and y is 2. So my x1 is going to be somewhere here. So sorry. We just put it somewhere here. The dotted line. Okay. I'll call that my 1. And then the other one is a y2. This is my 2. I'll just draw the asymptote somewhere here. Okay. Then we say that the intercepts. We had just one intercept and we said x is negative 1. Okay, x negative 1 could be somewhere here. And then we can still, because it's 4 over x minus 1 plus 2, we can still find the y-intercept. where x is 0. So 4 into negative 1 plus 2. So 4 over negative 1 plus 2 is going to give me a negative 2. So close to the same distance, it's a negative 2. So the graph must pass there, graph must touch it. But now, since our a is positive, okay, we know that if a or this number on top is positive, the graph is just going to lie within quadrant number 1 and quadrant number 3. If this a was less than 0, then the graph would be quadrant 2 and quadrant number 1. Now, when we talk of quadrants, we're not focusing on the original x and y. We're focusing on the asymptotes, the quadrants formed by the asymptotes. Okay. So my quadrant 1 is going to be here. And then my quadrant 3 is going to be this area here. So since there is nothing the graph to touch on in quadrant number 1, just draw your graph that tends towards the asymptotes. And put the arrows if you wish. And then just gonna move this a bit. Okay. So I can just stretch something that passes through these points and moves towards the asymptotes. And then I can just move this towards this as well. Okay, so that is my f. So in most cases, or in all cases, we need to have two arms of a hyperbola. Hyperbola must have two arms. Alright, then we move on. They want us to use the graph to determine the values of x for which 4 over x minus 1 is greater or equal to 2. So in this case, if I move this to this side, I'll get my original graph. So 4 over x minus 1 plus 2 is greater or equal to 0. So where do I find the function to be above the x-axis? That's what it means. Y is greater than 0. Okay, because f of x is the same as y is the same as this function. Where do I find it above the x-axis? Okay, so from this point to the left, okay, to the left, the graph will be above. But also, when I look at from this point, from positive 1, moving to the positive infinity, from negative 1 to the negative infinity, graph is above, and then from positive 1 to that side. So my representation is going to be x must be less or equal to negative 1. Okay? And also x must be greater than 1. So those are the two conditions under which the graph will be above the y-axis. So less or equal because the graph is passing through negative 1, and then we're using just greater because 1 is an asymptote. Can't pass there. Then 4.2.5, they want us to get the equation of the axis of symmetry of f of this 1 plus 2 is being shifted some units to the right. Okay, so where there is x, I can replace all of that. So 4 over x minus 2 minus 1 plus 2. So that's going to be 4 over x minus 3 plus 2. So this is the new function. Okay, so with this new function, I know that the asymptotes are going to be 3 and 2. Okay, x is going to be 3 and then y is going to be 2. So it's the same function or it's the same graph, but we're just shifting it 2 units to the right, so that this asymptote moves plus 2 to be somewhere there. Now, when you're finding the equation of your axis of symmetry, there are two. We have y is equal to x plus c, and then we have y is equal to negative x plus c. Now, for us to get the value of c, we normally use the intersection of the asymptotes. So since they want one with a negative coordinate, then I'll go with this. So I'll say y is equal to negative x plus c. That is, y can put a 2 is equal to negative 3 plus c. Next to the subject, c becomes a 5. Then my equation becomes negative x plus a 5. That becomes the equation of the axis of symmetry. Alright, question number 5. Question number 5. It's telling us that the graphs of functions f of x, which is negative x plus 3 squared plus 4. Then g of x is x plus 5. Okay. Drawn below, we have A and B. That's where the graphs are intersecting, or that's the point where the graphs are equal. Then they want us to get the coordinates of the turning point. So when you look at the format that is being given, this is a turning point format for f to a parabola. So these 3 and the 4 will represent the coordinates of the turning point. But what we do, we only have to change the sign of the 3 for the x. So we can say that coordinates of the turning points are going to be negative 3 and positive 4. If this is kind of hard for you to notice, you can still open that up using your FOIA. So that it's x squared plus 6x plus a 9, and then plus a 4. When you introduce the negative, it's going to be negative x squared minus 6x minus 9 plus 4. That's x squared negative minus 6x minus 5. And then you apply the axis of symmetry. X is negative b over 2a. Okay, that's negative and negative 6 over 2. Your a is a negative 1. When you simplify this, it will give you the 3. The negative 3. And then if you get that negative 3 and put it into that, you're going to end up with just 4. Alright, so that's how one would go about it. But from the first point, given the fact that it's 2 marks, you just needed to spot that. Then they want us to get a range. Now range represents y values for which f is valid. Y values that cover the graph of the graph of f. So this is our f, and we can see that the highest point it can go is just the 4, and then below. All the values below 4 are valid for the graph, because the graph can extend into the negative infinities. So I'm just gonna say that y is less or equal to 4. Alternatively, someone can say negative y is less or equal to, what am I saying? Negative infinity is less or equal to y less or equal to 4. This is also acceptable. Then 5.3, can we show that the coordinates of a and b are negative 5 and negative 4? Now, since my equation is negative x plus 4 squared, it's a plus 3, sorry, and then plus 4. What is a and what is b? That is what I need to find out. So a is a point of intersection as much as it is an intercept, and then b is an intersection point for the two graphs. So we know that at a and b, the graphs are going to be equal. Okay. We say g of x is x plus 5. So we're saying that at a and b, f of x must be the same as g of x. Point of intersection means the graphs are equal. So I'm going to solve this simultaneously. I'm going to equate everything. Okay, so I'm going to say negative x plus 3 squared plus 4 should be the same as x plus 5. Okay, remember we opened this up somewhere there. We had negative x squared. Someone remind me, minus 6x minus 5. Okay, that is minus 6x plus 5 is equal to x plus 5. Create a standard form. That's going to be negative x squared. This and that is going to be negative 7x plus 0 is equal to 0. And then I can write through by the negative. Just a moment. What's going on here? Was that a plus 5 or a minus 5? Wait a moment. It was minus 5. My bad. Just listening. Okay, so this is a negative 5. Okay, we said minus 5. So this not 0. Mr. 0 disappear. Okay, so when I move the 5 aside, it will be minus 10. Divide through by negative. That's going to be x squared plus 7x plus 10 is 0. The two numbers that I multiply to give me a 10, I add them to get a 5. Sorry, 7 is x plus 5 and then x plus 2. Then this bracket will give me x as a 5 or x as a negative 2. Then you can see, what am I doing here? Negative 5. What's going on? X is negative 5 and x is negative 2. So, which means, since my a is the farthest, it will have the smaller value. So the a of x is negative 5, and then the bx is going to be negative 2. Guys, that's what we do. They want the x coordinates only. Then they're telling us hence, which means from where we stopped, they want us to get the values of c, for which the equation of negative x plus c plus 3 squared plus a 4 is x plus c plus 5. This x plus c is like we are shifting the graph some units within the horizontal axis so that the graph can have one negative and then one positive root. So from the position of the graphs or the for this to have one negative root and one positive root, it's like this graph must be shifted some units. So if this is a negative 2, that's our negative is like must be shifted these units. These are 2 units, just slightly 2 units to the right. Okay. So it makes sense. So reflection is not gonna make sense. So I'm gonna take c to be slightly greater than 2. And if I plus that, which means 2 is going to give me negative 3. Okay, that's going to be 5. Which can't happen. That's a 1, which means it can move just 4 units. Oh, nice. Okay, I'm just gonna just say c must be greater than, must be between 2 and 4. Just say 2 is less c and less 4, because I can only shift it 4 units. And then it will make sense for it to have one positive and one negative. Then 1.5, they're telling us the maximum distance between f and g. This interval is k. And then if h of x is the same as h of x plus, determine the equation of h. So we need to find what k is, that maximum distance between the intervals of x, a, and x. So for us to get the maximum distance, we need to determine the difference between the two graphs. Okay. And from the look of things, I see the f being on top. So I'm just gonna say f minus g of x. So remember that was x squared minus 6x minus 5, and then I'm subtracting x plus 5. So that's negative x squared minus 7x, you said minus 10. Okay, which you already had. Then we need to find the maximum. So for maximum distance, I can find the first derivative, or I can even use the axis of symmetry. Okay. So for maximum, I don't know, whichever one is simpler. Okay, so if I use the first derivative, it's going to be negative 2x minus 7, and then I'll equate it to 0, and then I'll solve for x. So my x is going to be 7 over negative 2. If I use the axis of symmetry of negative b over 2a, so my b is negative 7 over 2 times my h is negative 1, which is still negative 7 over 2. So either way. So if this is the point where I'm having my maximum distance, I'll substitute this into the original to get what my k is. Okay. So then that's going to be negative, we have negative 7 over 2 squared minus 7 into negative 7 over 2 minus 10. Okay, let me just confirm. That is that minus 7 into P.1 minus 10. I'm having 2.25 in the positive. Then, which means my h of x is going to be the g of x, which is x plus 5, and then plus this 2.25 is representing the k, 2.25. So that is going to be 7.25. That is the h of x. Alright, so that's how I would have gone about it. It's either first derivative here or axis of symmetry to get the maximum point. Alright, then that's 5. I go to question number 6. Number 6 is telling me that a company bought a photocopier for 115,000 rands on the 1st of July 2022. They will use the old photocopier as a trading when they replace with a similar on the 30th of June 2027. Then the average rate of inflation is 6.5 for the next 5 years, turning the price of a similar photocopier in that time. So whenever I talk about inflation, that is compound interest. So A is P into 1 plus I to the exponent of n. Then we do the substitution. That is 150,000 into 1 plus. That's going to be 6.5, or someone can just divide that by 100 straight away. They have 0.065. to the exponent of 5. Okay, just punch this into your machine. Your machine 150 tau into 1 plus 0.065. Oops, to the exponent of 5. And I'm having 20.5512,999, which I'm going to round up to just 1/3. Okay, so that is how much the machine will cost in 5 years' time. 205,530 rands. Then calculate the trading value for the old photocopier. After 5 years, it depreciates at 9% straight line. So the keyword is straight line. So this time around, they are not using reducing balance. So with a straight line, it's just going to be 1 minus 1. 1 minus I. That is straight line method, depreciation. So our P, we're looking for A. Our P is the 150. We know that our N is going to be 5 and the I is 9%. So substitute that 150 tau into 1 minus 90.09 multiplied by 5. Put this in your machine. My machine into 1 minus 0.09 times 5. I'm getting 82,500. 82,500. Okay, so that is what the machine gonna be worth after 5 years. Then 6.3. The company sets up a sinking fund to cover the replacement costs of the initial copy. The fund earns interest at this much and then monthly. Okay, the company made the first deposit on the 31st of July. Just something that I need to know. They bought the machine on the 1st of July. Okay. And then on the 31st of July, they made payment. Okay. And then we'll continue to do so until 31 May. Alright. Which is 1 month prior to the new copier being bought. How much should be deposited at the end of each month so that the company will be able to buy the new photocopy? So a sinking fund is basically a fund that is set aside, or it's more like an investment that is put aside to cater for replacements, especially for machines and vehicles and stuff like that. So what normally happens, like if the current machine or the current truck that is being used is sold off in a certain period of time, whatever they get out of that truck may not be enough to buy anymore. So whatever will be saved over the period is what we call the sinking fund. And that money will be under the present. Is a present? No, it will be a future value. Okay. So what I need to know is what is my future value? How much am I looking at? So since we had 205513, okay, then we subtract. This is going to be the cost of the new machine, and then subtract what the old one is worth, which is 82,500. Okay, 205513 minus 82,500. This giving me 123,013. So this is how much must be put aside or must be saved so that they can be able to buy the new machine. Then the question is asking for the monthly installment. Is it true? Yes. How much should be deposited at the end of each month? So I don't have X. Maybe before I even talk about X, which formula I'm using, saying F is equal to X into 1 plus I to the exponent of n minus 1 over I. Okay, so we're looking for X. We have our F, which is this much. And then the interest rate, they told us it is 7, something. I say 7,85 compounded monthly. I'll divide that by 12, it's fine. And then my n. Okay. So since the first deposit was made on the 31st of July 2022, okay, 2023, 2024, 2025, it's going to be 2026 and 2027. Okay, so 1st July. So 1st July here also. 1st July. 1st July. This is 1st July. Okay, and also 1st July. Okay, so this is going to be 1, 2, 3, and then 4. It's meant to be 5 years. Okay, but the payment is not getting to the 1st of July. It's stopping in May, 31st May. Which means since these people paid an early payoff, and there are 2 months that are left before the final payment, which means I'm going to take off one payment to cater for the early payment, then I'm going to be left with less than 60 months, because we know 5 times 12 is meant to be 60 months. Then I subtract my 1, which is going to give me 59 months. Okay, so my n, I'm taking it as a 59. So since I'm looking for X, I'm going to make X the subject first. So I'll cross multiply. So I'll have my future value times I is equal to X into this whole thing. And then I'll divide both sides by that bracket. So the future value times the interest rate over 1 plus I to the exponent of n minus 1. Then I'll do my substitution. That's 1, 2, 3, 0, 1, 3 times my interest rate, say 7,8%, 7,89. That's going to be 0.0789. Is it 89 or 85? Man, what's the problem? It's 85. Let me confirm, please. Okay, it's 85 times. Okay. We're dividing this by 12 since we're compounding it monthly. That is fine. Over. We have 1 plus 0,0785 over 12. We can alternatively use that button of the percentage in the calculator so that you don't have to divide by 100. Okay, so when I punch this into my machine, 013 times what are you getting? So this is 1 plus 0.0785 over 12. I'll close this bracket to the exponent of 59, and then I'll subtract my 1. Oops, I'm getting 1,715 rands, 16 cents. So this is how much they're gonna be paying every month for 59 months, so that they can cover the new machine. Okay, 6.2. 6.2. They're telling us that today Andrew borrowed 200,000 from a bank. The bank charges interest that pays per annum compounded 4 times. Andrew is gonna make payments of 6,000. So X is 6,000. Interest rate, we say 5.25% over 4. 6,000 at the end of every 3 months. So when they talk of every 3 months, that's a quarter. So first payment will be made in 3 months from now, which is the correct timing. How long in years will Andrew take to settle the loan? So they want the end. Now, since this is a loan, so it's going to be representing our present value, which is 200,000 rands. So from the present value formula, which is h into 1 minus 1 plus I to the negative n, divide this by I. Okay. So I'm just going to say 200,000 is equal to the payment, which is 6,000 into 1 minus 1 plus the I. I'll go the old school way, 5.25. I'm dividing it by 100, which is 0.0525. I'm dividing it by 4 since the compounding is quarterly. Then my exponent here, I'm going to say 4n. 4 is for the quarter, and n will represent the number of years. But that must be negative. Dividing this by the same interest rate, 0.0525, divide by 4. Okay, so step number 1, I'm going to simplify this and that. If I can divide them, or I can multiply this and that, and then divide by 6,000. Whichever way. Divide this and then multiply, or simplify this and divide it outside. When I do that, I'm going to say 200,000, I'm dividing it by 6,000. Okay, and then I'm multiplying it by 0.0525 over 4. So I'm getting 7 over 16 is equal to, I'm saying 1 minus, when I simplify what is inside here, I'm going to have 1 plus 0.0525 over 4 is giving me something like 1621 over 1.6 to the exponent of negative 4n. Okay. Then I can move the one that side. So 7 over 16, I'm subtracting the 1. So I need to move this one that side. That's going to give me negative 9 over 16. And we got to the negative 1621 over 1.6 to the exponent of negative 4n. And then since either sides are having the negative, they will cancel out to be a positive. Then I can introduce my logs here. So I'll say negative 4n must be the log. Since this is a base, it must also be maintained as a base here. Okay, and then this is going to be 9 over 16. as an exponent. Okay, so when I simplify this, do I have space? Do I have space? I need to create space. Okay. So I'm just gonna get it a bit down. I'll take it out. So negative 4n is equal to, that is our log. The bottom have 1621 over 1.6. That's gonna be 9 over, guys, this is a 16, not a 10. Okay, 9 over 16. I'm getting negative 44, comma 124. Yeah. Then I can divide both sides by negative 4. And then my n becomes 11,03. So this guy is gonna take approximately 11 years. Okay, just clear off that one. Okay, that would be my approach to that question. Then 7.1, calculus. Determine the first derivative from first principles. So whenever they talk of first principles, then we know that the limit as h tends to 0 of f of x plus h minus f of x over h. So this is the formula we normally use. So what I know is that this is my f of x. I need to find what is my f of x plus h. So where there is x, I'm going to replace with x plus h. So negative 2 into x plus h squared minus 1. I can open this, so I can just put it so it is okay. Limit as h tends to 0. I'm going to say negative 2 into x plus h squared minus 1. Then minus the whole of f, which is negative 2x squared minus 1 over h. Then we're seeing the limit as h tends to 0. I'll open this up. I have negative 2 FOIL that, x squared plus 2xh plus h squared minus 1. Open that, so it will be 2x squared plus 1. Everything is over h. Now move to the side, so still the limit as h tends to 0. I'll open this bracket of mine, negative 2x squared minus 4xh minus 2h squared. Then I'm adding a minus 1 plus 2x squared plus 1. Everything is over h. Remember, whenever you do first principles, certain things must cancel. So this is going to cancel with that. They are the same, but the signs are opposite. This is going to cancel that. Then I'm left with negative 4xh minus 2x squared. I can factorize out the h. Okay, so that I have negative 4x minus 2h over h. So this cancels that. And then if I replace my h with a 0, then I'm going to be left with just negative 4x. So that's how we get the 5 marks from first principles. Remember the x plus h. This is important. And how you open it up without that negative 2. Then 7.2.1, they want us to find the first derivative if it's given like this. So use your rules. Remember, if we have a to the n, we'll say the n must multiply with the coefficient and then we subtract by 1. That's the rule that we're using for us to find y, maybe the n. Okay, so that's going to be negative 2 times 3. That's going to be negative 6x. Then we subtract 1, that is squared. Then 3 times 2 is going to be 6x. 2 minus 1, just that. Then that is our answer for that. Then 7.2.2. So whenever we have square roots, try to eliminate those roots and rather you write it in the form of exponents. So this would be the same as 2x plus 1 over, I know that the square root of 4 is 2. And in this x, I'm going to write it as exponent half. Okay, it would be the same as 1 over 2 root x. Then I can move this to the top, which is going to be 2x plus 1 over 2x to the exponent of half. And then I need to find my divide x from this. Okay, divide x there. It's going to be, that's a 2, because 1 times 2 is 2, then subtract 10. This is a negative, remember, since the exponent is gone up. A negative half times a half is going to give me negative 1 over 4. X subtract 1 from there, I'm going to have negative 3 over 2. So my answer, I can express it as 2 minus x 3 over 2 negative over 4. That will be my answer. For as long as the question does not tell you to leave your answer with a positive exponent, just leave it like this and move, please. Alright, then 7.3. They're telling us that the graph y is equal to first derivative has a minimum turning point at this. Determine the values of x for which this is concave. So concavity in most cases depends on the turning points. Okay, the point where we find the inflection is usually the average turning points. So since our x is a 1 and we're talking about concave down, remember whenever we find concave down or concavity downwards, we want to find the first derivative being less than 0. And in this case, since it is a graph in that sort of manner, the graph will only be concave down between x being 1 on the left hand side. So here I'm just going to say x must be less than 1. And then those are the values x for which it's going to be concave down. Then 8.3, sorry, 8.1. If you're given this function, it's a cubic function, write down the y-intercept. So y-intercept is usually the number without a variable. Okay, you can say it's negative 10. Alternatively, we know that the y-intercept, x is a 0. You can substitute with a 0. You're still going to get negative 10. Then show that 2 is a root of the equation. So for a number to be a root, if we substitute that number into the function, we must end up with a 0. And if that is true, then that number is a root. So let's do it here. So that is 2 cubed plus 4 times 2 squared minus 7 times 2 minus 10. So that's going to be 8 plus 16 minus 14 minus 10. That's a 24 minus a 24, which is a 0. Therefore, f of 2 is giving us a 0. Hence, 2 is a root. 2 is a root. Okay. And then hence factorize. Okay. So if 2 is one of the roots, for us to find the other roots, you can use your vector formula. If that is our vector, then use your long division. Alternatively, we can use what we call the synthetic approach. Let me see, this is A, B, C, and D. I prefer the synthetic because chances of me going wrong are very, very slim. Okay, let me just take this out. Okay, I'm saying A, B, C, and D. So A, B, and D represent the coefficients of my function. Okay. So with my A, they told me it's a 1. My B is a 4. My C is -7. And my D is a 10. Okay. Now since the first root is a 2, I'll put a 2 there. And then I'll just shade this off. In this one, I'll just write it down. Then what is 1 times 2? It's a 2. I plus this. I get a 6. Okay. And then 6 times 2, I'm getting 12. When I plus this, I get a 5. And 5 times 2, did I do something wrong? What is the D, guys? Say -10, not positive. What's the problem? Okay, this and that is 10. Then I plus that, I must always get a 0 at the end. So which means I can draw my diagonal lines to say that B is A, this is the C, and then that is the D. So which means it's gonna be x squared. Remember, these are coefficients. Plus 6x plus a 5. I can equate this to 0, or I don't even need to equate it to 0. I need to factorize that. The two brackets, choose x and x. Which numbers do I multiply to give me 5? I add to get 6. It has to be 5 and 1. And then I plus that. Okay. So which means for me to factorize f completely, this first root can give me this vector of x minus 2. Okay. Because x equals 2, move this that side, get x minus 2. And then I can combine it with this, that is x plus 5. So I'll factorize that completely. Then if it's further given that the coordinates of the turning points are approximately this much, they want us to draw a sketch. Now with the sketch, we have the x-intercepts. Remember, roots are more like the x-intercepts. Then we have the y-intercept, which was the -10. Look at your A. Our A is greater than 0, which means this graph must round and then smile, something like that. If it's less than 0, then it will be the other way around. So I'm not gonna waste a lot of time. If that is my x, and probably that is my y. Okay, then I'm gonna color. Let me use that. No, that is too faint for my liking. Use green. So let's mark off the intercepts. This is a 2, -1, -5. So if this is my 2, this can be my -1, probably -5. Turning point, we said 0, 7 and negative. Okay, negative something. No, 0, 7 and just a -12. Somewhere there. Okay. And then this is -3,4. Okay, somewhere halfway. And then top there, if I call that my point. I hope it comes out okay. Then my intercept is -10. If I put it somewhere there, then I can connect. So I know that that is my maximum, and then this is my turning point. And then I can just use dotted lines first, so that I see what kind of shape I have. If I'm happy with it, then I'll go on and draw the outline. Okay. And just make this bold. Okay. So I'm gonna have something like that. Okay, so we're only going to mark the intercepts and then the shape in most cases. Okay, so that becomes the graph. What I don't know. This one must come back. So -1 and 2 and so guys, that is just a sketch of how the graph will look like. And then they want us to use the graph to determine the values of x for which the first derivative is less than 0. So first derivative is normally the gradient function. Okay. So where do we find the gradient to be less than 0? In other words, the gradient must be decreasing. Okay. So if this is 0,7, this is -3,4. So between this area, that's where we see the graph to be decreasing, because before that the graph is in increasing format, and then after the 0,7 the graph is increasing. So we're gonna say -3,4 is less x and then is less 0,7. So between those intervals, the graph will be seen to be decreasing. Then the next question, that is 8.5.2. They're telling us the gradient, the x values with the gradient of the tangent will be minimum. So for any tangent to have a minimum gradient, it must occur at the point of inflection. Okay. And how do we get the point of inflection? Say it f double prime. So since we had x squared was it plus 4x minus 7x minus 10. Just confirm that. Okay, that is true. So my first derivative, let me find the first derivative first. That's gonna be 2x plus 4 minus 7. And then my second derivative is going to be this. I'm sorry guys, I'll take this back. The function is x cubed. This is x squared. So first derivative is going to be 3x squared plus 8x minus 7. So second derivative is going to be 6x plus 8. When I equate this to 0 and move the 8 outside, x must be -8 over 6, which is -4 over 3. So at this point where x is -4 over 3, that's where the tangent will have minimum gradient. Then 8.5.3, the first derivative and second derivative being less or equal to 0. Okay, so we know that the first derivative is going to be a parabola. If I call that my x, then I draw my parabola nicely. Okay, this is going to represent the first derivative. And these points will represent the turning points, which is -3,4, and then that's going to be the 0,7. We know the second derivative is going to be a straight line. Let me just draw something like that. That is my y. Straight line, we said x is -3 over 4 and y is 0. And then that is 8. So that is 8. Lines to be drawn to be moving somewhere. So 4 over 3 negative. So what this means is that for two functions multiplied to be less or equal to 0, it's like one of them must be positive and the other has to be negative, or negative and positive. So we need to look at those conditions before we can come up with the solutions. Okay, so when I look at this point, let me cut this out. Remember, we're looking for values of x. So at this point of 3/4, this graph is positive, and then this graph is negative. Okay, so from 3,4 to the left. So you can say x is less or equal to negative 3,4. That is one. And then when I look at this point, I can see that this graph is in the positive, but then this f first derivative is on the negative. But this only occurs up to this point of 0,7, okay, where this one is on top and this one is below. So I'm gonna say negative 4/3 must be less or equal to x, and then less or equal to 0,7. So those are the intervals that they were looking for. Then question number 9. A wire which is 12 meters long is cut into 2 pieces. Okay. One part is bent to form an equilateral triangle, and the other is bent to form a square. A side of the triangle has length of 2x. Okay, so which means that is equilateral. One thing about equilateral triangle is that all sides are equal. So that is 2x, 2x, and 2x. Which means the total perimeter of the triangle is 6x. Total sides, the triangle is 6x. Then write down the length of the side of the square. And the other thing we know about the square is that all the sides are also equal, but they are 4. So if this is 6x, what is left of the wire? It's going to be 12 meters minus the 6x. So this is the total perimeter of the square. Then for us to get one side of the square, we just get 12 minus 6x, and then I'll divide this by 4. Okay, when I split that, it's like 12 divided by 4 is going to be 3, minus 6 divided by 4 is going to be 3/2x. I don't know, I can call this meters. It's fine. So that is the length of one side, 3 minus 3/2. So 12 minus 6x over 4. When you simplify, someone can even factorize that. Maximum is a 3, is it not? It's a 2. Is that so? It's a 3. Yeah, it's 3. And then you have 4 minus 2x, and then by 4. Okay, so that is that. Let's not debate over the factorization. Then we move on. Then they're telling us that if this square is now used, now we use focusing on the square whose side is 3 minus 3/2. Okay. So if we choose to use the square as the base of the times the prism and the height is for determining the maximum volume. So one thing we know about volume is that we must get the area of the base, and then we multiply that area by the height. So since the area, or since the base is a square, which means the area is going to be 3 minus 3/2x multiplied by 3 minus 3/2x, then I'll multiply by my OX. Okay, I'll open this up using the foil. That's going to be 9 minus 9/2x, then minus 9/2x. That is going to be 9/4x squared. I'm multiplying this by 4x. When I collect my like terms in the middle there, it's gonna be 9 minus 9x plus 9 over 4x squared being multiplied by 4x. Then I can open up with the 4x. That's gonna be 36x minus 36x squared plus 9x cubed. So that's the volume, which I can rewrite as this plus 36x. Okay, this is the volume formula. Then the question is asking for the maximum volume. So for maximum volume, okay, we need to derive. We must find dv dx and equal to 0. Okay, so my first derivative is going to be 27x squared minus 72x plus 36 is equal to 0. Okay, then from there I can divide through by 9. Yeah, so that's gonna be 3x squared minus 8x plus 4 is equal to 0. Then I can use my quadratic formula. I can open up using the brackets. And to get 4, I can use 2 and 2. Let's see, that is 6 plus 2 is 8. I'll make this a minus so that my product is positive. So which means from this 3x minus 2 is equal to 0, or x minus 2 is equal to 0. So x here is going to be 2 over 3. Then x here is going to be 2. So for me to get the maximum volume, it's either x has to be 2 or x has to be 2 over 3. The question wants the volume. We determine the maximum volume. Okay. So I can get these numbers and just substitute them into the volume formula. So if I use v of 2, that's 9 times 2 cubed minus 36 times 2 squared plus 36 times 2. Okay, I'm getting a 0. And then if I use 2 over 3, okay, that's gonna be 9 into 2 over 3 cubed minus 36 into 4 over 3 squared plus 36 into 2 over 3. And substitute that. Okay, so that's 2 over 3 cubed minus 36 times 2 over 3. That is squared plus 36 into 2 over 3. I'm getting 32 over 3, which is the same as 10,67 meters cubed. So this will be the maximum volume, because 0 can be maximum when is 10. Okay, so that is question number 9. Then lastly, question number 10. They're telling us that a group of people participated in a trial to test a headache pill. 50% of the participants received the headache pill, and then 50% of the participants received the sugar pill. Okay? 2 over 5 of the group receiving the headache were not cured, and then 3 of the 10 receiving the sugar were cured. They want us to draw a tree diagram. Okay, so with the tree diagram, I'm going to start with either people getting the headache or the sugar pill. Okay, so I'm going to use the headache or the sugar. It's 50%, which is the same as a half. just write it. I can leave it as a half of 50% even a decimal 0.5. Okay, if you receive the headache pill, it's either you're cured or you're not cured. And then if you receive the sugar, it's either you're cured or you're not cured. So 2 over 5 of the group receiving the headache is not cured. So that's 2 over 5. So what will be left here must be 3 over 5, because for every branch you must add up to a 1. Just like a half and a half gave us a 1. So even this. Then 3 over 10 of the people that received the sugar were cured. So this is 3 over 10. Then this must be 7 over 10. So the outcomes will be headache pill and cured, headache pill not cured, sugar and cured, sugar and not cured. So these are our outcomes. Alright, we move on. .1.2, they're telling us that the probability that a person chosen at random from the group will not be cured. So there are 2 possibilities. It's either you'll not be cured because you received the headache pill, or you'll not be cured because you received the sugar pill. So I'm just gonna say HN plus the probability, and then probability of this n. Okay. So for HN, I'll say a half times minus cured is 2 over 5. And then plus sugar not cured is a half times 7 over 10. Okay, and I simplify that. That's gonna be like 1 over 5 plus 7 over 20. Just put this in your machine. 1 over 5 plus 7 over 20. That's 11 over 20. Or 0.55. Then 10.2. They are telling us that we have 3 events. Okay? We have A, B, and C. Probability of A is 2 over 5, probability of B is 1 over 4, probability of A or B is 13 over 20. Are the events A and B mutually exclusive? So, mutually exclusive events are basically events that cannot happen at the same time. In other words, they do not influence each other. In other words, there is no common ground between the events. And from the probability theorem, and using the addition rule, we know that the probability of A and B must be 0, since the events cannot happen. So from that formula of A or B, the sum of probabilities, saying probability of A plus probability of B minus the probability of A and B. So for us to assume, or for us to come to a conclusion that they are either mutually or not mutually, we need to solve for probability of B. So probability of A or B told us that is 3 over 20. Probability of A is 2 over 5 plus probability of B is 1 over 4 minus A and B. Okay. So when I simplify 2 over 5 plus 1 over 4, that's giving me 13 over 20. So 13 over 20 is equal to 13 over 20 minus probability of A and B. So if I transpose this, move it that side, and this move it that side, which means the probability of A and B is going to be a 0. Okay? And we said for as long as it is a 0, then they are mutually exclusive. So the answer is yes, A and B are mutually exclusive. Mutually exclusive. The reason, say probability of A and B is 0. Okay. Then 10.2.2, they want us to determine the probability of C only if it's further given. The probability of A or C is that, and all of that. So if I assume to be having a Venn diagram, okay, this is, let me call this A. Remember, B and A are not meeting, so I'll just leave it there. And then I'm having C that is meeting all of them, since we have A and C, and then we also have B and C. Okay, so remember, they told us that the probability of A was 2/5. So all of this is 2/5. Then the probability of B is 1/4. And then you just need to see. So if our sample space is a 1, okay, sample space is a 1, then you just fill in this. Okay, A and C must be 2/5. So if this is 2/5, okay, but probability of A and C is twice the probability of B and C. What does this mean? If I have B and C to be X, A and C must be twice. Okay. Then I can just apply my logic and represent that. So remember, A and C is 2/5. Must be twice the B and C, which is my X. So which means that this, I divide both sides by 2, which means my X is 1/5. Okay? So there's a 1/5 there, and then this will remain as 2/5, which is fine. Is there anything else we need? They want to see only this part. Okay, so for me to get my C only, I'll need to first of all get to what C is. And since I have the probability of A or C, it's going to help me. I have the probability of A, I have the probability of that. Okay. So it will be probability of A plus the probability of C minus the probability of A and C. So A, we had it as 2/5. A or C is 7/10. C, I don't know. I'm subtracting the intersection, which is 2. A and C is also 2/5. Okay, which means probability of C is just 7/10, because this is going to cancel that. Then if C is 7/10, the question is asking for the probability of C only. So C only is going to be my 7/10. Okay, I must subtract this area and subtract that area. Minus 2/5 and then minus 1/5. Then you just see 2/5 minus 1/5. Okay, so which means it's 1/10. Okay, C only, because C only is just this area without the B and then without the A as well. Alright, so that is done. Then determine the probability that events A, B, and C do not take place. So what is within that? So this is 7 over 10 for that. So we want the probability that is outside. Okay. So since I have the whole of P, so the 1 over 4. And we know that this 2 over 5 is the same as this 2 over 5, so that is a 0. I'm gonna get 1, which is my total probability. I'm gonna subtract the whole of 1 over 4. Okay. I'm also going to subtract the 2 over 5 for this part. And then I'll also subtract 1 over 10 for the C only. Okay. So I have 1 minus, we say 1 over 4. And then subtracting 2 over 5. And then subtracting 1 over 10. Something is not adding up. Something is not adding up. What did I do wrong? Okay. What did I do wrong? I was getting something out of range. I need to revisit this. Okay. A, B, or C do not take place. Okay, this is 1 over 5. So I'm taking the whole of 1 over 4 out, so I don't need to find that. Am I double counting? Okay, then what if I take 1 minus 7 over 10? No, it's my mistake. It's my mistake. Sorry. I must have added. Should have added. Okay, 1 minus, we said 2 over 5 plus the 1 over 10 plus the 1 over 4. This is 2 over 5 plus 1 over 10 and then plus 1 over 4. I'm getting a quarter. Yes, makes sense. Okay, so that is that, guys. I'm sorry, it was meant to be addition and subtraction because there are brackets already. So there's no need of me subtracting inside the brackets. Then 10.3, we have 7 friends, 4 boys and 3 girls that want to stand in a straight line next to each other for a selfie or a photo. In how many ways can the 3 girls stand next to each other? So if I have 7 spots, 2, 3, 4, 5, 6, and 7. If I'm talking of 3 girls standing next to each other, so it's like the 3 must move as a block. So how many options do we have? So we shall have this one being the first option, the second, the third, the fourth, and the fifth. So we have 5 options of moving this block. So if the first one is here, the first one can also be there, the first one can be there, the first one. So it's 5 different options. Times within the girls, you can always switch positions as well. Okay. So 3 factorial times 5 factorial 3 factorial times 5 factorial, I'm getting 720 ways. Okay, and then 10.3.2, they're telling us that in the next photo, you want us to determine the probability that this boy and this girl will not stand next to each other. So before we determine this, we need to first of all find out how many possible ways are there, regardless of the conditions of who wants to stand next to each other and who doesn't stand each other. So if we have 7 factorial, this will be the total number of ways. The total ways is going to be 7 factorial. Okay. Then for us to find the number of ways of these people standing to each other or standing next to each other, we need to look at what are the chances of them being together. And then we can subtract from the total number of ways. So if I were to take both of them to be together, which means I'm having a block of 2, how many ways can they move? 1, 2, 3, 4, 5, and 6 ways. Okay, so that's going to be 6 factorial. And the 2 could switch positions. The 6 factorial times 2 factorial. That is the number of ways for them to be together. Okay, so for them not to stand next to each other, it's going to be 7 factorial minus 6 factorial times 2 factorial. Okay. When I subtract that, let me say 7 factorial minus 6 factorial times 2 factorial. That's giving me 3.6 ways of them not standing next to each other. But the question is asking for the probability. So probability of not stand next to each other is going to be the number of ways, which is 3.6 divided by the 7 factorial. Okay, so if I divide this by my 7 factorial, I'll get 5 over 7, which is the same as 0.71 as well. Okay, so that is the probability that this boy and the girl will not stand next to each other. Alright guys, that is the end of the paper. Please, if there are any errors, any mistakes, please you can just correct us under the comments section. Okay, we're humans, but I tried my best, guys. So just go over that. Yeah, thank you very much. Let's meet in the next paper.
Way of doing this would have been moving the 4 to the right. That I have 2x plus 1 is equal to 4. Then I find square roots. Okay, so the square root will kill this the 2. Then I have plus minus the 2. I remove the 1 to the right, so 2x is equal to plus minus 2 minus 1, then divide through by 2. Okay, so my x, the first one, will be a plus 2 minus 1. That's going to be 1 over 2. Or if I use the negative side, negative 2 minus 1, that's negative 3 over 2. So those are the 2 solutions that we need for question number 1.1.1. Then 1.1.2, we need to create a standard equation. So I'll have 4x squared plus 12x minus 11 is equal to 0. Now, whenever they ask us to give our answers to decimal places, we definitely have to use the quadratic formula. Yeah. Now, when you look at the quadratic formula, we're going to be having 4x squared minus 11. Okay, we say plus 12x is equal to 0. So that's 4x squared plus 12x minus 11 is equal to 0. So our A is a 4, our B is a 12, and then our C is negative 11. When we substitute, we know that x is equal to negative b plus minus square root of b squared minus 4ac divided by 2a. So our b is at negative 12. So our b is at 12. So we substitute with negative 12. And this is 12 squared minus 4. The a is a 4. This is negative 11 over 2 times 4. You have the right to simplify whatever is under the root sign and then get the answer. So my first x value is going to be negative 3.74, or x can be 0.74. So those are the two values that we expected. All right. Then when we move on, 1.1.3 is the inequality question. So create the standard. So it's going to be negative 9x squared plus 15x minus a 4 is less than 0. I'm moving the 9x to the left. Then I can divide through by negative just to make sure that this is a positive. So I'm going to have 9x squared minus 15x plus a 4. The inequality symbol must change now to greater. Okay, then from there, I can just open my brackets. Okay, I'll have 3x. This is 3x. Since this is a negative, sorry, it's a positive, I'll have 4 and 1. If I use negatives, I have a positive 4. This is a negative 3 and a negative 12 being 15. So that's fine. So my critical values are going to be 4 over 3, or basically a third. Now, since my inequality has switched to greater, so even my representation of the values or the solutions is going to change. So my solutions are going to be x has to be less than 1 over 3, or x is greater than 4 over 3. So that's how I represent it. For people that want to draw the, what do you call it? The parabolas, you can quickly do that. And you have something like that. And then you have the 1 over 3, and then the 4 over 3 last side. Okay, so 1.1.4. 1.1.4. So 1.1.4, I'm seeing the square roots. But we have two expressions or two terms that have the root signs, which is kind of a bit tricky. But it's fine. Let me write this side. I think I'm going to need quite a lot of space. So the question says the square root of 2x minus 2 minus the square root of 7 minus 2x is equal to 1. Okay. So what I can start with, I can square both sides since the root signs have already been isolated. Okay. It's more like having any square brackets, a minus b squared. I can apply the FOIL. So I'll say this squared, and then that squared. So this multiplied by that, the root sign is going to fall out. Then, remember when I'm opening this, I'll have a 2ab summary. So I'll have a minus 2, and then these two multiplied together. Okay, so when I multiply these two together, since they both have the root signs, it's as good as me having 2x minus 2, and then 7 minus 2x. And then lastly, for the last part squared, I'll have plus 7 minus 2x is equal to a 1. Okay. And then from there, what do I need to do? I need to open up my brackets. This has to be under the root side. Because I'm multiplying both of them. Okay, so when I open this, I'm going to have 2x. Now let me just cancel this and I cancel that. This 7 and this 2, I'll have a 5. Minus 2, the root of, let me open this up, 2x and 7. I'm going to have 14x. This and that, I'll have minus 4x squared. That and that is minus 14. This and this is plus 4x is equal to 1. Okay. And then what do I need? Let me move the 5 to that side so that I have negative 2 with the root and simplify what is there. So this and that is going to give me 18x minus 4x squared minus 14 is equal to negative 4. I can square both sides so that I get rid of the root again. Okay. So the root goes, but these two have takes the negative 2. I'll end up with just a 4 into negative 4x squared plus 18x minus 14 is equal to 16. Divide both sides by 4. So over 4, then over 4. I have negative 4x squared plus 18x minus 14. We can move this one actually that side. The result we get, so which is a minus 1 is equal to 0. Negative x squared plus 18x minus 18 is equal to 0. Okay, can divide through by negative 2. I have 2x squared minus 9x. I divide through by negative 2. I'll get a positive 9 is equal to 0. Okay, then from here, I can do the factors. Okay, so if that is a 2x, this is going to be x. And I can use the raise and minus sign since my product here is a positive. So either my x is going to be a 3 over 2, or my x is going to be a 3. Okay, so that's what I'm getting. But then remember, with such questions, you always need to test the left-hand side and then the right-hand side. So let's say I have my 2x minus 2. I'm subtracting the square root of 7 minus 2x is equal to 1. So I'm going to test with each of these numbers on the left and on the right and see whether I get the same thing as that which is on the right. Okay, so if I use 3 over 2, if I put a 3 over 2 here, I'm just going to have 3 minus 2, which will give me 1. Then minus, if I put a 3 over 2 here, that's going to be 7 minus 3, which is a 4. Square root of 4 is going to be a 2. The 1 minus 2 gives me negative 1, which is not a 1. So I can take this solution out. It's not applicable. Let me try with the 3. That's going to be 2 times 3, which is a 6. 6 minus that is a 2. Now 6 minus 2 is a 4. Square root of 4 is a 2. And then when I move to this bracket, 7 minus 3, 2 times 3 over 2, that is 7 minus 4, which is a, what is going on? Let's see. We know that 7 minus
Something is not right. X7 minus 2x. So if this is a 3, it's saying 2 times 3 over 2. That's a negative 3, which is a positive 4. And then 4 square root of 4 is going to be a 2. Can we go back to the first one? That's 2 times 3 over 2 minus 2. This cancels that. We have that. What am I doing? We're using 3 method. Sorry, guys. Sorry. I'm still using the 3 over 2. Okay, so let's use 3 because it is 2 times 3, which is a 6. 6 minus that, which is 4 square root of 4. It's giving us a 2. Minus 2 times 3, which is a 6 square root of, that is a 6 subtract the square root of 1, which is a 1. So 1 is a correct solution. Okay. Then we move on to the next part. Solve the following equations simultaneously. This is weird. We have the log a plus 5 base 2 is equal to 3. So the quick approach is to first start with this log expression or equation. Okay. From our functions, when you're writing the inverses and what, we need to at least know how to move from log form, okay, let's say exponential. So how will this work? So it will be the same as P is equal to A to the exponent of C. So this is going to be A plus 5 is equal to 2 to the exponent of 3. We know that 2 to the exponent of 3 is 8. Then 2 to the exponent of 3 is going to be 8. And then we need to move the 5 to the, okay, I have A plus 5 is equal to 8. Move the 5 that side, which means A is a 3. So if A is a 3, then I just need to substitute where there's A back into the first equation. So this is like my equation 1, and then this is my equation 2. So I use the equation 2 to determine the A, which is a 3. Okay, so I'm just gonna write it beside 1.2. Okay, so we have A squared B squared minus 2AB minus 8 is equal to 0. Remember, A is a 3. So it's like 3 squared with a B squared minus 2 times 3 with a B minus 8 is equal to 0. So that is 9B squared minus 6B minus 8 is equal to 0. So it's your choice to either use the vectors or to use the quadratic formula. So if I try to use the vectors, what do I end up with? Okay, so in this case, is it gonna make sense? I'm gonna try to use the vectors. It's going to be 3B and 3B. You can have a 2 and I can have a 4 to give me 8. Okay, if I put a plus here, it's gonna make sense. No, that's not, that can be a plus. If I use a minus in this case, then I use a plus. That's 9. That's gonna be minus 12 plus 6 minus 6, that minus 8. So which means B is gonna be negative 2 over 3, or B is just gonna be 4 over 3. Okay, so that's what I'm getting. Our A, we say it was just a 3. And then the B is that. Okay, so that's how I would have gone about that question. I know the log might have been the deal breaker. 1.3. If P is this, for which values will this be real? So from our nature of words,
we say that the discriminant must be greater than 0 for the roots to be real. And in this case, our discriminant is basically what we are finding under the root signs. Okay. So scenario number 1, I'm going to say x plus 2 must be greater than 0. Then this gives me x being greater than 2. That is the first condition. Then when I look at the second discriminant of the 16 minus x squared is greater than 0. So I'm going to say 16 minus x squared is greater than 0. So this is a difference of 2 squares. So I can have 4 minus x, and then 4 plus x is greater than 0. So in this case, our critical values are basically plus 4 and then minus 4. So how do I represent this? Since this is a greater and my a is a negative, so I'm going to have negative 4 is less x, and then it's less than 4. So that's how I would have gone about with that question 1.3. All right, so that's question number 1. Number 2, they're telling us below is an arithmetic. So with arithmetic, remember, we have one common difference. Okay, we want us to get the value of p. So we're going to say if we have 1 minus p, 2p minus a 3, and then a p plus 5. Let's get the difference, this to be our difference 1, and then the difference 2. So difference 1 has to be the same as difference 2. Okay, so 2p minus 3, I'm subtracting, I'll say 1 minus p, must be equal to p plus 5 minus 2p minus 3. When I open this up, I have a 2p minus 3 minus 1 plus a p is equal to p plus 5 minus 2p plus a 3. This and that is a 3p minus 4. This and that, I'm having 8 minus p. I'll move the p to the left. So I have a 4p is equal to 12. Is that true? 12p is equal to 12, then divide both sides by 4. So which means p is a 3. P is a 3. I don't know, let's try substitute and see if we're going to get a, so the first term is going to be negative 2. Okay, that's negative 2. The second term, that is 6 minus 3 is 3. The third term is that which is 8. So plus 5 is that, plus 5 is that. Now I think we get to go. Okay, so p is a 3. Then they want the first term. So with the first term, just say 1 minus a 3, which is negative 2. Okay, and then the common difference, remember, it's a 5. That's a 5. We just substituted it just right now and so forth. Okay, then explain why none of the numbers in the arithmetic are perfect squares. Now, one thing we need to know is that if we look at, let's say the Tn of this thing, this sequence, it's going to be negative 2 plus n minus 1 times 5. When we open this up, we're going to have 5n. That's a minus 5 minus that with a minus 7. Okay, so this is the general Tn. Now, whenever we talk about perfect squares, these are numbers that are basically going to end with a 0, 1, 4, 5, 6, and 9. Okay, these are the numbers. Okay, in other words, perfect squares end with that set of numbers. But now, if whatever we have is being subtracted by 7, okay, it's being decreased by 7, then it's very hard for us to get a perfect square in this sense. It's very hard. Remember, the perfect squares are 1, 4, 9, and so on and so forth. Okay. So in this case, we're saying because of the -7, because when you subtract, it's either you're gonna get a 2 or n of those numbers. But you can't get a 9 when you subtract something from 7. 6, gonna be a bit hard. 5, and so on. Because for us to get a 5, number has to be ending with something like a 9 or so. Okay. Number has to be a 2 or something. So the explanation would be first get the Tn and then tell us the effect that the -7 plays on whatever number it is. Because 5 multiplied by a number, you're dealing with the multiples of 5. Okay. Now, under the multiples of 5, we know the only perfect square there is 0.5. Okay, but now if you're reducing it again by 7, then you can't get any perfect squares. 2.2, they're telling us the following forms a quadratic. Okay, so with a quadratic, we know we have two differences. They're telling us that the first difference in capital letters, the first differences of the above also forms a sequence, which is the arithmetic. Now they want us to get the expression for the general term of the first differences, which is the Tn of the arithmetic. So what we need to do, we need to determine that first difference. Okay, so -3, we have a -2, we have a -3, we have a -6, and -11. So this and that is going to give us a 1. Okay, this and that and give us -1. Okay, so subtract this and that, we get to -3. This and that, so negative that plus that, we get to -5. So when we look at this, that's a -2, a -2, and then a -2. So our common difference is -2. But then our first term is a positive one. So from the Tn formula, we know that a plus n minus 1 into d. Okay, so that's a 1 plus n minus 1 into -2. Open that up. We're gonna have -2n plus 2 plus 1. And what does that give us? -2n plus a 3. That's what I'm getting for the Tn of 2.11. Then calculate the first difference between 35th term and then the 30th term of the quadratic. Now, right from the general term that we obtained, this is what we're going to use. Remember, term number 1 of the arithmetic is between T1 and T2. Term number 2 is between T2 and T3, which means term number 35 of the arithmetic is going to be between 35 and 36. So you're going to say -2 times the 35 plus a 3. So that's -70 plus 6 plus 3, which gives us -67. Okay. Then 2.2.3, they want an expression for the nth term. So with the nth term, since we have our second difference, which shall say 2a is going to be equal to -2, divide both sides by 2, which means a is -1. Then with the 3a plus b, I'll equate it to 1, which is the first term of first differences. So if there is -1, then b is going to end up to be a 4. And then a plus b plus c must give me, what is that first term? It's -3. Okay. So now if a is -1 plus a 4, that's going to be a 3. When I move it that side, c becomes a -6. So which means my Tn in this case is going to be, remember, it's meant to be the form of an squared plus bn plus a c. So it's going to be -n squared plus 4n minus 6. Okay, so that is our Tn. And then 2.2.4 show that the sequence will never contain a positive term. So that the sequence will never contain a positive term. Okay, so with the positive term, we're seeing that these negatives are basically decreasing. They keep on decreasing and decreasing and decreasing. So if I try to get, let's say, the turning point, because we know this is the parabola that is moving that kind of shape, let me try to get the turning point. That's negative b over 2a. So negative 4 over 2a, which gives me, this is a negative 1. So negative 4 over 2 times negative 1, which gives me a 2. The turning point is at a 2. Then when I try to substitute that, plus 4 times a 2 minus a 6. Let me see, negative, but 2 squared plus, that is 8 minus 6. So my turning point is at negative 2. Okay, so if the turning point is at negative, which means this function can never go above the x-axis. So you can use this and you tell us that the turning point is 2 and negative 2, or the maximum point is negative 2. So it cannot go above the x-axis, and then it can never have a positive term. Okay, then question number 3. Question number 3. They're telling us that the sum Sn is given us 4n squared plus 1. They want us to get T6. So one thing we said under the discussion of the prediction, for as long as you're given a scenario of this nature, okay, for us to get T6, you need the sum of the first 6 terms minus the sum of the first 5 terms. So I'm just going to substitute here. So I'll say 4 into 6 squared plus 1 minus 4 into 5 squared plus a 1. Okay, let me just punch that in. 4 times 6 squared plus a 1, I'm getting 145. Okay, I'm subtracting 4 times 5 squared plus a 1, I'm getting 101. So 145 minus 101, I end up with 44. So T6 is a 44. Then 3.2, for which values of x will the following series converge? So the condition for series to converge is negative 1 is less r and less 1. Okay, so the r has to be between negative 1 and a positive 1. So what is our r from here? We can see we have 4x minus 3 and 4x minus 3 squared, which means our r is simply 4x minus 3. So let's replace this. That is r. So negative 1 is less 4x minus 3 is less 1. Let's transpose the 3 on either sides. So that's going to give me a 2 is less 4x is less a 4. Divide through by 4. Is that making sure? Divide through by 4. So if I divide through by 4, this is going to give me a half is less x is less 1. So that's what you had to do. Then 3.3. Remember, I said you have sigma notation, that is summation. Okay. So in this case, we don't even need to know what sort of pattern it is. It's not necessary, since we're only looking at term 3, or from the 3rd K up to the 5th K. Those are very few terms that we can easily add up with ease. Okay, so what we're gonna do, replace the K with 3, replace the K with the 4, replace the K with the 5, okay? So when I use 3 as an exponent, then that's gonna give me a negative 2 over 3. Plus, if I use K as a 4, the negative disappears now, becomes a positive. That's gonna be 2 over 4. And then when I use K as a 5, the negative comes back again. So I'm gonna have negative 2 over 5. So get those terms, put them in the calculator. So negative 2 over 3 plus 2 over 4 is a half, okay? Then minus 2 over 5. That is giving me negative 17 over 30. Is that true? Did I do the right thing, guys, comrades? How come I have 3, 4, 5? Let me just be short. Let me make sure. 3 plus 2 over 4. And then minus 2 over 5. The same thing, I'm getting negative 17 over 30, which is negative 0.5667. Okay, so we shall stick to that. Then question number 4. Consider the following graphs, okay? G of x, h of x. So we can see that the denominators have x in them. So all these are hyperbolas. Okay, write down the domain of G. So domain, those are x values, remember? And the only thing that affects x values is this 3 here. Okay, so we're gonna say that x is an element of real numbers. X should never be a negative 3. We change the sign there. They want the range of h. So h is this one. So range, we're saying y is an element of real numbers. Y should never be a 2, because it is this 2 that affects the range of the graph. Then 4.3. 4.3. They're telling us that if this graph of G is shifted so that it coincides with the graph of H, in other words, we want this graph of G to be just the same as the graph of H. What's going to happen? How many units must be moved horizontally? Okay. So remember, from this 3 to a negative 3, what is happening? So which means that there is a minus 6, okay? Like you subtract a 6, and then you end up with a negative 3 there. So we're going to say shift the graph, how many units? So it's saying 6 units. Which direction? To the right. Okay, because this negative is going to represent the right. And then how about the negative 3 over 2 to a 2? So if our original is at negative 3 over 2, how many units do we move to get to a 2? So that is our 0 point. These are 2 units, and then 3 over 2. So 3 over 2 plus 2, that's going to give us 7 over 2 units upwards. 7 over 2 units upwards. All right, then I'm going to have 4.4. 4.4, they're asking us for the asymptotes of G. So asymptotes of G, we're going to say x is negative 3, y is negative 3 over 2. Okay, then we're good to go. Then they want the x-intercept of G. So we know that at the x-intercept, y must be 0. So where there is G of x, I'm going to replace it with a 0 and then try to solve for x. So it's a 0. I don't know why it's a 1 mark question. So 6 over x plus 3 minus 3 over 2. Let's move the 3 over 2 that side. Is equal to 6 over x plus 3. We can do the cross multiplication. This question is like, it was just the y-intercept was going to make sense, but x. So when I cross multiply, I'm going to have 3x plus 9 is equal to 12. Move the 9 that side. 3x is equal to 3, which means x is a 1. They want the x-intercept. So it will be 1 and a 0. Okay. Then 4.6, they want me to sketch. Oh, they want me to sketch the G. So we know the intercepts and all of that. Okay, let me just sketch it here. If that is my y, yes, I'm sorry, I apologize in advance for this. That is x. Then let me try to put the asymptotes. Remember our asymptotes? We're negative 3. Is that true? Negative 3 and negative 3 over 2. So negative 3 can be somewhere here. Okay. And then the negative 3 over 2 is going to be somewhere here. 3 over 2 negative. Okay. Then we say the x is a 1. So that's a 1. And then if x is a 0, what is this thing gonna become? That's a 0, it's gonna be so that is 6 over -3, but I'm subtracting 3 over 2. I'm getting -3. Wow. Not making sense. Not making sure. Not making sure. So let's see. It's not complete sense. So did R1 make sense? 1, did you resonate with our answer? Let me see. X plus 3. I have a 1. No, the x-intercept is correct, but if I replace this with a 0, that's going to be a 2. Okay, minus 3 over 2, which gives me a half. Yes, makes sense. It's a half, which means this graph must pass through a half. I don't know, somewhere there. And then let this move, pass through. Because it's first quadrant, and then this other arm must just be drawn towards their sequence. So that's what you have to do for question number 4.6. Then they want the axis of symmetry of G with the negative gradient. So remember what we said with axis of symmetry, y is negative x plus c. So the point of intersection of their asymptotes is -3 and then -3 over 2. Let's substitute that. So -3 over 2 is equal to negative and -3 plus a c. Let's move this 3 to the left-hand side. So -3 over 2, hello, I said -3 over 2 plus a 3. That's giving me 3 over 2 again. How? Because should be making sense. Because when I replace the x, it's a negative. Okay. Did I do something wrong? Where there is y, I'm putting -3 over 2. Where there is x, I'm putting that. This is going to be positive. Yeah, it's my problem. We're subtracting. Because the positive, we're going to subtract -3 over 2 minus 3. Okay, so which means it's -9 over 2 in that case. So which means our k is -9 over 2. So that line must be moving in this sort of direction. Then for which values of x? For which values of x is J greater than the axis of symmetry? So if our line is just here in this sort of order, okay, that is our h, where do we find G to be above? So you can see that the only part that is above G is this arm. And it happens when x is greater than -3. So I'll just say x is greater than -3. Then G is reflected about the x-axis, okay. They want us to get the new equation. So when you reflect something about the x-axis, the whole y changes. In other words, this whole thing needs to be multiplied by the negative sign. So which means the y is going to be -6 over x plus 3 plus the 3 over 2. So that would be the 4.9. Okay, so guys, that's that with question number 4. Question number 5, functions. So they're telling us that f of x is given as this. So this format of the parabola is what we call the turning point method. Okay, where 7 over 2 represents the turning point and even the 81 over 4. Graphs of f and g intersect at points D and B. There we go. Let me just try to make that a bit small. Okay, so what is the first question asking for? They want the coordinates of the turning point. Wow. I'll just put it here, 5.1. So it's saying 7 over 2 positive, then 81 over 4. As simple as that, right from here. Change the sign to positive, and then you have that. Because you can even see that the turning point is on the positive x. Okay, 5.2, they want us to get the average gradient between x1 and x5. So when they ask for average gradient, we're gonna use the same gradient formula, but we need to determine the y value. So if x is a 1, okay, what is our y value? So get 1, substitute it into the f. Okay, let's do that. So we have negative brackets, take 1 minus 7 over 2 squared plus 81 over 4. I'm getting a 14. Okay, and then if x is a 5, what's our y? So if I just put a 5, I'm getting 18 as my answer. Okay, so if 18 is my answer, if 18 is our answer, let's now use this gradient formula. Let's use the gradient formula and say that m is equal to y2 minus y1 over x2 minus x1, or changing y over changing. So that's 18 minus 14 over 5 minus 1. So the gradient becomes a 1. So that is the average gradient. That's how we would have done that. Then 5.3, they want us to get the value of a, which a is the x-coordinate of d. Where is d? Let's see. So when you look at d, this is a point of intersection between f and g. So at this point, both graphs are equal. It's the same as saying f of x is the same as g of x. We solve this simultaneously. Let me just do this. So I'll have negative. And let me open this up. That's going to give me x squared. Okay. And I open that up. It's going to give me minus 7x. 7 over that is going to be 49 over 4. Plus 81 over 4 should be equal to 3x plus 24. I'm going to just regroup or simplify further. When I open this, I'll have a positive x squared plus 7x. That's a negative 49 over 4 plus 81 over 4 minus 3x minus 24 is equal to 0. Okay. So that is x squared. This and that is giving me a plus 4x. Then when I simplify these others, minus 49 over 4 plus 81 over 4. Okay, and then minus a 24. That gives me minus 16. Is equal to 0. Okay, so it's a quadratic that are again where I get two values. If I use my factors, x and x, should I use 8 and 4, 8 and 4, so 8 and 2? It's gonna make sense. If I make this negative. It's going to make sense. We do everything right. Make this a plus. This and that is minus 2. This is gonna give me a plus 6. Gonna give me a plus 6. Which means there's something I put wrong. Let me check my signs. Oh, sorry, that's a minus. That's a minus. If that's a minus, then this is a plus. Then this is a 10. And if it's a 10, I open this up. And I need to check my signs also. I need to check my signs again. Yes, yes. What's going on? What's going on? Let's go back. Let's go back and reopen this thing. I can't wait to this. Never. Let's see what we did wrong. F of x is the same as g of x. Does it make sense? Then you have to repeat the process. Repeat the process. Okay. So we're saying negative x minus 7 over 2 squared plus 81 over 4 is equal to negative 3x plus 24. If I use my FOIL, x minus 7 over 2 and x minus 7 over 2, that's going to be x squared minus 7 over 2 and 7 over 2. That's going to give me a minus 7. This and that is going to give me a positive 49 over 4. So when I open, it's going to be a negative x squared plus a 7x minus 49 over 4 plus 81 over 4 is equal to minus 3x plus a 24. Okay, let's see. It's negative x squared. Yeah, I think I see where I went wrong. That's a 10x. So minus 49 over 4. Same plus 81. Same plus 81 over 4. And then we're subtracting the 24. That's a negative 16. Is equal to 0. So when I divide through by the negative, that's where the game changer is. Yes. Got you. Okay, so that's going to be x squared minus 10x plus a 16 is equal to 0. Then we can use the 8 and 2. So x, 8, x, and the 2. Let's use the minus. So x is either 8 or x is a 2. So when I look at the 2 points where the line is meeting, you have this and then you have that. So which means D is meant to be the smaller value, which is 2. So we're going to say A is a 2. Okay, then they're telling us that point S, which is X and Y, is a point on the graph F where A, remember A is a 2. So it's between that interval of the line. Line ST is drawn. Now from the graph, determine the length ST in terms of X. So for us to get the distance between the two graphs, we need to look at which graph is on top, which is the F. And then the one that's below is G. Let's subtract both of them. Okay, so I'll use the simplified format. Okay, which is, I think it's that. Isn't it? Yeah. Just gonna say negative x squared plus 10x minus 16. That's your ST. I mean, we got it already because we said f of x minus the g of x. Don't equate it to 0. First, subtract the 2. That's what we just did here. Okay, so I don't need to redo that. Then they're asking us for the maximum. So this is just the application of calculus. For us to get maximum, we need to find the derivative. Okay, so we're going to say the first derivative is going to be negative 2x plus a 10 must be equated to 0. Take the 10 that side, so 2x is equal to negative 10, divide both sides by negative 2, x becomes 5. So that is question number 5. Question number 6, we have the exponential, which never misses. So graph below is f to x, sketch below P is that, which is a point on F. Okay, so what do they want us to do? They want the inverse. So remember inverse, you just have to use log, and then we're done. Then they want us to sketch one, the inverse. Let's start with the inverse. So we know that point Q is a 1. So that point is like 0 and 1. So when I switch it, it's going to be 1 and 0. This point P is gonna be 1 over 3 and then negative 1. So 1 over 3 somewhere, negative 1 is below. So the inverse is just gonna be something like that. Okay, I'll call that F inverse. Then they also want us to sketch the shifted inverse 2 units to the right. Okay, so if this is a 1, we shift 2 units, then that's going to be a 3. Let me use a different color for the inverse. Okay, so which means the inverse is just going to be in that format after shifting it. And then we're going to call this F negative 1, x plus 2. So that's how the graph will look like. All right, so use your graphs to solve x if the log, okay, is less than 1. So the question we need to ask ourselves, that from the original, the log 3x is less than, where do we find the inverse to be below 1? So if the inverse is below 1, remember this one is representing the y. So let me go to the original graph, okay, that says f of x is equal to 3 to the x. So if I'm looking at f of 1, that's going to be 3 to the 1, which is a 3. So if, is that true? If x is a 1, then the y is going to be a 3. Okay. But then with the inverse, if x is a 3, y is going to be a 1. Okay, that is a 1. That is x is a 3. Y is going to be 1. So if I translate this one back to here, remember I'm shifting this 3 2 units to the right. Why am I putting this as a negative? Or positive? It's meant to be negative. So 2 units, that's going to be point number 5. So 5 is going to give me a 1. So where do I find the graph of this shifted inverse below 1? I find it below 1 at a point where x is a 5. Okay. So I'm going to say that 0. Why am I saying 0? It has to be 1. Is less x is less 5, because this graph cannot pass through 1. That's going to be its asymptote. Is it an asymptote? Yeah, it's asymptote. Okay, so that's question number 6. 7, which is the finance, telling us a survey was conducted in December 2015. We determined that 5.7 million people living with HIV. Then the researchers used the model of the compound growth or exponential growth to determine that there will be 6 million people living with the disease in 2022. Calculate the percentage. So they want us to get the R. Okay. So we know that our A is going to be 6 million. Our P is just going to be 5.5 million. No, it's 5.7. Why am I sticking to the 5? It's a 7. Okay, so that's 5.7. Our N, 2022 minus 2015, that's like 7 years. Okay. Then just substitute into this formula. I have 6 is equal to 5.7 into 1 plus I to the exponent of 7. Divide both sides by 5,7, which is 20 over 19. So 20 over 19 is equal to 1 plus I to the exponent of 7. And then I find the 7th root on either sides. I get rid of that. So now I find the 7th root of 20 over 19. That gives me 1,00735 is equal to 1 plus I. Move the one that side, you're going to have 0,00 multiplied by 100. So that is giving me our I of 0,7. Let's say 35% if I'm rounding it up to 3 decimals. Yeah, that's what I get. Then if it's 2, then it's 0.74%. 7.2, they're telling us that Shimi invests 4 million into an account that is earning 6% per annum compounded monthly. She withdraws 30,000 rands per month. So the first withdrawal is exactly 1 month after she posted the money. How many withdrawals of 30,000 are we going to make? So with this kind of question, we're going to use the present value. Why? Because this one is more like her. Okay, she's taking it out. More like a loan that she's kind of paying back to herself. So we're going to use the P as our 4 million. Our X is 30,000. Our I is 6%. They want us to get the N. Okay. So I'm going to, I have space on the, so I'm going to use this page and write down the present value formula. That is X into 1 minus 1 plus I to the exponent of negative N over R. So we said 4 million, okay, is equal to our X, which is 30,000 into 1 plus the I, which is said 6%. That we compounding it monthly. That's yes, to the exponent of negative A over 6% over 12. So step number 1, I'm just going to multiply and divide both sides by the 30,000. Okay, so when I do that, I'll have 400 over 3. And then I'm going to multiply by the 6% over 12. I'll be just left with this bracket. 1 plus, let me just write that to the negative. Okay, so that we say we're multiplying by 6% over 12. That gives us 12 over 3 is equal to 1 plus. When I simplify that small bracket to 6% over 12, I'm getting 1,005 to the negative N. So move the one that side. Move the one that side. So 12 over 3, I'm subtracting the 1. That's giving me negative a third. When I move this one that side, negative a third is equal to 1,005 to the exponent of negative N. And then I'll introduce my logs. Okay, so the log of negative third is equal to negative N, the log of 1,005. Alternatively, I can just make this as a base so that I have log. Okay, of the same base 1,005, and then I have my negative 1 over 3 is equal to negative N. So divide both sides, so negative N is equal to negative a third over the log of 1,005. Okay, we should get a negative answer, 1,005. Using the second alternative. Okay. I'm getting right doing everything correct with this. Because this is not giving me let's see. This is log and negative 1 over the something wrong because I'm getting imaginary numbers. So I need to go back. I need to go back. I need to go back. Something is off. Refresh that. No. So 400 over. Let's see, 4 million divided by 30,000. 400 over 3. I'm multiplying it by 6% over 12, which is 12 over 3. Okay, let's see. Okay, so the present value is x into 1 minus 1 plus I to the exponent negative n. So it's saying 4 million is equal to the 30,000 into 1 minus 1 plus the 6% over 12 to the negative n. I'm dividing this by 6% over 12. So divide that. I'll have the 400 over 3. When I multiply this by 6% over 12, give me 1 minus 1,005 to the exponent of negative n. Okay, so that's a 2 over 3 minus 1 is giving me negative 1,005 to the exponent of negative n. Okay, so this should give me negative a third is equal to negative 1,005 to the exponent of negative n. Then that's going to give me a positive. So 1 over 3 is equal to 1,005 to the negative n. And then I'll introduce my logs. Okay, so I'll just say negative n is the log of 1,005 into 1 over 3. Okay, when I substitute that, 1,005, this is 1 over 3. That's giving me negative 220,27, which means we have 220 payments that this lady is going to be able to get. Okay, so the question said, how many withdrawals? Okay, so looking at the question, we have just 220 withdrawals. Then the question goes on to say, how many withdrawals will she be able to make if now she changes to 20,000 rands? I must show the calculations. Okay, so still from the present, it's x into 1 minus 1 plus I to the exponent of negative n over I. So 4 million is equal to now 20,000 into 1 minus 1 plus the 6% over 12 to the negative n over 6% over 12. Okay, so 4 million divided by 20,000 is giving me 200. Let me just multiply this by 6% over 12. It's 1 minus, we say that was 1,005 to the negative 10. Okay, so 6% over 12. So that gives me a 1. Let's see, 6% over 12 times divide with the correct answer. 400. That's giving me 1 is equal to 1 minus 1,005 to the exponent of negative n. Okay. So that's a 0. 0 is going to give me negative answer. We don't have anything like a negative 0. So log that, 1,005 to the exponent of negative n. Now, when I introduce my logs, I'll just say the log of 1,005 will be 0. So my fixed point makes sense. Let's see, 1,005. And then there's a 0 there. Something is off again. Something is off again. What did we do wrong? Because now when I substitute that 4 million divided by the 20,000, I get the 200, which is fine. When I multiply that by the 6 over 12, giving me, and that's a 0. So when I substitute that, I'm just getting an infinity. Okay. So how many withdrawals will she able to make if she changes the amount withdrawn per month to 20,000? So what does that infinity mean? Does that mean that this lady will be withdrawing money indefinitely? Would it mean something like that? I don't know. But that is what I'll go. Okay, so with question 7.3, they're telling us that this person opened a savings account with a single deposit of 1,000 on the 1st of April. You should then next 18 monthly deposits of 700 at the end of every month. So half past payment is on the 30th for the 700. So we have 700 and then also have 1,000, which is a once off. Okay, once off, and then this is continuous. Okay, the amount earns within percent per annum compounded monthly, determine the amount that should be in the account immediately after her last deposit on the 30th. So 30th September and 30th April, those are 18 months, they told us. Then for how long the 1,000 gonna be grown to? So what I'm going to do, we'll have a lump sum of 1,000, and then we also have these continuous payments, the future. So we're gonna use the future value for the 700, then we're gonna use the normal compound formula for the 1,000. So A is equal to P into 1 plus I to the exponent of N. So that's 1,000 into 1 plus 15%. Okay, so I'm going to look at it as 15 over 100, but remember it's compounded monthly. So let me just say 15%. Okay, let's say 15% over 12 with the exponent of 18. Okay, with this I must add the future value. So the future value formula will be 700 into 1 plus, let me just make this a big bracket, 1 plus the I, 15% over 12. Okay, to the exponent of 18 minus 1. Everything is over 15% over 12. And I punch this into the calculator. Just I want to break it bit by bit. Let me just do it at once.
Come on. Okay, so 1,000. That's 15% over 12 with exponent of 18 plus 700 into that's 1 plus 15% over 12. We're using 18 months again. Subtract 1 over 15% over 12. Let's close this. So that's giving me 15,282.9. Guys, that's what I'm having. Then 8.1. 8.1, they are telling us we must derive from first principles. Okay, we have 3x squared minus 6. Let me just write it aside. Remember, f of x is 3x squared minus 6. So from the formula of limit as h tends to 0, f of x plus h minus f of x over h. So my f of x plus h is going to be 3 into x plus h squared minus 6. I'm subtracting 3x squared minus 6 over h. The limit as h tends to 0. Then I need to open up the bracket. Then, so when I open this bracket, I'll say the limit as h tends to 0. 3 into x squared plus 2xh plus x squared minus a 6 minus 3x squared plus 6. I'm dividing it by h. So then the limit as h tends to 0, I'll have 3x squared plus 6xh plus 3x squared minus the 6, okay, minus 3x squared plus a 6 over h. Then I need to cancel things out. I need to cancel that and that. Then this minus 6 goes with the plus 6. Then my next step has to be factorizing out the h. So limit as h tends to 0, I have 6x plus 3h over h. So this cancels that, and then I replace h with a 0, which means my answer becomes a 6x. So that is done. Okay. Then with this, we have f of x, and then they want us to find the derivative. So we need to open up the brackets there first. So it's like 2 root x minus 1 over x times 2 root x minus 1 over x. We FOIL it, this and that. That's going to give me 4x. I multiply this and that. I'll have a minus 2 root x over x minus, when I multiply that, 2 root x over x. Then that and that, I'll have 1 minus x squared. Okay, so that reduces to 4x minus, when I add that, I have 4 root x over x plus 1 over x squared. When I simplify, get rid of the root sign, remember root sign is exponent a half. So that is 4x. That is going to give me 4x to the negative a half. When I take this up, I'll have x to the negative 2. And then I can now find my f prime, which is the first derivative. So that's going to be a 4. This and that is going to give me a plus 2x, or subtract 1, which is a minus 3 over 2. And that's going to be minus 2x to the negative 3. So this becomes my first derivative. Then 8.3. They're asking me for which values. Okay, so they want us to get the interval for which this graph is concave up. So for us to have a graph that is concave up, the second derivative has to be greater than 0. Second derivative has to be greater than 0. Let me just put it aside. So we're gonna have something like Our f of x is 3x cubed minus 3x squared plus 6x minus 2. So my first derivative is going to be 9x squared minus 6x plus a 6. And then my second derivative, which is going to be 18x minus 6, we say it must be greater than 0. Okay. Then let's move the 6 aside and make x the subject. So 18x must be greater than 6, which means x must be greater than that when you divide both sides by 18. So guys, that's how question number 8 would have been worked out. Let's look at question number 9. It's telling us that sketched below is the graph of the first derivative of this function. This is the original. Points A, B, and C are the intercepts of the inverse with the axis. Okay, then they want us to get the coordinates of A. Now the coordinates of A, let's first find the first derivative. Probably we shall get that. So we have, that's going to be negative 6x squared minus 6x plus a 12. Okay, so this graph here is represented by that function. So we know that A is the x-intercept, sorry, the y-intercept. And at the y-intercept, our x must be a 0. So when you substitute x with a 0, you're going to be left with just a 12. So which means that the coordinates of A are just 0 and 12. Okay, then they want us to get the coordinates of B and C. Now, if we're given the first derivative, okay, the points B and C will be like the turning points, but let's just use this first derivative and solve it. So negative 6x squared minus 6x plus 12, I'm going to equate it to 0. Since I'm talking about B and C, which is the x-intercept, y is a 0. I'm going to divide through by negative 6. I'll have x squared plus x minus 2 is equal to 0. When I open up my brackets, I'll have x, I have a 1 and a 2. If I make this a negative, I'll end up with a positive there, is equal to 0. So which means x is negative 2, or x is a positive 1. Okay, so now they wanted the coordinates of B. So we can see that B is on the far end of the negatives. So B is going to be negative 2, 0, and then C is going to be the 1 and 0. Then 9.1.3, which points on the graph will have exactly the same x values as B and C. So remember we said these points, the x-intercepts of the first derivative, will represent the turning points. So which points? I'm just going to say the turning points. Okay, so sometimes the turning points can also be called the minimum and then the maximum points. The local maximum and the local minimum. Then for which values of x will the graph be increasing? Remember now they're talking about the original f. Now we know that for a graph to be increasing, okay, so let me just look at my original graph. It's a negative a. So with a negative a, the original shape is something like that. And we said the turning point here is a 1, turning point here is a negative 2. Okay, so between this area, that's where we're seeing the graph to be increasing. But otherwise, it is decreasing in all the other aspects. So we're going to say that negative 2 is less x and then less 1. Then determine the y-coordinate of the point of inflection. So remember we said point of inflection represents the second derivative. Okay, so I'm going to say, can either find the second derivative directly or I can look at these points and find the midpoint of them. So I can say negative 2 plus 1 divided by 2. It's going to give me negative a half. This is going to be my x-coordinate of the point of inflection. Then I'll get this and substitute it into the f. So our f was negative 2x cubed minus 3x plus 12x plus a 20. So I'm replacing x with negative a half. So negative 2 into negative a half cubed minus 3 into negative a half plus 12 into negative a half plus a 20. Okay, I'm getting, what are we getting? So negative 2 times negative 0.5 cubed, okay, minus 3 into negative 0.5 squared. Yes, it's a square, thank you. So we square that. And then plus 12 into negative 0.5. Okay. And then plus 20. What gives me 27 over 2. So the answer they need here is a 27 over 2, or just a 13.5. Would make sense. The 9.2. 9.2, 9.2, 9.2. They're telling us that a tangent at P, which is 3 and negative 10 to this curve, okay, intersects the x-axis at a point R. Then line PT is drawn perpendicular to the x-axis with this and determine the length RT. So for me to interpret this question, let me just try to refresh my page so that I get space to that. Okay, so when I look at the graph Y, okay, this graph of mine, that's a parabola. Okay, which parabola is having a front face and passing through -1. If I was just to sketch it. They're telling me point P is a 3 and -10. Let me take this to be a P. They're telling me it's a tangent. Okay, if that's a tangent, they're telling me to intersect the y-axis at point R. Okay, then a line PT is drawn. PT. There is a line there, which is PT drawn perpendicular to the x-axis with T on the x. So that is a T, that's a 90. Okay, so if this is a 3 and -10, which means this point T is also a 3 and a 0. What do they want? They want me to determine the length RT. So for me to get RT, I need to find the coordinates of R. For me to get the coordinates of R, I need the equation of PR. So I'll start by finding the y dx, okay, which is going to be -2x. Okay, so now this -2x is the equation of the gradient at any point on this curve. But then if x is 3, okay, so I'll say if y prime of 3 is -2 times 3, which means the gradient is -6 at this point P. Then I'm going to use the point 3 and -10 and find the equation of the tangent. So I'll say y minus -10 is equal to -6 into x minus 3. I'll open up y plus 10 is equal to -6x plus 18, which means y is -6x plus 8. That is my equation of the tangent. Now, if that is the equation of the tangent, I need to find the R, which is the x-intercept. So for x-intercept, y is a 0. I'll replace y with a 0, -6x plus 8. I'll move the 6 that side, is equal to 8, divide both sides by 6, which means my x is just going to be a 4/3. So if that is a 4/3, and then this is a 3, they want us to get the distance. So for that distance, you just need to subtract since it's on the x-axis. So I'll say 3 minus 4/3. So that gives me 5/3 units. Okay, we said 3 minus 4/3, which is 5/3 units. So that is question number 9. Question number 10. Question number 10, the profit that was earned by a company that makes bicycles per week is given as that. What should be the weekly bicycle production be to maximize? So they want us to get the value of X where the profit is maximum. Okay, so this is under optimization. We need to find the first derivative. So that's going to be -3/150 x squared plus 6x minus a 250. I need to equate this to 0 and solve for x. So if I multiply through by 150, I'll have -3x squared plus 6 times 150 is going to give me a 900x, and then 250 times 150 gives me 37,500 is equal to 0. You can divide through by -3, so x squared plus, that's minus, since we're dividing through by a negative. Okay, so that's a minus. 3 divided by that, which is a 300x. And then this divide by 3, I'm getting 12,500. Okay, 12,500 is equal to 0. Then I can gladly use my quadratic formula. Okay, so x is equal to -b plus minus square root of b squared minus 4ac divided by 2a. So our b is a -300. So negative 300 will be a positive. Plus minus, that is 300 squared minus 4. Our a is a 1. Our c is a 12,500. Okay. So when I just substitute that into the quadratic formula, so minus 300 with x plus 12,500, what am I getting? I'm ending up with x to be a 50. So that is 2 times 1. So x is either 50 or x is a 250. Then I need to substitute these values back into the original to see what answers I get if I can make a decision on which x to take. So in this case, if I substitute a 50, okay, so if I get my 50, I'm just gonna say W50 is gonna give me a negative answer, which is 8533,33. And then if I use 250, I'm gonna end up with 4.8. According to the calculator, I'm having 4.8. So we can see that from the 250 is giving us a bigger profit. So which means this company must produce 250 bicycles every week. Okay, question 11. Okay, so question 11, probability, they're telling us that the machine A and machine B, they are coin pressing machines that operate at the same time. Okay, probability of A only is X, that's correct. Probability of B only is 0.3, probability that both take the same time 0.1, and there's a Y. Then they're telling us that if A and B are independent. Now, one thing we know about independent events is that the product, okay, so in this case, we shall say probability of A times the probability of B must give us the intersection, which is 0.1. Okay, let me just jot it on that other side. Let me write it beside. So we say probability of A times probability of B must give us 0.1. But when we look at our question, our A is going to be the whole of that circle, which is x plus 0.1. And then our B is going to be the combination of the intersection of that, which is 0.1
4. So then when I substitute that, we say 0, 1 plus x. We're multiplying this by 0, 4. It must give us 0, 1. Open up this 0, 1 and that, I'm getting, what we get? 0, 0, 4. And then 0, 4x is equal to 0, 1. When I move the 0, 0, 4 that side, I have 0, 4x is equal to 0, 0, 6. It's 0, 1 minus 0, 0, 4. 0, 0, 6. Then I will divide both sides by 0, 4 over 0, 4, which means x is going to give me 0, 1, 5. And then when you look at y in this Venn diagram, if you get y, if you get all of this, you must get a 1. So I'm just going to add up everything and equate it to 1 for me to end up with the value of y. Okay. So our x is 0, 15 plus the 0, 1 plus the 0, 3 plus the y should give us a 1. So this is a 0, 4, 0, 55 plus the y should be a 1. And then move the 0, 55 to the other side. And then y is going to be 0, 45. So that is 11.121. Then they want us to determine the probability that exactly one of the machines is pressing the coins. Exactly one of the machines. So remember, our x was 0,015, 0,15. And then the b alone is 0,3. So we just add the two. 0,15 plus the 0,3, that gives us 0,45. And then 11.2. 11.2. Let me just take this out. They're telling us that Wilson takes a driver's test. The probability that he will succeed on his first attempt is 3/7. Okay, so if I try to use a tree diagram, this is 3/7. This is going to be 4/7. Because remember, we must end up with 1. So this is a pass, that's a fail. And then they're asking us for the probability that he will succeed after 2 attempts. So if this is the first attempt, the second attempt for him to succeed, because they told us that for each attempt he reduces, the probability increases to 3/5. So which means for him to pass, it's 3/5. And then for him to fail, it's going to be 2/5. And then if he fails the first test, for him to pass, it's going to be a 3/5. And then this is going to be a 2/5. So now for us to get the probability of passing after 2 attempts, we either look at the pass and the pass, or the fail and the pass. So this is a pass, that's a fail. So I'll be having 3/7 times the 3/5 plus the 4/7 times the 3/5. Okay, so when I simplify that, you say 3/5 times that is giving us 17/35. 17/35 for the first part. And then the probability that you will succeed after 3 attempts. Okay, so with 3 attempts, which means we have 3 options to look at, or 3 different ways. So which means if our tree diagram is to continue, pass or fail, pass or fail, pass or fail, pass or fail. So passing, 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 and passing. So it's 4 different options. Okay, so if you follow the branches, because the 3/5 and the 2/5 will remain. 3/5, 2/5, 3/5, 2/5, and so on. So which means I'm getting a 0.6 if I combine all of that. Then question number 12. They're telling us that this lady turned 8. Her friends, 1, 2, 3, 4, 5, 6. So altogether, they are 7 people. They're invited to a birthday party. This person and the friends sat in a row and played a game. In how many ways can they be seated if they sit in alphabetical orders? Remember, they are 7. Okay, we can arrange alphabetically 7.
but then I'm just going to multiply this by 2, since they said it's alphabetical order. So it's possible for you to start with the ascending or the descending part. So that is 14 for me. And then 12.1.2, they want us to get the probability that this lady and that lady do not want to sit together. Okay, so if they were to sit in any order, this would be the number of combinations or number of ways that we can arrange them, which is 50, 40. I'm not going to use the 14. Okay. Then for Emily and Clara to sit together, because now that's what I want to use. If they were to sit together, okay, then I'll be looking at 6 factorial times the 2 factorial, because there will be 6 ways to arrange them, and then these two can easily switch. Okay. Now, what is the probability of them sitting together? Okay, probability of sitting together is going to be 6 factorial times 2 factorial over the 7 factorial. Now, the probability of not sitting together, I'll just say 1 minus the 6 factorial times 2 factorial over the 7 factorial. When I put this into the calculator, 1 minus, say 6 factorial times 2 factorial over the 7 factorial. I'm getting 5 over 7 as my probability. If there's any other options or ways to do that, please in the comment section. 12.2. 12.2, they're telling us that the probability that a team wins or the team has all its players fit is 70%. And the probability that they win a game if all the players are fit is 90%. When they are not fit, probability of winning is 45, the probability of them winning the first game. So this is still more like a tree diagram. I prefer to use a tree diagram in this kind of question because it's kind of easier for me to see. So let me start by drawing the first branch. It's either the team is fit or it is not fit. If it's fit, they either win or they lose. If they are not fit, they'll either win or they lose. So 70%. Okay, so this is going to be 70%. So if they are fit for 7%, then the 30 is going to be for unfit. And then if they are fit, 90% will be winning. This will be a 10%. And then if they are unfit, probability of winning is 45. Okay, then this is going to be a 55. The outcomes are either fit and winning, fit and losing, not fit and winning, it's still possible, and then not fit, and then they lose. So they want us to get the probability of winning the first game. So which means it's either they are fit and winning or not fit and winning. Just that. So what we're going to do, I'll get my first probability of them being fit, which they said 70%. I'm going to change it to a decimal, which is 0.7, times them winning 0.9. Plus, when they are not fit, it's going to be a 0.3, and then winning is a 45%. So I'm going to say 0.3 times the 0.45. Then when I simplify this, 0.7 times 0.9 plus 0.3 times 0.45. I'm ending up with a 0.765, or it can be 76.5% that they will win the first game. So guys, that is that with paper 1. If there are any corrections, remember the memorandum is not yet out, but we can use this. Okay, so if there are any amendments that need to be made, please do advise. Thank you very much. Let's meet in paper 2. Hello, welcome to this episode where we shall be looking at the mathematics paper 1 for Houghton, September 2023. Okay, so question number 1, we have 2x plus 1 squared minus 4 is equal to 1. So my quick way of doing this would have been moving the 4 to the right.
that I have 2x plus 1 is equal to 4. Then I find square roots. Okay, so the square root will kill this the 2. Then I have plus minus the 2. I remove the 1 to the right, so 2x is equal to plus minus 2 minus 1, and divide through by 2. Okay, so my x, the first one, will be a plus 2 minus 1. That's going to be 1 over 2. Or if I use the negative side, negative 2 minus 1, that's negative 3 over 2. So those are the two solutions that we need for question number 1.1.1. Then 1.1.2, we need to create a standard equation. So I'll have 4x squared plus 12x minus 11 is equal to 0. Now, whenever they ask us to give our answers to decimal places, we definitely have to use the quadratic formula. Okay. Now, when you look at the quadratic formula, we're going to be having 4x squared minus 11. Okay, we say plus 12x is equal to 0. So that's 4x squared plus 12x minus 11 is equal to 0. So our A is a 4, our B is a 12, and then our C is negative 11. When we substitute, we know that x is equal to negative b plus minus square root of b squared minus 4ac divided by 2a. So our b is at negative 12, so our b is at 12, so we substitute with negative 12. And this is 12 squared minus 4. The a is a 4, this is negative 11 over 2 times 4. You have the right to simplify whatever is under the root sign and then get the answer. So my first x value is going to be negative 3.74, or x can be 0.74. So those are the two values that we expected. All right. Then when we move on, 1.1.3 is the inequality question. So create the standard. So it's going to be negative 9x squared plus 15x minus a 4 is less than 0. I'm moving the 9x to the left. Then I can divide through by negative just to make sure that this is a positive. So I'm going to have 9x squared minus 15x plus a 4. The inequality symbol must change now to greater. Okay, then from there, I can just open my brackets. Okay, I'll have 3x. This is 3x. Since this is a negative, sorry, it's a positive, I'll have 4 and 1. If I use negatives, I have a positive 4. This is a negative 3 and a negative 12 being 15. So that's fine. So my critical values are going to be 4 over 3, or basically a third. Now, since my inequality has switched to greater, so even my representation of the values or the solutions is going to change. So my solutions are going to be x has to be less than 1 over 3, or x is greater than 4 over 3. So that's how I represent it. For people that want to draw the, what do you call it? The parabolas, you can quickly do that, and you have something like that. And then you have the 1 over 3, and then the 4 over 3 aside. Okay, so 1.1.4. 1.1.4. So 1.1.4, I'm seeing the square roots. But we have two expressions or two terms that have the root signs, which is kind of a bit tricky. But it's fine. Let me write this side. I think I'm going to need quite a lot of space. So the question says the square root of 2x minus 2 minus the square root of 7 minus 2x is equal to 1. Okay. So what I can start with, I can square both sides since the root signs have already been isolated. Okay. It's more like having any square brackets, a minus b squared. I can apply the FOIL. So I'll say this squared and then that squared. So this multiplied by that, the root sign is going to fall out. Then, remember when I'm opening this, I'll have a 2ab summary. So I'll have a minus 2, and then these two multiplied together. Okay, so when I multiply these two together, since they both have the root signs, it's as good as me having 2x minus 2, and then 7 minus 2x. And then lastly, for the last part squared, I'll have plus 7 minus 2x is equal to a 1. Okay. And then from there, what do I need to do? I need to open up my brackets. This has to be under the root sign. Because I'm multiplying both of them. Okay, so when I open this, I'm going to have 2x. Now let me just cancel this and I cancel that. This 7 and this 2, I'll have a 5. Minus 2, the root of, let me open this up, 2x and 7. I'm going to have 14x. This and that, I'll have minus 4x squared. That and that is minus 14. This and this is plus 4x is equal to 1. Okay. And then what do I need? Let me move the 5 to that side so that I have negative 2 with the root and simplify what is there. So this and that is going to give me 18x minus 4x squared minus 14 is equal to negative 4. I can square both sides so that I get rid of the root again. Okay. So the root goes, but these two have takes the negative 2. I'll end up with just a 4 into negative 4x squared plus 18x minus 14 is equal to 16. Divide both sides by 4. So over 4, then over 4. I have negative 4x squared plus 18x minus 14. We can move this one actually that side. The result we get, so which is a minus 1 is equal to 0. Negative x squared plus 18x minus 18 is equal to 0. Okay, can divide through by negative 2. But I have 2x squared minus 9x. I divide through by negative 2. I'll get a positive 9 is equal to 0. Okay. Then from here, I can do the factors. Okay, so if that is a 2x, this is going to be x. And I can use the raise minus sign since my product here is a positive. So either my x is going to be a 3 over 2, or my x is going to be a 3. Okay, so that's what I'm getting. But then remember, with such questions, you always need to test the left-hand side and then the right-hand side. So let's say I have my 2x minus 2. I'm subtracting the square root of 7 minus 2x is equal to 1. So I'm going to test with each of these numbers on the left and on the right, and see whether I get the same thing as that which is on the right. Okay, so if I use 3 over 2, if I put a 3 over 2 here, I'm just going to have 3 minus 2, which will give me 1. Then minus, if I put a 3 over 2 here, that's going to be 7 minus 3. which is a 4. Square root of 4 is going to be a 2. The 1 minus 2 gives me -1, which is not a 1. So I can take this solution out. It's not applicable. Let me try with the 3. That's going to be 2 times 3, which is a 6. 6 minus that is a 2. Now 6 minus 2 is a 4. Square root of 4 is a 2. 7 minus 3, 2 times 3 over 2. That is 7 minus 4, which is a... What is going on? I do a minus 2. Let's see. We know that 7 minus something is not right. It's 7 minus 2x. So if this is a 3, it's saying 2 times 3 over 2. That's a -3, which is a +4. And then 4 square root of 4 is going to be a 2. Can we go back to the first one? That's 2 times 3 over 2 minus 2. This cancels that. We have that. What am I doing? We're using 3 here. Sorry, guys. Sorry. I'm still using the 3 over 2. Okay, so let's use 3. Because it is 2 times 3, which is a 6. 6 minus that, which is 4 square root of 4. It's giving us a 2. Minus 2 minus 2 times 3, which is a 6 square root of, that is a 6, subtract the square root of 1, which is a 1. So 1 is a correct solution. Okay. Then we move on to the next part. Solve the following equations simultaneously. This is weird. We have the log a plus 5 base 2 is equal to 3. So the quick approach is to first start with this log expression or equation. Okay. From our functions, when you're writing the inverses and what, we need to at least know how to move from log form, okay, let's say exponential. So how would this work? So it will be the same as P is equal to A to the exponent of C. So this is going to be A plus 5 is equal to 2 to the exponent of 3. We know that 2 to the exponent of 3 is 8. Then 2 to the exponent of 3 is going to be 8. And then we need to move the 5 to the, okay, I have A plus 5 is equal to 8. Move the 5 that side, which means A is a 3. So if A is a 3, then I just need to substitute where there's A back into the first equation. So this is like my equation 1, and then this is my equation 2. So I use the equation 2 to determine the A, which is a 3. Okay, so I'm just gonna write it beside 1.2. Okay, so we have A squared B squared minus 2AB minus 8 is equal to 0. Remember, A is a 3. So it's like 3 squared with a B squared minus 2 times 3 with a B minus 8 is equal to 0. So that is 9B squared minus 6B minus 8 is equal to 0. So it's your choice to either use the vectors or to use the quadratic formula. So if I try to use the vectors, what do I end up with? Okay, so in this case, is it an axis? I'm going to try to use the vectors. It's going to be 3B and 3B. You can have a 2 and I can have a 4 to give me 8. Okay, if I put a plus here,
It's gonna make sense now. That's not that can be a plus. If I use a minus in this case, then I use a plus. That's 9. That's gonna be minus 12 plus 6 minus 6, that minus 8. So which means B is gonna be negative 2 over 3, or B is just gonna be 4 over 3. Okay, so that's what I'm getting. Our A, we say it was just a 3. And then the B is that. Okay, so that's how I would have gone about that question. I know the log might have been the deal breaker. 1.3. If P is this, for which values will this be real? So from our nature of roots, we say that the discriminant must be greater than 0 for the roots to be real. And in this case, our discriminant is basically what we are finding under the root signs. Okay. So scenario number 1, I'm going to say x plus 2 must be greater than 0. Then this gives me x being greater than 2. That is the first condition. Then when I look at the second discriminant of the 16 minus x squared is greater than 0. So I'm going to say 16 minus x squared is greater than 0. So this is a difference of 2 squares. So I can have 4 minus x, and then 4 plus x is greater than 0. So in this case, our critical values are basically plus 4 and then minus 4. So how do I represent this? Since this is a greater and my A is a negative, so I'm going to have negative 4 is less x, and then it's less than 4. So that's how I would have gone about with that question, 1.3. All right, so that's question number 1. Number 2, they're telling us below is an arithmetic. So with arithmetic, remember, we have one common difference. Okay, we want us to get the value of P. So we're going to say, if we have 1 minus P, 2P minus a 3, and then a P plus 5. Let's get the difference, this to be our difference 1, and then the difference 2. So difference 1 has to be the same as difference 2. Okay, so 2P minus 3, I'm subtracting, I'll say 1 minus P. Must be equal to P plus 5 minus 2P minus 3. When I open this up, I have a 2P minus 3 minus 1 plus a P is equal to P plus 5 minus 2P plus a 3. This and that is a 3P minus 4. This and that, I'm having 8 minus P. I'll move the P to the left. So I have a 4P is equal to 12. Is that true? 12P is equal to 12, then divide both sides by 4. So which means P is a 3. P is a 3. I don't know, let's try substitute and see if we're gonna get a, so the first term is going to be negative 2. Okay, that's negative 2. The second term, that is 6 minus 3 is 3. The third term is that which is 8. So plus 5 is that, plus 5 is that. Now I think we get to go. Okay, so P is a 3. Then they want the first term. So with the first term, just say 1 minus a 3, which is negative 2. Okay, and then the common difference, remember, it's a 5. That's a 5. We just substituted it just right now. And so, okay, then explain why none of the numbers in the arithmetic are perfect squares. Now, one thing we need to know is that if we look at, let's say the Tn of this thing, this sequence, it's going to be negative 2 plus n minus 1 times 5. When we open this up, we're going to have 5n. That's a minus 5 minus that.
with the -7. Okay, so this is the general TN. Now, whenever we talk about perfect squares, these are numbers that are basically gonna end with a 0, 1, 4, 5, 6, and 9. Okay, these are the numbers. Okay, in other words, perfect squares end with that set of numbers. But now, if whatever we have in is being subtracted by 7, okay, it's being decreased by 7, then it's very hard for us to get a perfect square in this sense. It's very hard. Remember, the perfect squares are 1, 4, 9, and so on and so forth. Okay. So in this case, we're saying because of the -7, because when you subtract, it's either you're gonna get a 2 or n of those numbers. But you can't get a 9 when you subtract something from 7. 6, gonna be a bit hard. 5, and so on. Because for us to get a 5, number has to be ending with something like a 9 or so. Okay. Number has to be a 2 or something. So the explanation would be first get the Tn and then tell us the effect that the -7 plays on whatever number it is. Because 5 multiplied by a number, you're dealing with the multiples of 5. Okay. Now, under the multiples of 5, we know the only perfect square there is 0.5. Okay, but now if you're reducing it again by 7, then you can't get any perfect squares. 2.2, they're telling us the following forms a quadratic. Okay, so with a quadratic, we know we have two differences. They're telling us that the first difference in capital letters, the first differences of the above also forms a sequence, which is the arithmetic. Now they want us to get the expression for the general term of the first differences, which is the Tn of the arithmetic. So what we need to do, we need to determine that first difference. Okay, so -3, we have a -2, we have a -3, we have a -6, and -11. So this and that is going to give us a 1. Okay, this and that and give us -1. Okay, so subtract this and that, we get to -3. This and that, so negative that plus that, we get to -5. So when we look at this, that's a -2, a -2, and then a -2. So our common difference is -2, but then our first term is a positive 1. So from the Tn formula, we know that a plus n minus 1 into d. Okay, so that's a 1 plus n minus 1 into -2. Open that up, we're gonna have -2n plus 2 plus 1. And what does that give us? -2n plus a 3. That's what I'm getting for the Tn of 2.11. Then calculate the first difference between 35th term and then the 30th term of the quadratic. Now, right from the general term that we obtained, this is what we're going to use. Remember, term number 1 of the arithmetic is between T1 and T2. Term number 2 is between T2 and T3, which means a term number 35 of the arithmetic is going to be between 35 and 36. So you're going to say -2 times the 35 plus a 3. So that's -70 plus 6 plus 3, which gives us -67. Okay. Then 2.3, they want an expression for the nth term. So with the nth term, since we have our second difference, which shall say 2a is going to be equal to -2, divide both sides by 2, which means a is -1. Then with the 3a plus b, I'll equate it to 1, which is the first term of first differences. So if there is -1, then b is going to end up to be a 4. And then a plus b plus c must give me, what is that first term? It's -3. Okay.
So now if A is -1 plus a 4, that's going to be a 3. When I move it that side, C becomes a -6. So which means my Tn in this case is going to be, remember, it's meant to be in the form of an squared plus bn plus a c. So it's going to be -n squared plus 4n minus 6. Okay, so that is our Tn. And then 2.2.4 show that the sequence will never contain a positive term. So that the sequence will never contain a positive term. Okay, so with the positive term, we're seeing that these negatives are basically decreasing. They keep on decreasing and decreasing and decreasing. So if I try to get, let's say, the turning point, because we know this is a parabola that is moving that kind of shape. Let me try to get the turning point. That's negative b over 2a. So negative 4 over 2a, which gives me, this is a negative 1. So negative 4 over 2 times -1, which gives me a 2. The turning point is at a 2. Then when I try to substitute that, plus 4 times a 2 minus a 6. Let me see, negative but 2 squared plus, that is 8 minus 6. So my turning point is at -2. Okay, so if the turning point is at negative, which means this function can never go above the x-axis. So you can use this and you tell us that the turning point is 2 and -2, or the maximum point is -2. So it cannot go above the x-axis, and then it can never have a positive term. Okay, then question number 3. Question number 3. They're telling us that the sum Sn is given us 4n squared plus 1. They want us to get T6. So one thing we said under the discussion of the prediction, for as long as you're given a scenario of this nature, okay, for us to get T6, you need the sum of the first 6 terms minus the sum of the first 5 terms. So I'm just going to substitute here. So I'll say 4 into 6 squared plus 1 minus 4 into 5 squared plus a 1. Okay, let me just count that thing. 4 times 6 squared plus a 1, I'm getting 145. Okay, I'm subtracting 4 times 5 squared plus a 1, I'm getting 101. So 145 minus 101, I end up with 44. So T6 is a 44. Then 3.2, for which values of x will the following series converge? So the condition for series to converge is -1 less r less 1. Okay, so the r has to be between -1 and a +1. So what is our r from here? We can see we have 4x minus 3 and 4x minus 3 squared, which means our r is simply 4x minus 3. So let's replace this. That is r. So -1 is less 4x minus 3 is less 1. Let's transpose the 3 on either sides. So that's going to give me a 2 is less 4x is less a 4. Divide through by 4. Is that making sure? Divide through by 4. So if I divide through by 4, this is going to give me a half is less x is less 1. So that's what you had to do. Then 3.3. Remember I said you have sigma notation, that is an issue. Okay. So in this case, we don't even need to know what sort of pattern it is. It's not necessary, since we're only looking at term 3, or from the 3rd K up to the 5th K. Those are very few terms that we can easily add up with ease. Okay, so what we're gonna do, replace the K with the 3, replace the K with the 4, replace the K with the 5, okay?
So when I use 3 as an exponent, then that's going to give me a negative 2 over 3. Plus, if I use k as a 4, the negative disappears now, it becomes a positive. That's going to be 2 over 4. And then when I use k as a 5, the negative comes back again. So I'm going to have negative 2 over 5. So get those terms, put them in the calculator. There's algebra. We're going to have equations, inequalities, and that is question number 1. And then we're going to have number patterns, or sometimes we call it series and sequences. Then we're going to have functions and graphs. We're going to have some questions on finance, growth and decay. Then we have differential calculus, and then we have the counting principles or the probability. So the paper will be out of 150 marks. Okay, and then the time is 180 minutes, which is roughly 3 hours, which means 1 mark approximately for 1 minute. So the mark allocation is that question 1 carries basically plus minus 25 marks. No? Then the next question of the topic, number pattern sequence series, usually carries 2 questions, which is plus minus and 25 marks and 5 marks. Then for the functions and graphs, plus minus 35 marks. Then finance will cater for 15 plus minus, and then calculus plus minus 35, and then probability is plus minus 15. So that we have a total of 150 marks. So what are the expectations? Okay, what are the expectations in all of this? So let's see, I'll just break it down and start with algebra, which is more like question number 1. Okay, so when you look at this, under algebra, they're telling us that we're going to be solving quadratic equations, which is true, but we're not going to use the difference of 2 squares. Okay, we're not going to use the difference of 2 squares. So what are we going to be using? We're going to be using all the other methods of factorization and the quadratic formula. Remember, the quadratic formula is obtained from the completing of squares. So we don't need the completing of squares, which is the long approach, but rather we use the simplified approach. Okay. Quadratic formula can be found on the back page of the paper. So this is out. Our main focus is just the factorization of factors and then the quadratic formula. Okay, then you need to solve quadratic equations using the substitution of the K method. This is examinable. It's possible that it can come where you have maybe an equation with a bigger exponent other than 2. Maybe x to the 4, probably x to the 6, and so on and so forth. So when you use the K method, you let K be maybe x squared, so that you just replace that and then you solve it. Then equations involving sides, these are the square roots that lead to quadratic equations. These are examinable, and we need to pay attention to this, especially when you're giving your answers. We always encourage people to test their values afterwards. Okay, solutions of non-quadratic inequalities. This can be asked under the functions, and then the nature of roots can also be asked under the functions sometimes. Let's just have a look at just an example of question 1. Okay, here we go. Solve for x, correct 2 decimal places. So in most cases, when they tell you 2 decimal places, they would expect you to use a quadratic formula, but it's up to you anyway. So you can choose the factors where you feel you can get the factors, and where you can't get the factors, just use the quadratic formula. But if you're a person that just specializes in the quadratic formula, please stick to that. What we need is the marks. Ne? So this, just get your A, your B, and your C values, substitute in the quadratic formula, or get the factors and then get the answers for x. Then for the second part, create the standard form first. So it's 3x squared. Okay, what's happening? I say 3x squared minus 17x. Okay, plus 8 is equal to 0. And then you can go on to solve. And then with the inequalities, you need to pay attention to the A value, okay? Whereby if the A is positive, and then the symbol of the inequality is greater or equal to, then your solutions must be X is less than the smaller value, X is greater than the big value, okay? And then if the A is positive, and then the inequality is less or equal to, then the small value is less or equal to X, less or equal to the big value. So just pay attention to the sign and the direction. Okay, 1.2, these are exponents. So with exponents, just make sure that the bases are the same. Since these are exponential equations, make sure the bases are the same. Express a 4 in a base of 2. In this case, they just want you to show that. Then simultaneous equations, remember, we always have a linear equation, okay? Which you call maybe equation 1, and then you call this equation 2, and then you just do the substitution. That is to do with the simultaneous equations. They carry quite a lot of maths. So and so on and so forth. So that would be question number 1. Then let's look at this other one. Probably let's just snip into it and see how a question 1 would look like. Okay, here we go. So in this case where you have brackets and then they're asking you to solve for X, we don't necessarily have to open up the brackets. Just use the dot product where X minus 7 is equal to 0 or X plus 4 is equal to 0, and then solve the values. Or alternatively, just get these numbers and then switch the signs. So X is 7 and X is negative or something like that. Then in this case, where the question comes with a condition of 2 decimal places, that is the quadratic formula. Then 1.1.3, where we say the sides. You know, you square both sides, get the values, get a quadratic, and get your answers. Then those answers, we need to test them on the left-hand side of the original expression, and then on the right-hand side. So if we get a scenario whereby we get the same answers on the left and on the right, then that value will be a solution. And then if we get an answer that does not give us the same value on the left and the right, we just cancel it out. Or you can just say not applicable or no solution, something of the sort. 1.1.4, create a standard solution or the standard equation. You move the 4 that side and then you solve that. For 1.2, it's a simultaneous equation, a 3x, a y, 5, and all of that. So we have the linear and then we have the quadratic equation. So start with the linear, manipulate it around, make one of the variables the subject. So you can leave y on one side, move the x that side, and then you get that y, substitute into there. Then 1.3, calculate. So the square root with these exponents. So in such a case, break down the bases to just the smallest base, and then do the factorization since we have a plus. So when you have a plus or a minus with exponents, factorization is always a must. So that is how the question 1 would look like. Okay, then I'm moving on to the second part, which is normally the sequences and series, number patterns. So number patterns, sequences, and series. So what they tell us that the sequence of the first difference of a quadratic is always a linear pattern. Therefore, knowledge of linear patterns can be tested in the context of what we call the quadratic patterns. Then recursive patterns, we're not going to ask you about that. Then we must link between the patterns that were done in earlier grades. And so remember, guys, that when we talk about number patterns, we have what we call the arithmetic, okay? We have the geometric, and then we have the quadratic. What is important with all the 3 is that we need to know what their TNs are, the nth terms, okay? The a plus n minus 1 into d, the AR n minus 1, and then the AN squares, the BN, and then the C. So all these need to be known, whereby A represents the first term for the first 2, and then N is the position, and then D, in this case, is the common difference. In this case, R becomes the common ratio. Okay. Then when you're dealing with, let's say, the quadratic, we need to remember the 2A the 3a plus b, the a plus b plus c. We need to use those expressions. Then okay, so the other thing that we need to remember is also the sum. Okay, we need to know our formulas. Sum of an arithmetic is n over 2 into 2a plus n minus 1 into d. For the geometric, we need to know that it is a into 1 minus r to the exponent of n over 1 minus r. And then lastly, we need to know the sum to infinity, a over 1 minus r. So this we need to know, and how to apply them is also important. Then the other thing about the sums is, let's say you're given the sum of maybe n squared plus n. The sum of any pattern or sequence or series is given as n squared plus n. Then they ask you to use this to determine, let's say, the pattern itself. And so we know that S1, that will be the sum of the first term, is always equal to T1. Replace n with a 1. You're going to have something like 1 squared is 1 plus 1, that's a 2. Then for us to get S2, the sum of the first two terms, that will be 2 squared, 4 plus 2, that's a 6. So what I need us to know is the link between the sum of the terms and then the term themselves. What this means that for us to get, let's say, the second term, you must get the sum of the first two terms minus the sum of the first term. For us to get T3, we shall get the sum of the first three terms minus the sum of the first two. But what we know is that T1 is equal to S1. Okay, so what this means is that T of n is equal to S of n minus S of n minus 1. For us to get term 3, you must get the sum of the first 3 minus the sum of the first 2. So this is also possible. Okay, so we have the sums to infinity, arithmetic, geometric, and all of that. So R is the common ratio, A is the first term, and then we're good to go. Okay, so that is how these geometric patterns and series can be asked. But then we also have what we call the converging series. Okay, converging series. We need to know this as well. So for series to converge, there is a condition that -1 must be less than R, must be less than 1. In other words, the ratio must be between the intervals. But in most cases, the ratio that is given is in terms of other variables, maybe P, X, and so on. And then we need to work that out. So if let's say we have 2x minus 1 as our common ratio, if we put it within this interval, and then we solve for the x, you move the -1 to either sides, it's going to be a plus 2 that side. And then this side is going to be a 0, is less than 2x. Divide through by 2, 0 is less than x, and then is less than, let's say, 1. So this is the interval within which that sequence, that imaginary sequence of ours will converge when R, or when the common ratio is between those values. So that we need to remember. So that is to converge. That means the series will just become smaller, smaller, and narrower. Okay. But then for series to become bigger or to diverge, which means your R has to be greater than this one. If this was a number, maybe a 4, then R has to be greater than 4 for that sequence to diverge or become bigger. All right, so that is what we need to know with the sequences and with the series. Let's just snip into the papers and we see. Okay, we have this, which I didn't mention. Thank you very much. It's here, sigma notation. So sigma notation means just the sum or the summation. For you to work around with the sigma notation, you need to first of all determine the type of sequence it is. Is it arithmetic, geometric, or quadratic, depending. Okay, we can do that by just substituting this 3 into this, the 4 into that, and then the 5, because the sigma notation is telling us that n must start at 3 and must end at 20. So after getting those terms and determining whether it's arithmetic or geometric, so let me assume this is arithmetic. Okay, I'll have to get my A, and then I'll have to get my D, and then bring in the sum of the arithmetic, which is n over 2 into 2A plus n minus 1 into D, and then do the substitution. How do I get the number of terms? I will get my last term where I'm ending, which is a 20, minus the starting point, which is a 3, and then I'll have to plus a 1. So in this case, our n will be something like 18, and then I'll use n as 18, and then apply all of that. Remember, it's a T2 over T1, or T3 over T2. That's how we get the common ratio, not the other way around. Same applies with the differences. When you're getting the differences, the T2 minus T1, which is the same as a T3 minus T2, just between consecutive terms. Okay, so in this case, our ratio would be 3x minus 1. Okay, then they're asking for which values of x. They're not asking for r. Of x is the series going to converge. Then bring in that condition. -1 is less r and less 1. And then get this r, replace it, and then make x the subject in that case. Then sum to infinity, we know the formula a over 1 minus r. So after doing your substitution of x as a half, you'll get your first term. You replace x as a half, you get your T2. And then get this a, and then between the two, get the common ratio. You can just get x, substitute it here, and then you have your common ratio. And then work the question out. So that is one question. Okay, there's another one here. We have 2x12 and y. They're telling us their first 4 terms of a quadratic. Sometimes they'll tell you what sort of sequence it is. So if it's a quadratic, just know that we have 2 differences that are involved. Okay, so 2, we have x, we have 12, and then we have y. So this and this is going to give us our first difference. But then they're telling us that the second difference that we're going to have here must be equated to a 6, according to the information given. So whatever we get here is a 6, and then whatever we have here must also be a 6. So in that way, we shall be able to solve x and y. And one other thing that we need to remember is that it's also possible for simultaneous equations to be brought just in the format of sequences and series. Okay, that was just one paper. Let's look at the other one. Okay, so with this one, they're telling us we have a quadratic. Okay, there we go. So we can get the first difference, which is maybe 18 minus 5, which is a 13, 37 minus that. I don't know. Is it a 9? 29? 19? Okay, someone is saying 19. And then you subtract that and you have your first difference. And then within the first difference, you get your second difference, and then you determine the Tn. So here, whatever we get for the second difference is the 2a. This 13 is going to represent the 3a plus the b. Okay, and then the a plus b plus c must be a 5. So 2a is equal to what's 19 minus that? It's a 6, something like that. And then you solve that. Whatever we get for a, we substitute it there. The a and the b we have, put it there. Then we got our terms, a, b, and c. Then determine the number of terms. Now, for you to get the number of terms, you should have been given the last term, the Tn. So where there is Tn, we're going to put 557. We have our a, we have our b, we have our c. Then we solve for n. Remember, when you're looking for n under sequences and series, your n should never be negative. And then your n should never be a fraction, because we're talking of a position. Positions are countable, okay? So in that case, not a negative, not a fraction. If ever we get a negative fraction, we discard those values and just focus on the others. And 2.2, we have 10x, y, and so on, the first 4 terms of an arithmetic. So follow the rules of arithmetic. There's just one difference. You just subtract x minus 10. That will be the first difference. And then we have y minus x. That will be another. And then negative 14 minus y will be another. Then These differences have to be the same since it is arithmetic, it's constant. Then equate this. And then also equate that. So it will be more like a mini simultaneous. You get X, then you get Y. 2.3, just the same thing, determine the sum. So it's arithmetic, use the sum for arithmetic. And then the mth term of a sequence of arithmetic is K, the kth term is M, determine the common difference. So in this case, use the TNs, since they say the mth term, the kth term of what? Of an arithmetic. Use the TN of an arithmetic, and then we're good to go. All right, so we move on. So that is sequences and series or number patterns. Ne? The next we have what we call the functions. I'll just go up a bit. Functions. We need to know and use and interpret the functional notation, okay? When teaching the process, people must know how f of x will be transformed. Remember we said f of x will be the same as the g of x, will be the same as the h of x, the same as y itself. Ne? So when you have f of x, but then it has turned out to be f of negative x, this is a reflection about the y-axis, okay? Then if it is in this format where it's negative f of x, it's a reflection about the x-axis. Then if we have f of x plus a, this is a shift. In other words, the graph has been moved some units. So it's a units. If it's positive, it's going to be to the left. And then if it's a negative a, it's units to the right. A units to the right. And then if we have f of x and then plus a, which a represents any number, this a is going to represent a shift, which is vertical. Okay, the graph is being moved up or down, and so on and so forth. So trig functions, these can only be found within paper 2. Now, with the functions, we need to remember we have different types of functions and we need to pay attention to all of them because most of them are examinable. Okay, an example, I'll start with the first one, which is maybe the exponential. This one is common, it's always there. With exponential, the exponent is x, probably plus a q. This q represents the asymptote. We need to remember that. Okay, we need to know at least how to determine the domain. The domain, you don't need to stress. X is a set of real numbers or an element of real numbers. Problem is the range. Range, these are y values. So y values are always affected by the asymptote. Okay, always y is greater than the asymptote. Then we need to know when is the exponential increasing or decreasing. We need to go over that because sometimes they can ask you to do the sketch. Then we also need to understand how to determine the inverses, okay? Most cases, it can be of an exponential function. So the shape is usually in that sort of format. So remember that. That is to do with exponential. Then 2, we have the parabolas. Parabolas always have to be with another graph in most cases, either parabola and a straight line, parabola with exponential, or parabola with a hyperbola. Okay, so that is x squared plus bx plus c. It's a cubic function. We also have ax plus p squared and then plus q, where p and q represent the turning point. And then we also have a into x minus x1 into x minus x2, where x1 and x2, these are intercepts. Okay, the points where the graph is cutting axis. And then we also have the is less than the hyperbolas. Hyperbolas. So if the denominator is having x involved, né? So a over x plus maybe p plus q. So with the hyperbola, the asymptotes, we can say x is going to be a positive. Say it's a positive, then x is going to be a negative. These are asymptotes, guys. Okay. So having obtained the asymptote, we need to know. And remember 2 arms, whereby if a is greater than 0, we expect the arms to be in that format. And then if the a is less than 0, okay, we expect the arms to be in the second and all of that. Okay, they're telling us this is a tangent of f. But with this tangent, we can see that the gradient is derivative of f equate it to -2. So for x, get the value substituted back into the original. Look at question number 5. We have the is showing the inverse. Please pay attention to that. And then you just need to know that with the inverse and the original, we just switch everything around. What is x becomes y, what is y becomes x. 1 point for which both graphs will pass. Remember, this is f, it's not the g. So just switch these points, 1 and 4, or 2 and 16. Then equation of f, for you to get, whenever you're looking for unknowns of any function, you need a set of points. Okay, if there are 2 unknowns, then you're gonna need as well. Okay, that is one paper. That formula, we just need to know it by our heads, by ourselves, okay? And then you work out that. So the ends are either gonna be compounding periods of monthly, where it's a 12, quarterly, which is a 4, half yearly, which is a 2. Sometimes half yearly is known as semi-annual. I saw a question that talked about weekly. Okay? How many weeks are there in a year? It's 52, no? Not 54. 52 weeks. That okay. Then with the exception of calculating I, okay, they're not going to ask you for I under annuities. But all the other variables, the X, the N, all of them, they can be examined. Okay, so F represents the future value. Okay, and then P represents the present value. To calculate the value of any other variables. Pyramid schemes, they're not going to look at them. So when they talk of finance, we need to know, number one, when you talk of, let's say, growth, then you use the compound formula, 1 plus I to the exponent of n. When we talk about decay, we have different types of decay. Number one, we have what we call the reducing balance.